So if the tournament takes in $100, you can't award $1,000. And then there's also the thought of having a percentage-based system. And that's a nicety. So that would look like something like where you award the first place player 50% of the overall take. So if the tournament brings in $100, first place gets $50. But if the tournament takes in $50, the first place gets $25. That way, it's dependent on how a tournament does. Because again, remember, these tournaments, in theory, could be less than full. So in a 16-player tournament, we may only have 10 players, which means that we have 6 people not paying those 6 bye weeks or bye players. In that case, if you were basing your cash prizes on a $160 income, $10 per person, you'd only be bringing in $100. That'd be a problem. Now notice that it doesn't say we have to divide up everything to the winners. One use case for this could be where we do some kind of fundraising. Say we're going to, kind of like a 50-50 drawing or something like that, where we're going to have this tournament. We're anticipating bringing in $200. The top prize is going to get $50. Second place is going to get $25. And the third place is also going to get $25. And then, so that's half the money. And the other half would go towards Toys for Tots or whatever. So we could do that in this existing system, or we could divide everything up, or the tournament owner, the guy that's running the tournament, could just be taking his cut. So he says, I'll give out half of the overall income of the tournament. I'll pocket the other half as my fee for running the tournament. Who knows? It's important to think through those ideas, but we don't have to go so far down the rabbit hole that our whole application changes. We should just think through, would this fit these different scenarios that are possible or probable? And if we're not sure and something will change our application, we should talk to our stakeholders. All right, question number 11. What type of reporting is needed? Well, the answer is a simple report specifying the outcome of the games per round, as well as a report that specifies who won and how much they won. I'm assuming that the how much they won and who won would be at the end of the overall tournament. These reports can be just displayed on a form, or they can be emailed to tournament competitors and the administrator. So the idea is, we don't have a full robust reporting system with PDFs and layouts and all the rest of the stuff. Instead, what we have is either we just display on a form and say, here's the daily status, or we could be emailing the competitors and the administrator these updates. The round report as well as the end report of who won and how much. All right, question 12. Who can fill in the results of a game? The answer is great for us. It makes it simple. Anyone using the application should be able to fill in the game scores. That means we don't have to have this varying level of access or have this whole way of creating users to use our system and having passwords and all the rest. We just have to say, if you're using the application, you have rights to. And of course, the next question is, are there varying levels of access? And the answer would be no, because we're allowing everyone to do everything. But here's the kicker. We could say that competitors, or the administrator could say, competitors are not allowed into the application. And instead, they do everything via email. Now remember, this is a desktop application. This could reside on the administrator's desktop and not anybody else's. Which means that if they don't have access to the desktop of the administrator, they don't have access to the tournament. Which is actually kind of a two-level system. One level just gets emails. The other level is the one that has full control. So in theory, it could be We wouldn't call it a two-level system just because we're not doing any kind of varying level of access inside the application. All right, question number 14. Should this system contact users about upcoming games? And the answer is yes. The system should email users. And that's about the third or fourth time that email has come up. We're going to have to make sure that we know how to send or at least send emails from this system. So if I were taking notes, that'd be a big one that I write down, star, underline, and put a big arrow to. Make sure you know how to do email. So the system should email users that are due to play in a round as well as who is scheduled to play. So every player who's actually playing the current round will get an email saying, you're playing game number 3. It's Tim versus Bob. And that's probably about it. Maybe some details that the administrator sets up about options or when and where, those kind of things. But this is going to be an email that goes out automatically and not manually. So we can't have we can't have specific answers to where and when. But instead we have to rely on generic options or generic text to tell them that. Finally, question 15. Is each player on their own, or can teams use this tournament tracker? And the answer is the tournament tracker should be able to handle the addition of other members. All members should be treated as equal in that they can all get tournament emails. Teams should also be able to name their team. So the idea here is we're not going to pick a team captain. We're not going to say that all information goes through one person. If you're on a 5-person team, all 5 people get the same email saying, here's your game for this week or this round. Also, we're going to call that team something. You really don't want to refer to a team as Tim, Bob, Sue, and Mary's team. You want to refer to it as Team Snicker Bars, whatever. That's actually probably more information than a stakeholder normally would give you, unless they're really in tune with how to give information to developers. But I simulated here the idea of maybe I went back and forth a couple times until I finally got this full answer. Again, the real world is kind of messy, and communication is a very difficult thing to do well. The key here is to learn to ask better and better questions so that users understand what you need, and also to go back and get more information and kind of really dig deep on your general question or your first question in order to get the information you really need. So those are the answers to the 15 questions that we had. So now we have the initial requirements, and we have the answers to our 15 questions, which really give us more requirements. And so now we can move on to the big picture design. And the big picture design is where we look back at a high level at our application and say, okay, what should this in general look like? To use an example, if we were to design a picture, draw out a picture of an ocean with a sunset over it, the big picture idea for that would be we're going to need some tan for the sand, we're going to need some blues and some greens for the ocean, the sky, we're going to need some reds for the sun and probably have some birds in there, and maybe some washed up flotsam on the shore. That's a big picture look at that painting. There's a whole lot more detail that would go into it in the future, but for right now, that gives you a good rough outline of this is what we're going to kind of do. In the same way with our application, we're going to develop that big picture view that doesn't get really specific on anything, but it gives us those initial guardrails or boundaries for how we're going to design this application. The first broad brushstroke of our application is the structure. In our case, the structure is going to be a Windows Forms application and a class library. And I point that out whenever I build an application. I try very hard to put all of my code, or at least my models, into a class library. But I want to point that out very clearly here, because we have to think back and say, oh wait, the Windows Forms application should not be our complete application, because we want to take that off at some point and put something different on top. If we have all of our code behind the forms, that's not going to work. Now, it's not great application design anyway, but I want to specify here just to make sure that we have that brushstroke in place. Okay, the next one is data. In that case, we're going to look at SQL and or a text file for storing information. What that data looks like, or how it's being designed, or if we use one text file or 20, all those questions we're not really going to answer here. That'll be when we dive deeper later. But for now, we just know we need SQL and text file storage. Next is users. And what this represents is who's going to use our application and when. In our case, it's very, very simple. It's awesome. One at a time on one application. We're not looking to have 50 users using different applications that all point to the back to the same SQL database or text file. We don't have 18 different levels of security and all this authentication system going on. We just have one user at one time on one application. So that's the broad overview of our application. It seems very, very simplistic, but it's actually really important that you identify this, because it puts some boundaries around you. Now, those boundaries are pretty broad. You can do a lot inside these. But what it does do is it keeps you from saying, well, maybe I should make this user interface a web application. Nope, it's a Windows Forms application. Well, maybe I should just go ahead and design an app now. Nope, Windows Form application. Well, maybe I should just store the information in memory. Nope, SQL and text file. See, all those questions that you might think down the road or might start wandering down that path, you can say, nope, these are my boundaries. And we'll make these boundaries even tighter as we go. But for right now, it's a great place for us to start before we start laying out our more detailed plan. Now, the other thing I like to do at this point is identify the big concepts in this application that I might not know everything about. So let's look at these key concepts for our application. Email. How do we email from C#? I'm going to have to figure that out at some point. So I have to keep that back in my mind. Maybe I should learn about that before I go on, or maybe I should do some research and do a trial app to make sure I understand how to do that and what the best way of doing that is. In our case, we don't have to do this kind of stuff because we're going to walk through it as we go, and I do know how to do these concepts. But again, I just want to simulate the idea of real world. In the real world, this is exactly what I do. I identify my key concepts, and I say, I need to build a small demo application to make sure I understand this, not to have the code then to plop in later, but to have the idea of how it works so that my design takes those kind of things into account. All right, so email is one. SQL. It's pretty important we know how to access our data. Next is one you might have missed, and that's custom events. And the reason I said that we need to understand custom events is because I started thinking about the application. I'm still in big picture mode here, but I'm thinking when one game is complete and it's the last game in the round, how are we going to know to check to make sure there's no more games? And how are we going to know if there are no more games to move to the next round? And how are we going to know to trigger those emails that go out saying, here is the overview of round one, here's what happened? And that sounded an awful lot like custom events. And so I said, you know what? I think it's custom events. I'm not going to lock into that right now, but I probably should at least learn a little bit about them so that I know how to use them if I need to. The bonus here is if you learn a little bit about them and kind of brush up on them, even if you knew something about them before, but you're just kind of rusty, if you know more about them before you then go into further planning steps, you'll know if they're a good fit, and you'll know kind of how they're going to fit in there in your design. And the more information you know up front, the better your application will be in the long run. The next key concept is error handling. We're going to need to take in information from the user. We really shouldn't trust the users to give us the right information all the time. So we need to have some type of error handling in place to scrub that data, to prompt them to give us better data, and to make sure that we don't have any problems as we go. So error handling is important. Interfaces is another key concept. And this is one that if you're like, what are interfaces? Don't worry, we'll get there. But I know from experience of building this type of application that it's going to be kind of important to know how to use interfaces, because we're going to use those to pass information back and forth from form to form. Also, random ordering. We've mentioned 4 or 5 times in the answers to our questions the idea of random. We have it's random who gets what in what order. It's random who gets a buy for the first week if there is one. And so this idea of random or randomizing information is going to be important. And we'll have to look at randomizing in a couple different ways. Maybe we have to figure out random numbers, or maybe it's just how you shuffle a list in a random way. And really shuffling a list is random numbers kind of stepped up a notch. So we'll need to keep that idea in our minds. And this last concept is one that really wasn't mentioned in our requirements anywhere, but it's an idea that I have for a possible add-in or a possible bonus upgrade for this software, and that's the idea of texting. We alert people via email about upcoming games and when games are done and when rounds are done and when the whole tournament is done. Maybe some users are going to want to have their notifications texted to them as well. It's not something that's going to change our application as far as structurally. Really all it is we're going to add this on top. So when we capture their first name and last name and email address in order to email them, we'll also capture their phone number. And then maybe we'll put something in place where they can have the option of getting a text as well, or we'll have some other mechanism in place to determine should we send a text. But that's really a bonus or an extra. It's not something that's really a part of our requirements. And it's okay to have these bonus ideas as long as they don't affect the overall application. If this were to change how we do things, for example, if I had to capture now a team captain instead of just capturing team members, that would be a problem because that was something specified in the requirements. So I'd need to go back to the stakeholders and say, do you want this, and this is what it will take, or this is what it will do to one of your other requirements. But if it's something that's really just an add-on or extra, that might be something you could plan to do or even do if you're pretty confident the customer or the stakeholder would want it. One area that can be important or even really helpful to you is if you are in business especially a small business, where you're building something for someone that it's not quite as defined as maybe a big company might define an application. It's really just this loose structure like this one was. Maybe it's nice to give them a little something extra so that they see that you're not only hitting your goal for the application, which is the goal would be to meet all the requirements, but that you're going above and beyond. But the key here is to know when to do this and when not to do this. It's definitely not a good idea to do something like this if you're not going to meet your deadline. In fact, I would say do everything else first, and if you have time, make it better. And this could be one way to make it better. So that's really it. We've covered all of our questions and the answers we got back from our stakeholders. And out of that, we built one big set of requirements. And from that, we were able to develop this big picture design. We were also able to develop these key concepts that we might need to go out and research to understand better. Now, normally, if I were doing this in the workplace environment and I was unsure of something in my key concepts list, this is where I'd go out and start researching that. But again, we're simulating as though we know all of these because I'm going to teach you all of these. So therefore, we can kind of skip that step. Welcome to lesson number 3 in the C# from start to finish course. We're looking at data design. Now, we've already set up the boundaries for our application, the requirements that drive how the application gets built. And we've kind of built a little bit of a structure, but now we're going to take those requirements and build an actual data structure. Now, at this point, some people may say, I've seen it done differently in other lessons. I've seen some people design the front end first and then develop the data later. And that's true. Some people like to design how the application looks first, and then from that, it helps them decide what to do with data. I've done that before, but I've found the best success for me comes when I design the data first. And here's why. Your application is nothing without data. In fact, your application is just a vehicle to display, manipulate, change, and save data. Now think about that for a minute, because at first it sounds wrong. So start thinking through some examples. Let's start with something simple. Let's look at a text editor. Think of maybe Microsoft Word even. What's its job? Well, it all revolves around the text on the page. Whether it is which items are bolded, which items are underlined, the spacing, and all the rest, all of that is data, and it all revolves around that data that you give it. And maybe right now you're saying, okay, sure, line up business applications, the basic applications, would use data a lot, and they're kind of centered around data. But certain applications aren't. For example, a game. A game is not based around data. Well, really, yes, it is. Let's take, for example, chess. Chess is all data. You've got pieces in certain locations. So you have what the piece is, what it can do, and where it's located. Then you have the game board and where each piece is in relation to each other on that game board. And then you have the moves and where the pieces go. That's all data. And sure, that's chess, but if we look at a more complex or a larger example, say a first-person shooter game, how can that possibly be data? Well, you have to know where your character is and where every other character is, the system does, in order to know when you shoot a bullet, first of all, where it's going to go, that's data. How fast it's going to get there, that's data. And when it gets there, who it's going to hit, if anybody. If it hits somebody, how much damage does it do, that's data. You start seeing all the data that goes on behind the scenes sometimes, but still is fundamental to the application. It's all about that data. Again, looking at that first-person shooter game, what's the end result you want to see? A victory. How do you determine victory? Based upon the data that says, all my foes have been conquered. So data is very important. And that's why I start with my data. I will often find that it's easier to develop my front-end user interface once I have my data, because I see what needs to be done, and then it's just a matter of how I accomplish that instead of just drawing from a blank slate with no information. All right, so that's enough theory. let's get into actually mapping out our data. Now, typically I draw this out on a legal pad or my whiteboard, and both are great ways to visualize what needs to happen, and at the same time, they're quick to change. Now, that's kind of hard for me to show you on video, so instead I'm going to kind of fast forward to when I'm done my design, but I'll walk you through it step by step. So when I do this development, there's a lot of scratch this out, move this around, erase this, draw a line through this, move this over here, because developing on paper is so easy to make changes. I would encourage you, and I started this course by saying, don't open Visual Studio yet. Do this development of the plan in Notepad, in your scratch pad, in a legal pad, on your whiteboard. Don't do it inside of code or inside of Visual Studio. And that still holds true here. I'm just going to show you the cleaned up end result of all that planning. And I'll walk you through some of the questions that I had, the thoughts that I had along the way. So this is really where I start, the blank page. And really, this can be intimidating at first because you don't know, where do I start? What's the best place to start? And the answer is really just put something down. And so I said, well, let's start with team. I know I need to have some kind of team that has people in it and has a team name and all the rest. So I started with team. And I said, on that team, we're going to have members. Now in parens, I put, this is the type that I think we're going to need to have. So I said, probably a list of type person. I don't have a person list yet. And maybe at that point, I pause and say, create a person list. But my focus is on, let's just get the team built first. Now, the other thing here is I don't typically put types in until after I've come back through. But in this case, I'm showing you the end product. And so I put the types in there. But really what you want to do is you want to get all the information about a team down first before you do anything else. Don't worry about types for now, but do a second pass. After you got all the data in place, do a second pass and assign types to each one, just so you make sure you understand how this whole thing is going to work. Again, since I didn't have a type person yet, I'd make a note of that, but not actually develop the person class or the person group of information yet, because I'm focusing on team. If I leave team to build person, I might forget where I was in team and miss a key component. So always focus on one thing at a time. Everything else gets written down for later. So I have members. So that would be the number of people on a team, which could be one person. It's a one-person team, say for our ping pong tournament, or it could be 5 people, say for a basketball team, or it could be 20 people, maybe for some kind of office game. It doesn't really matter. What really matters is that we have that list that can have really 0 or more, but in our case, we kind of want to force it to have at least one person on the team. The team name. We know that each team has to have a name in order to call it something better than Tim, Bob, Mary, Sue. Oh, that might be a great team name. Who knows? And that'd be a string. So that's really all the team class is. So let's move on to person. Since we created this list of person, let's go ahead and now create that person object so we get that out of our mind too. We have a first name, which is a string. That's pretty straightforward. A last name, also a string. We could have asked for just name and had first and last name together, but I find that breaking that apart into 2 different properties or 2 different data points is, first of all, best practice in the industry, meaning the industry does this by default or does this most of the time, but also it makes it a whole lot easier for us to do things like have an email where it says, Dear Tim. It seems more personal that way instead of Dear Tim Corey. So breaking it apart into 2 different objects and having the user break that apart is very important. You could say, well, I know how to break a string apart based on the space. Therefore, Tim Corey could be in that variable. I could break it apart and say the first part is the first name, the second part is the last name, which only works when a person only has one space in their full name. What if, for example, they said they had a last name that has space in it? Van space Wilder is the last name, Van Wilder. Well, that would come out as split apart. That's a problem. Wilder is not the last name. It's Van Wilder. First name is Joey. The same thing is true for first name. Maybe the first name is Mary Sue. Well, if the first name truly is Mary Sue, or they put Mary Sue as their first name, Mary Sue Smith, if we broke that apart, we'd say the first name is Mary, not Mary Sue. So breaking things apart can get ugly really quickly. Instead of breaking things apart later, you can put them together later. And that also allows you to do interesting things like last name, first name, or first initial, last name. Okay, let's look at the next property, email address. So we need to capture the person's email address, and that's also a string, and cell phone number. And that too is a string, and that trips some people up here. The idea that right in the name, cell phone number, and yet we're not saving it as some type of number, whether it's an int or a double or anything like that. We're storing it as a string. And the reason why is because we don't treat a cell phone number as if it were a number itself. So for example, the number, we can add to that, we can subtract from it, we can divide it, we can multiply it. But doing that to a cell phone number doesn't make sense. We wouldn't add 2 to a cell phone number for any reason. The cell phone number is what it is and it never changes. Also, we might want to store some type of formatting. For example, around the area code in the United States, we put parentheses, then we put a space, and then after the first 3 numbers of the actual phone number, we put a dash, and then the last 4. Well, you can't really do that and store it that way. And you might say, well, yeah, but I'll store it as just numbers. Well, that's great, but it still doesn't get past the idea of this isn't really a number to be manipulated. So we're going to store it as a string. Now, you may have caught me saying a couple times properties. And I want to stop for a minute and point that out. Really what we're doing here is we're creating our classes. So a team is going to be a class, person will be a class, and inside those classes will be these properties. Now, it's not a direct one-to-one matchup right now because, for example, cell phone number. I might change that to cell phone or phone number or something like that. But it's a pretty close matchup. Now, there may be other classes we create, but these are really our foundational classes on which the application gets built. These 2 plus the others we'll talk about in a minute. And I don't want you to get too caught up in the idea of code, but I do want you to be thinking about the fact that really these do map up pretty directly to classes, which is why I call these items properties. So just keep that in the back of your mind. When it comes to actually building our class library, having our data mapped out like this makes creating our foundation of our class library so very easy. Okay, back to our data. Our third class, or our third set of data, we'll call tournament. And this is all the data that surrounds the actual tournament, which is what this entire application is based upon. This is a tournament tracker. So this is going to be the central data hub, or a central bit that everything revolves around. So the first thing we need is a tournament name. Now that's not specified anywhere in the requirements, but we do mention the idea that there might be more than one tournament at a time. And so if there's more than one tournament, how do you know which tournament is which? You could look at who's playing in them and what round they're in and all the other details, but really that's so imprecise. So instead, we're going to specify that every tournament be given a name. That way you could say ping pong tournament, basketball tournament, and then you know exactly which tournament you're talking about. Next, we'll have an entry fee. Remember we talked about the idea that we could accept fees, or we could say that every person or every team needs to turn in a fee? Well, this entry fee is going to allow the administrator, the person that sets up a tournament, to say, there is an entry fee to this tournament, and it's $10 or whatever it is. And then every time we add a team to the tournament, we're going to charge that team the entry fee. So that would be of type decimal. And that's something else to point out. We'll get into more of the C# after we're actually inside Visual Studio. But for now, I just want to point out that because this is money, this entry fee, we should store it in type decimal, not double. On the surface, these 2 data types look very, very similar, decimal and double. They both store numbers that have a decimal point in them. The difference is precision. Decimal is very, very precise, but it also takes up a lot more memory. And so we typically only use this when we're talking about money. Double is a little less precise, But if you look at the actual precision, we're still precise to about, I believe it's 14 decimal places or 14 places after the decimal. That's good enough for me. But in the case of money, we really should have decimal. Okay, I mentioned that the entry fee is going to be charged, if there is one, to every team that enters the tournament, which means we have to have a list of teams in the tournament, or I called it entered teams, teams that have entered the tournament. And that would be a list of type team. The great thing here is when we're developing this tournament, we're not thinking about, oh, I have to enter the first name and last name and email address and phone number of these people who were on teams and all the rest. We're just concentrated on what the tournament needs. Even if we hadn't yet created that team or that list of person called team members or anything else, we could say, I just need a list of teams. And then from there, we could say, okay, in a team, this is what I need. And then in a person, this is what I need. And so really when we're developing this data, we can't look too broadly. We have to focus on just what makes sense for this particular object or this particular chunk of a data. What goes together? In this case, we're talking about tournament. So the name of the tournament, the entry fee, the entered teams, and then also the prizes. The list of prizes contains just that, a list of prize. What's a prize? Well, we talked about the idea of having, for first place you get half the money, or first place you get $50, whatever we want to do is in setup. So we need to have a list of those. And this list, it truly is a 0 or more list. Maybe we don't have any prizes. Maybe we have 1, maybe we have 15. The next property for our tournament is going to be rounds. And this one's a bit tricky. And you got to think through how this is going to work. Now, we haven't built the matchup object yet, but a matchup would be one team versus another team. So we're going to have a look from the middle out. So we have a matchup, that's one team versus another. We're going to have a list of those matchups per round. So we'll have a list of matchups that's round 1, another list of matchups that's round 2, another for round 3, 4, and so on. So one list represents one round. Therefore, we have a list of matchup. You get that? You might have to draw it out on paper to think it through. We have matchups, but then we have a set of matchups that represents one round. And this rounds property holds all the rounds. So it has multiple lists, one for each round. Thus, the list of a list of matchup. And that's really what the tournament object contains. And at this point, there's a couple things I want to point out. First of all, we don't have the prize object or the matchup object yet. That's okay. We've written those down as we need these. We'll get back to them. We're concentrating on tournament. The other thing I want to point out here is there's going to be data besides what you have here. You're going to miss stuff. You're going to not think things through all the way necessarily. There may be things that you need for certain things. For example, in SQL, which is where you want to store our data, one of the places, typically what you do is you have a unique identifier for every row in a table. Well, probably team will be a table, and person will be a table, and tournament will be a table. And so each of these will probably have a unique identifier. Now, there are certain things that we call natural keys we could use for identifiers. For example, in tournament name kind of specifies, this is this tournament and not one of 3 tournaments called this. So for example, you wouldn't have 3 different tournaments all called basketball tournament because you couldn't identify which one was which. Therefore, you'd say men's basketball tournament, women's basketball tournament, mixed basketball tournament. There's 3 different ones. And so the tournament name would be unique across all the tournaments. That could be a natural key. I'm not a big fan of natural keys. I like to create my own. And so it'd be something I'd call ID, and it'd be just a counter, 1, 2, 3, 4. It makes it a little easier for indexing, and it's just easier to work with that. And so really, we're missing that ID property, probably on all 3 of these. And that's okay. If you notice that, you can go back and put that on all of the places where you need it. But you're going to miss something. And that's what I want to get across to you is the idea of it's okay. You may miss stuff. You don't have to get this 100% right. Don't stress out about it. Instead, do your best, think it through. Don't rush through it, for sure, but make sure that you at least get everything that you know and a little more in here. Do some research. Look at what other people do or what information other people capture in these type of situations. For example, a simple example, the person class. Right now we're capturing first name, last name, email address, and cell phone number. Go find out what other people do when they're capturing a person. And you may say, I have no clue where to look. Well, think about Amazon. When you sign up for an account at Amazon, Amazon asks you for certain information. What is that information? Not the billing information, the personal information. For example, they're going to ask things like where you live. They might ask for 2 different phone numbers, a home phone and a cell phone. Or they might ask you to tell them what type of phone number you're giving them. They might ask for a middle name or middle initial. Another place you could go look would be a contact on your phone. Go into contacts and say add new contact and look at all the information that you can add about a contact, because a contact is really just a person. And you don't have to do everything that everybody else does. In fact, please don't. But it's a really good idea to look through some examples to say, no, I don't need that. No, I don't need that. Oh, I didn't think about this one. Maybe I do need that one. And that'll just help you better visualize what data you need up front. But once you've done that, again, don't stress out about, I have to look at 10 more examples to make sure I don't miss anything. That's not what this process is about. We're going to make mistakes, and it's okay. In fact, I know in my planning, I've made mistakes. In fact, when we get to lesson 5, I'll point out a couple of my mistakes that I've made in this process so far. And you know what? It's okay, because we can work through it. Now, I caught that still in the planning stage, which is good, because it's easier to change things in planning than it is once we start developing. But you know what? Even in development, I'll capture more errors or more things that I've missed. And we'll figure out how to handle it at that point. Is it as convenient as handling it now? No. But you know what? You can't ever get things perfect up front. If you try and do that, you'll spend way too much time planning and you'll never get your application out the door. And a well-planned application that's still on your legal pad is useless. What you need is something out the door. So there is that balance of we should definitely plan before we start building. But we don't want to get so bogged down in planning that we don't build. So that's just the tension we're going to work through. But the big keynote here that I want to point out again and again is don't worry. Don't overthink it. Okay, so let's move on. We know we have prize and matchup are 2 more objects we need to create in order to support the tournament object. Let's start with the prize object. Inside the prize object, we have a place number, and that's an int or a number. So what the place number is we're talking about first place, second place, third place, and we represent that with just a number. 1 represents first place, 2 second place, 3 third place. So if I said the place number is 10, what place is that? Well, it's the 10th place. So it's pretty straightforward. There's not any kind of matchup you have to do. We understand number 1 is first place. Next, we have place name. So this is where we're going to specify what that place is called. And you might think, wait a minute, we just said what those places are, first place, second place, third place. But maybe we want to call it champion is first place. Second place we call first runner up. You see how that terminology might be a little bit different? So we'll put that in this string field. The administrator, when they're setting up a tournament, they can specify anything they want for that place name. And then we'll use that when we're talking about the prizes that were won. So Tim won the championship and got $50. Or Tim was the first runner up and earn $25. So that's that place name. It's just a name that we are given to describe that place. And it could be first or second. So now we have the amount. Again, this is money, so it's a decimal. And that prize amount is how much in dollars we're going to assign to this place. And if you're remembering your requirements for this application, we said it's either a flat amount or it's a percentage. And so we also created the prize percentage property, and that's a type double. So for example, 0.5 would be 50%. So if you remember back to requirements, we said it's either a prize amount, a fixed amount, or it's a percentage. So how do we represent that in this prize object? Well, some of that comes down to, we'll probably have some kind of read-only property, but also if prize amount is 0 and prize percentage is 0.5, we know it's 50%. If the prize amount is $20, the prize percentage is 0, we know that the prize is $20. And so we'll use that idea of one is 0, therefore the other one is the one that we use. And if both are 0, we have no prize, which doesn't really make sense that we then create that, but maybe we do. But that would be the prize object. A place, a name, an amount, and a percentage. Now on to the matchup object. And in the matchup object, we have entries, which is a list of matchup entry. What's a matchup entry? We'll get to that. But the idea is that a matchup entry would be one person. And so we'll have more than one person in a matchup. Obviously, we'll have at least two. And in fact, this system is designed for just two. But we'll still have that called a list. Then we have a winner. We're going to specify which team is the winner. We're going to put that in its own property. That way we can pull out information about the winner, like their email address to email them, or that kind of thing. So it makes it just a little bit easier if we have that winner property. And they also have a round number. Is this matchup for round 1, for round 2, for round 18? What is it? And that's it. So now we have this matchup entry. And this is where we describe what we have in that list of matchup entry, those entries, what they really mean. First, we have a team competing. So it's one team. So that represents this entry in the matchup is one team. Their score, if they have any, maybe it'd start at 0, but then once we mark them as their score, then we know. And then the parent matchup. So what I did here, originally I had team 1 and team 2 up in the matchup object. And I said we will only ever have two teams. But then I had team 1 score, team 2 score. And that didn't fit right with me. The idea that we had properties that were mirrored for two different teams for their information. I didn't really like that. And so what I decided was, I'm going to create a list, even though there'll only be two. I'll create a list, and then I'll create an object for each entry so I can have multiple data points about that entry in one object. And one of the ways this helps me is I can reorder that list based upon things like score. So I can say, give me the top one matchup entry, order by score. And if the score goes the opposite direction, meaning it's like golf where the low score wins, I can say take the entries list, which is that list of matchup entry, order it descending by score, which would give me a low score first, and then it's giving me the first person. And that gives me the winner, which I can put in the winner object, and it allows me to then say other things as well, order by something else. The other thing it allows me to do, though, is it keeps the team competing, their score, and where they came from all together. Now that where they came from is kind of important. That's what I call the parent matchup. So this is, in round 2, we know that this team came from this other matchup in round 1. So round 1 was played, team 1 played team 2. Team 1 lost. Therefore, team 2 goes on to round 2. So they have, team 2 has their matchup entry. They'll have a score of 0 to start, but they'll have a parent matchup of their win from round 1. That way we can link a winner all the way back through the different rounds. So it's going to be a bit confusing, I know, but this is my idea of how to deal with that whole matchup and which teams and all the rest, how to deal with that in a way that makes sense, or at least it makes sense to me. And we'll see as we put it down in actual code how it works out in the application. You know what? Right here we have all of our data we need for our application, or at least the broad strokes of all of our data we need for application. These 6 classes are what the application is going to revolve around. And we're done. Welcome to Lesson 4 in C# from start to finish. I am Tim Corey, and today we're going to look at building our user interface in the design phase for our tournament tracker. And this is the fun step because we actually get to see kind of a rough idea of what our application is going to look like, which really helps cement some ideas in our minds, and it also helps hone our overall idea for how the application should work. Now, normally in this process, this is where I get out my whiteboard or my legal pad and I start drawing. And I am not an artist by any stretch of the imagination, but I still like to draw it out because that way I can scrap it, erase it, start over, and it gives me an idea of what the thing should look like, what the form should basically be. It doesn't have to be pretty. It doesn't have to be even proportional. It doesn't have to have all of the extras that you're going to want to add to make this thing really pop. It just has to have the basic idea of these are the forms I need, or these are the pages I need, and that's it. So the question that comes up is, where do I start? And that's the same question we have when we started the data design. Where do I start with this thing? And really the answer is, it doesn't matter. Just start somewhere. If you aren't sure of a certain part of the application, start with what you are sure of. Get that stuff out of the way first, and then come back to what you're not sure of. More often than not, you'll find that you've got a better idea now of how that piece should work. And you've also got that momentum of, I've done this 4 or 5, 6, 7 times. I'm on a roll. I can do this. So that in mind, I'm going to start with our tournament viewer form. Now, before I go to that form, I want to talk a little bit about how I've adjusted for working on video. And so one of the things I'm not going to do is just show a whiteboard session. I'm actually going to show you a somewhat completed form. Now, it's not going to be pretty. It's not going to have, again, all the visuals, but it gives us an idea of where to go. Now, again, before I show you this, I want to emphasize I don't encourage you to do this in Windows Form Builder. Don't go into Visual Studio and create a new form and design it and call that your design process. That's not a real design. You don't want to start there, and the reason why is because one of 2 things will happen. Either one, you'll spend way too much time tweaking the layout and looking for different controls and trying things out and naming things and all this other stuff that's really not necessary in this part of the process. Or you'll create this form and in the end you'll say, that's great, I'm going to use that for my actual application. And while it sounds like you just saved some time, what you really did is you shortcutted the design process and you haven't looked at other ideas or alternatives, and you've probably left yourself some problems in the form that you kind of worked around because you don't want to redo it. Whereas if it's on a paper, you can go ahead and scratch it out and try again. You can try weird and silly things and say, yep, that's not going to work. Or you'll have the epiphany when you try something silly and go, wait, that's not silly, it's awesome. So definitely put it on paper. But for our purposes, since I am showing on video, I'm actually going to show you a completed form, and we're going to walk through my thought process and some of the things that I changed and tweaked until I got it somewhat right. And again, this is about an 85 to 95% certainty. This is not 100% done, even in the rough layout. All right, that's enough preamble. Let's actually jump right into Tournament Viewer. All right, here's a Tournament Viewer form that I created. Now again, it's ugly right now. That's okay. Let's walk through my ideas for this form. First, we have the tournament and that name in the less than, greater than signs. And so what that's going to be is that's going to say the name of this particular tournament. So this form is going to display all the information about one tournament. So it's going to first say this is the women's basketball tournament. or whatever we've called our particular tournament. Again, at this part of the process, we don't care how the information got here. We don't care about what the backend's going to look like. We just want to look at user interface layouts. So pretend like the rest doesn't exist and you're just developing cool screens. So we have the tournament name. Next, we have this round dropdown. And so here's my thought. I didn't know of a good way to lay out the tournament bracket and have this huge bracket on the screen. We can see all the games in a nice ordered layout. And really, even if I found a third-party control that did it, that's not going to teach you a whole lot because you're not going to use that bracket in your job or to create your own application unless you're also creating a tournament viewer. So instead, I thought, what if I showed a list box, that matchup list box, and in that list box, I had just the games in this particular round, in one round. And so that drop down for round allows me to choose which round I'm displaying. So in a 4-round tournament, it could be round 1, round 2, round 3, round 4. So that drop down would change based upon the number of rounds. The list box would change based upon which round is selected in the drop down. And then my final piece I thought of was, what if we only showed the games that have not yet been played? Let's think for a minute about a tournament that has 16 games in the first round. That's a lot of games. But imagine we have 16 games in this list box. Well, if we only have 2 left to play, you're weeding through 14 played games to find the 2 that aren't played. So instead, we could check that box that says unplayed only. I'll probably have it default to be checked. But if that box is true, then we'll only show the games that have not yet been played. So as you play games, that list will get shorter and shorter until there's none left in the list. I also had a thought that I would change the round dropdown based upon the current active round. So for example, it would default to whatever round we're currently in. If we're in round 3 right now, it wouldn't start off this form with round 1, it would start in round 3. How that's going to work, I don't know yet. I just wrote down my paper as, this is a cool idea, remember this for later. Because now I'm not doing code, I'm doing user interface design. Now on the right, we have sample team 1 and a score and a box. They have versus and sample team 2, the score and the box. So this section right here, what I'm doing, or what I'm thinking I'm going to do, is I'll have the name of team 1 and the name of team 2. And then we'll be able to put in scores for them if they're not already scored. So if they're already scored, that box to the right of score will have an actual value. But if they've not been scored yet, it will have nothing. Once they've scored, we'll put the information in those 2 boxes and hit the score button to the right. The idea here is that would complete the matchup. Now, looking at it, I'm not sure that's my final design. I might want to change what that score button says and how those 2 boxes are laid out, just because I'm not sure it's totally clear with the score box versus the score button and how those 2 interact. And I want that to be very clear to the user that's using this form. So this form is basically done. There's not anything more that I think needs to be displayed on the form. It simply has all the games, and then you can score a particular game, and it will show you which ones are yet to be played. Pretty simple. We can probably add some more fun stuff, like maybe buttons that tell us who won the tournament or things like that. But right now, I think that this form is done in its design phase. So let's move on to our next form. Now again, it doesn't matter which order you do this in, but in my thought process, if I have a tournament viewer form, I'll probably need a tournament creator form. So here's my create tournament form. It starts off with asking for the tournament name, and then an entry fee box. That box will allow us to, if we want to, specify how much each team needs to pay to enter the tournament. And then it gets a little more complicated. So my thought is that we have a select team drop down. And what this will do is it will allow us to select an already existing team. Maybe one team enters more than one tournament, especially if that team is one person. So if we've already created a team, we don't need to recreate them. We just need to add them to our tournament. And when you hit the add team button, it's going to take whoever's in the drop down and add them to the list box on the right at the upper top where it says team/players. And that'll be who is in the tournament. Now, if we don't already have a team and we need to create one, that's that create new link. And while I don't get individuals too much at this point, that's why they're ugly gray forms, I did like the idea of having that create new be somewhat different than the other buttons, just so it's pretty obvious that we're creating a new team versus creating a new team on this tournament, as in using an existing team, but adding them to the tournament. So it was just confusing. I decided that link button needed to be a bit different. Okay, so we've got the drop down for teams. We've also got the create new button for the team. Both of those will add whatever team we either create or select to the list box on the right. And now we have prizes, because a tournament has a name, an entry fee, players, and prizes. And if you're confused as to what a tournament has, you can go back and look at your data model, because the data model for a tournament tells you all the things you're going to need to capture. So for prizes, I didn't expect we'd have prizes roll over from one tournament to the next. They just seemed too different to me, especially the variable number of players in a tournament. So instead, I said we'll create a new prize list every time from new prizes. So instead of the drop down, we just have the create prize button. And that will pop up a new form, just like the create new team will pop up a new form. So again, in your notes, you should note that we have two more forms to create now, the create new team and the create new prize. Once the prize is created, it'll get added to the prizes list box. That seems pretty straightforward. Now, next to the list boxes, and I'll change these icons probably. I'll probably go with some kind of red X or something like that. But the delete selected. Whenever you have a list box where you're adding something to it, you need to have some way to get them out to. For example, maybe you added a player or a team and you didn't want to. You want to take them back off. You've got to have a way to do that without closing the form and restarting. And that's really all I have for this form. I just have that create tournament button, which will take all the information and create a tournament object. The assumption is this will also get saved in a database or a text file in some way. But again, we don't care about code at this point. Now, if you're looking at your model, you may have noticed that I'm missing one piece of data, and that is the rounds. We have a list of matchup, and this form doesn't cover rounds in any way. And the reason why is because rounds are random. Who goes in what order for each matchup is random. The number of rounds is determined based upon the number of teams. So all of that gets set up in code, and it's not something that the end user does at all. Therefore, it's not displayed on this form. Okay, according to my notes, the next form I had to create was the add team or the create new team form. And so let's go ahead and create that. And this is my idea for the create team form. It has a team name, which if you notice, let's go back to the create tournament, the tournament name, it's laid out the same way. And that's an idea that is really important to think about, is the continuity between forms. The idea that the same thing works the same way on multiple forms, or the same layout works kind of the same way. That way, even if you do things a little differently, the fact that it's done a little differently throughout your entire application makes your form and your application more cohesive. So we have a team name, and that's just a straight text field. Then we have select team members. Now this again pulls from the database with a text file, and it says, I already have team members. Why don't you just go ahead and add one of these if that's who you want? So if the same office team plays all the time, so you have 10 people in the office, well, there's no reason to recreate who they are every single time. They're the same 10 people. Therefore, for the second tournament, we'll just select the team members from the list because we've already created them in the first tournament. So the select team member, we'll select who to add as a member of this team, or if they're not already in the team member list, we can add them right in line. Now it's important to note that this form now does two different things. It both creates teams and also creates members. And sometimes that's not the best way of doing things. Sometimes you want some separation there where you have a button that goes to a new form for add member. But for me, what I said was, this is such a little bit of data, just 4 fields, all text fields, and I have the space in the create team form. Let's go ahead and put that right in line with this form, because I know that at least for the first little bit, I'm going to be entering new members right away multiple times. Now, I don't want to go 3, 4, and 5 forms deep to create a tournament. Now, don't forget, we're already in form number 2. Because form number 1 was create tournament. And on there, it had a create team button. So in this, that's this form right here. Now, if we say add new member or create member is a new form, that's 3 layers deep. And it just gets confusing and it gets cumbersome. And so the more I can streamline that by putting things together, the better I feel about it from a user acceptance and a user comfort level with my application. Now, that might not be something you're comfortable with, and that's fine. You can definitely have just the button here and open a new form. But for me, I like the compact, quicker design process of this create team form. So that's what we're going to do. So whether you add a member from the list or create a member, either way, they get added to the tournament players list box. Once all the team members have been added, and once the team has been named, we go ahead and create the team. And that's it. And that's the create team form. So the next form, according to my notes, is that create prize form. And that's really simple. So remember, we have back on our tournament form, we have that create prize button that's going to allow us to create one prize and add it to our list of prizes. So this represents one prize. So for example, place number 2, place name, second place, prize amount, $20, or prize percentage, 0.15 or 15%, in which we accept there is definitely up to us at build time. So it's pretty straightforward. It has 4 input boxes and that button to create the prize. There'll be a little more that goes on behind the scenes to say, don't allow both prize amount and prize percentage. But besides that, we don't have a whole lot to work with here as far as difficulty. And so that brings us to our last form. And this form I really wrestled with. So I'm going to show you the form first, and then let's talk about it. This is my tournament dashboard form. Now, I'm not totally in love with this, but I've come to the conclusion this is probably the easiest way to make this whole thing work. You see, when you create a Windows Forms application, and again, we're getting a little bit into code, and that's okay, but when you create a Windows Forms application, it wants to create one form and leave it open the entire time. You can open new forms, and you can close those new forms. But if you close the main form, the application is done. And so I was wrestling this idea of how do I do multiple tournaments, and how do I have this system where a form stays open the whole time that's logical. At first I thought about having this switching system where it said, if you have no tournaments currently running, open the create tournament form. But if you have an existing tournament, go to that tournament instead. And that kind of works, except for the fact that maybe you want to have 2 tournaments running. How do you create the second tournament? And if you do create the second tournament, how does the system know which tournament to open up? And if you have no tournaments yet and it opens the create tournament form, when you're done creating the tournament, it's going to close that form, which closes the application. And that doesn't work. So I said, I need some sort of central form that kind of coordinates or quarterbacks everything. And that's this stupid little form. Here's what it does. It allows you to see what tournaments are currently open. You select one and you hit load tournament, and it opens the tournament form, the tournament viewer. Or you can say create tournament, even if you currently have existing tournaments. When you create a tournament, it opens the create tournament form, which is pretty self-explanatory. But this form stays open all the time. That way, if you close out of the create tournament form, you still have this form, and that dropdown should be updated. If you have a tournament viewer form open, it will be on top of this dashboard. You won't see the dashboard. The only time you'll see this dashboard is if you have nothing else open. So again, I'm not in love with it, but I think it works. And so we may have to tweak how it looks a little bit because it really is stupid simple. So maybe do some kind of design around it to make it a little more inviting, more splash pagey or something like that. But the key here is this is what we need on the form, and this is the form we need to use to open the application on. And that is the conclusion of our user interface design. That's really all there is. You just kind of sketch out some forms and say, what do I need on each form and what forms do I need? That's really it. Welcome to Lesson 5 in the C# from Start to Finish course. My name is Tim Corey, and today we're looking at logic planning. Now, so far in this course, we have scoped out our requirements. We have built the overall structure for our application as far as our design. We have designed our data backend and drawn out our front end. In this step, what we're going to do is look at some of the global ideas for how we're going to wire up our different forms. Now, there's a lot more to logic than just wiring up forms, but you'll find that wiring up the forms will do most of the major heavy lifting for your application. By the time you're done, you'll have just a few things left to do before your application is running. So today, we're going to talk through those global ideas, the big picture ideas. We won't get into the nitty-gritty of actually writing code, but instead we'll talk through what each different piece of the application should do. If I were doing this on paper, which I recommend you do, I'd write out some notes and thoughts on what each piece is going to do. I would redraw out each form and kind of put arrows there and say, okay, this button is going to do this and that button is going to do that. Now again, we're on screen, we're not showing a piece of paper. So what I will do instead is I'll bring up the form and then we'll talk through the logic behind each different piece. Like before, the order doesn't matter. But I'm actually going to readjust our order a little bit because I want to talk about one of the forms last because it's the most complicated, most complex. So let's go through the easier, more simple ones first, and then we'll get to the more complex one at the end. So let's start with the create tournament form. And this is the form we created in our previous step. We kind of drew it out. Again, remember that this is just a design of the application. It's not the actual form itself. It's just a concept of what the form will probably look like, or at least the structure of it. So the first thing we want to look at is this create new button. It's actually a button or a button link. But what this does is it's going to create a new team. Now remember, we have a new team form. So this button will open up that new form. But it's not done there. Once the new team gets created, we want to close out the new team form and come back to this form and have that data on the screen now in the team/players list box. And how we're going to do that is we'll probably create a method that the create team form can call saying, okay, here is the new team. Here's a new team object. And that's where, if you remember back to our big idea, the overview planning we did, we talked about key concepts, and one of the key concepts was interfaces. And this is probably a good place to have an interface because that way the form doesn't have to know, the create team form does not need to know about the tournament creator form. It just needs to know about the contract that the tournament creator form implements. And if you're not sure what that means, don't worry about it. We'll actually show it in code and we'll talk through it and talk through the different options we have. That's just where varying levels of experience will show you more or less that you need to do at a certain junction, or give you more of an idea of how you're going to do it. But if you don't have that experience, don't worry. You'll learn how to do it, and then next time you'll have that experience. Next, let's look at the add team button. Now this button's pretty straightforward in what it needs to do. It's going to look at which item is selected in that drop-down right above it, and it's going to take that item and put it in the list for the tournament players list box. It's also going to remove it from the drop-down list that it pulled it from. Once it's done both of those steps, we're going to need to refresh both the drop-down list and also the list box. Next, we have the create prize button. And this button works almost exactly like the create new over the selected team drop-down. The create prize button is going to open up a new form, wait until the prize gets created, and then take the value from that created prize and put it in the prizes list box. So really, the logic is basically the same. It's just which class you're creating. So there's not much more we need to say there. Next, we have these two delete selected buttons. What each of these is going to do, and they are so similar, I just highlighted them both. What each of these is going to do is when you click that button, it's going to delete whatever item in a list box to its left is selected. In the case of the teams list box, The additional step is it's going to put that team back in the select team drop-down box. And finally, we have the create tournament button. And this is actually the big one, because a lot of stuff goes on behind the scenes when this button is clicked. First of all, we're going to need to validate all this information. So for example, we need to make sure we have a tournament name. We need to make sure that the entry fee isn't something like a negative number. We have to make sure that we have at least 2 teams, because a tournament can't be a tournament with only 1 team. Once all of that is done, we then need to create the schedule. Remember, we talked about the fact that we have that rounds property, which is a list of matchup. We have that rounds property, but we don't have that on the create tournament form because that's not something that the user does. That it gets populated on the click of this create tournament button. First, we'll need to figure out how many teams should be in the tournament. And if you read the companion document that comes along with this course, you'll see I've written out the formula for how to determine how many teams should be in a tournament, and then also how many buys we should have to make up for the missing teams. So for example, if we have 10 teams in the tournament needs to start with 16 teams. So therefore we need to have 6 buys in the first round. And so how that gets worked out is determined in this create tournament button click. It won't happen right behind the button in the code behind, but this is where that logic gets kicked off. We will also then need to randomize the order for the first round. Once all that's complete, then we're really done with this form. So let's move on to the create team form. This form is a little simpler, but let's look at some of the interesting pieces of it. First, the add member button. This is going to take an existing team member from the drop-down list and add it to the tournament player list box on the right. That logic is very similar to the previous form where we had the add team button. Don't forget that when we add the member to the list box, we have to remove that member from the drop-down list and refresh both lists. The next interesting piece is the create member button. What this will do is take those 4 fields above, create a new team member, and add them to the tournament players list box. It will also then clear out those 4 fields. Finally, the create team button will allow us to first of all validate this team and then create them. The other thing we'll do is send this information back to the caller. Now the one thing you may have noticed that's missing on this form, and it's not something that we realized at the previous stage, is that we don't have a delete player button on this form somewhere. We're going to need to add that. And at this part in the process, again, it's really nice to have it drawn on paper because I can just draw it in. But since I don't have it drawn on paper, I'm just going to put it in my notes to make sure to add that. The other thing we'll do is make it the same as the other delete buttons because the users want to see a similar experience across all the forms. That way they get more comfortable with how things work and know what to expect when they see certain things. Okay, moving on, we have the create prize form. And this is even simpler. This essentially is the same as the previous page with just the add new member field or section. So the create prize has 4 text boxes, and when we hit the create prize button, it's going to need to validate the information and then send that information back to the calling form and close this form. And that's all there is to it. The next form is the tournament dashboard. This is really simple. It has a list of existing tournaments. If you select one and hit load tournament, it's going to load the selected tournament viewer for that given tournament. So that's what the load tournament button does. The create tournament button just opens the create tournament form. And that's really all this form does. The only thing that will be different is we'll have to capture when a tournament gets created and put that new tournament in the drop-down for the load existing tournament drop-down. That way, once you create a tournament and the form closes, you can then load that tournament. And that brings us to our last form, the tournament viewer. And this is the fun one because it has a lot of stuff going on behind the scenes that makes it a little more complex, but I think we can definitely dive into it and understand the overall view of what's happening in this form. First and very simply, the tournament name will get updated when we load this form. When the form gets loaded, we're going to pass in that tournament object so we'll know what the name is. And we'll just put that in this label. Next, we have a drop-down with rounds. Now, so far, I haven't really highlighted the drop-downs. Essentially, they're just loading information from a database or from a text file. But with this drop-down, it's a little different because this is actually calculated. So what's going to happen is we have that list of matchup. And we call that whole object rounds. This drop-down will figure out how many rounds are in a rounds object. I know it doesn't make sense necessarily when you talk about it. You got to kind of see it on paper. But essentially what's going to happen is if a tournament has 4 rounds, we're going to have to put in this drop-down list round 1, round 2, round 3, round 4. And it has to know, go to the list entry for round 1 or round 2. So that drop-down will change what the matchup list box shows. But next, we have the unplayed only checkbox. If this is checked, which I plan on having it checked by default, if it's checked, then we will further filter the matchup list box, not only by which round we're in, but also by if the game has been played or not. Next, we have this section over here that displays the scores and allows us to update or change the scores. So based upon who is selected in the matchup list box, that will determine which matchup then gets displayed on the right. First, we'll update the team names, Team 1 and Team 2, and then if they have scores, we'll put those scores in these score boxes. And finally, this score button right here will allow us to change that matchup's scores. And based upon this, it will finalize and say, the matchup is over and this is who won. Now that's where it gets really interesting because we're going to have to figure out some way of triggering then other things based upon a matchup being scored. For example, if this is the last unplayed game in the round, hitting the score button here should trigger the next round. Remember that we email people when they are scheduled to play. We also email out the results of a round. And if this was the last game in the last round, meaning the championship game, we then trigger the end of tournament information. Meaning we then assign prizes and we trigger that final email saying who won, who got what, and what the results were. Now that raises an issue, or at least a question, and that is, can we mark played games with a new score? So for example, say it was a basketball game, and the score for sample team 1 was 95, and the score for sample team 2 was 75. We put those values in and hit score. But then we realize instead of 95 and 75, it was 95 and 82. Can we go back in and update that score? And I think the answer has to be that yes, we can, as long as we're still in the current round. Remember that teams can't play each other until they're in the right round. Meaning, if we know that we're going to play each other in the next round, but this current round's not over, we can't play each other in that next round yet. All the games have to be done in the current round before the next round gets started. So as long as we're in the current round, we can adjust those scores. Because think of it this way. What if sample team 1 was given 95 points and sample team 2 was given 75? But in actuality, we got it backwards. Sample team 1 should have gotten 75 points and sample team 2 should have gotten 95 points. And that changes the outcome of the game. If we were already in the next round, that would change who plays who in the existing round. That could cause some major issues. So I think we need to lock this so that we can only modify scores in the existing round, which means that this score button needs to have logic in it that says, are we in the current round? And that's really it for the tournament viewer. So that raises this question. What are the other pieces we haven't really covered in our logic planning? And we've got quite a few. For example, we haven't really talked about data access. How are we going to access the data, store the data? How are we going to deal with two different data sources that are very, very different? How are we going to email out information? What triggers that? What triggers knowing who plays the next matchup? These are some areas that we're going to dive in when we actually get to the code. We can't plan everything out in abstract. Some things it's just easier to be in the code and then plan. So we've done what we can with our planning outside of Visual Studio. We've created our data design. We've created our UI layout. We have looked at what logic needs to be behind that user interface in order to use and move the data around properly. We're not going to worry about trying to plan out every bit of the other pieces of logic at this point. We'll get to that once we've done all we can to put what we have in code. Welcome to Lesson 6 in a C# from start to finish course. My name is Tim Corey, and today we're going to create our class library. So far, we've been stuck in planning mode. And I say stuck because that's how I always feel. That first thing I want to do is start writing code. And as I've stressed, planning is important and it needs to be done before we start coding. But now that we're through our initial planning, we get to actually start by opening Visual Studio today. And today we're going to look at creating our class library based upon what we've already laid out. So let's jump right in. Here we are inside Visual Studio. So we're going to create a new project. We'll select class library. We'll name this tracker library. And I call it library at the end to make sure that I know that this is a class library. I'll go ahead and set the location to the location as specified. And the solution name we will call tournament tracker. I'll hit OK. And the first thing I do is I open up Solution Explorer and delete class 1. And the reason I do that is because I don't want anything named the default, like 1 at the end. So instead of trying to rename that and possibly having an issue, I just go ahead and delete that. So now we have our library set up and it's ready for our classes. But what classes do we put in here? And this is the great part about having done the planning process already. We're really not thinking at this point. Instead, what we're doing is we're just retyping what we have in our planning document into actual code. Now, we still are thinking. It's just that our thought process is maybe a little bit different. Instead of thinking, what data do I need? We're now thinking, is that the right name to call it? Am I missing anything? Those type of things. And so it really speeds up the process. So I've got a printed out list of my classes and the properties in them. And so I'll go ahead and start creating those. If you have the companion guide, this is a great time to open that up and go to that page because it really helps you follow along. If not, you can reference the previous videos to see the design for our class layout and compare that to what we're doing right now. Or if you're really organized and have been taking notes, refer back to those. So let's start by adding a new class, and we'll call this team model. We could just call it team if you wanted to, but a standard is to put model at the end of it, just so we know this is a data model or it captures data. It does really differentiate this type of object from anything else. So let's go ahead and just put model at the end of every one of our classes. So team model, we'll make it public. And we'll type prop, P-R-O-P. And this is my snippet that I use. It's built into Visual Studio. And this snippet, what it does is if you type prop and tab twice, it creates an auto property. And this auto property is the type of thing we're going to use quite a bit in our classes. This holds one piece of data. So in this case, right now it's an int type, and it's called my property. Of course, we'll change that. We can change that by saying a list of person, and I tab, I can say team members. I hit enter, it goes to the end of the line. Now, we don't have a person class yet. We'll get to that. So for right now, it's a red squiggly. That's okay. Next, I'll type prop, string, team name. So now I have two properties. First is a list of person, and next is a string. And that is all I needed for the team class. Before I continue, the one thing I want to do as well is initialize this team members property. By default, this will be an uninitialized list. And I want to make sure that the very first thing that happens is we initialize it. So what I can do is at the end of the property, say equals new list of person. And this is something new in C# 6.0, it used to be we couldn't do this here. And so instead what we do is we create a constructor, CTOR, tab twice, and then say team members equals new list of person. And that's in the constructor, and so anytime this class is instantiated, it'd call this and it would instantiate the team members property. But since C# 6, we can now just say the auto property equals new list of person. Again, that's yelling at me for the person because it's not yet created. No worries, we'll get there next. So let's go ahead and right-click on the tracker library and say add class. And this is the person model. We can say public class person model. I say prop, tab twice, string, first name, prop, tab twice, string, last name, email address, cell phone number, and that's it. So now we have the person model. Notice how quick that went. And I intentionally didn't really talk through the whole thing. I just want to go through it because we've already talked through it initially in our planning step. And now I'm just putting this stuff down into actual code. And the one thing we need to address is back over here in team model, we call this person, actually person model. I'm going to change this as well. So now we have no more red squigglies. The team model has team members, which is a list of person model. And the person model has our 4 properties. And that's all for that. Let's add another class. And now we add our tournament model. We make it public. We're going to add our string tournament name, our decimal entry fee, our list of team model, entered teams, our list of prize model called prizes, our list of matchup model called rounds. And again, we will initialize these 3 lists. So equals new list of team model equals new. And notice how when I say new space, I kind of glossed over it before, but it already knows list of prize model. And so therefore I say new, and it says right here list of prize model. So I can say tab and it fills it in for me. Even though right now prize model is not yet a created model. And so it's yelling at me, but at the same time it's saying, you probably want this to be a new list of prize model. So it allows it. Even for that more complicated list of a list of matchup model, it allows it. Now let's continue on and create these other models. Add class, prize model, make it public, int place number, place name, prize amount, and prize percentage. Now leave those all to their initial values. Now if you come back over here to our tournament model, we can see that prize model is now working correctly. So we can add our next class, which is the matchup model. We can make it public. Prop, tab twice. A list of matchup entry model. Entries. And I'll even say right now equals new list. Team model winner. Int matchup round. All right, and the last one I have to do is I have to add a new class for matchup entry model. Make it public. Team competing. Score. And parent matchup. And guess what? That completes the basics of our class library. You see, when you get right down to it, the class library, once it's planned out, is very, very simple to actually build. But before we go, there is one other thing that I want to point out that we really should do. I'm going to start doing it, but I won't show you the whole thing just because it is a little bit long and tedious. And that is, we need to comment this. And I know that's not one of those steps, kind of like planning, that you're like, man, I really don't want to do that, or I'll get to it later. And here's the reality. If you don't do it now, you won't get to it. But I'm not asking you to comment this in general. Instead, what I'm asking for is XML comments. And if you've never used an XML comment before, they're really easy to use, and they're really, really useful. So for example, above this property right here, if I type 3 slashes in a row, 1, 2, 3, it gives me this little bit of XML. And it says summary, and it has a blank line, and then it has the slash summary. If you're familiar with XML or HTML or things of this nature, this right here is an opening tag, and this is a closing tag. Inside here is where you put your actual comment. In this case, I might say, represents one team in the matchup. And then come down here, and again over the score, represents the score for this particular team. And then our matchup model, I would say, represents the matchup that this team came from as the winner. Now that might be a little long, and so I could actually right here hit the enter key and put it on the next line. And notice how it added those triple slash comments and then moved one space over and then started my text. So this is called an XML comment. Now it may just look like a kind of a cool way of formatting, or maybe not cool way of formatting your comments, but there's so much more to this. Let me do a quick constructor here to show you what I mean. Let's say I create a constructor where you have to pass in a double called score, or maybe initial score. Why you do this, not really important. Instead, what's important is this actual method. If I hit triple slash comments here, I get that summary, but I also get this other line saying, here is the initial score parameter. So not only can I document the method itself, but also inside here, and this is where people get some things mixed up a little bit, it's inside like this. And so it's between this greater than sign and this less than sign. Not in here somewhere. Not in here. But you document right there. So not only can I document the method, but also the parameter. And in fact, if this was a method and it had a return type, we could also document that. And if you notice, if you open up your less than sign, I can have examples, or which exceptions get returned, or what permissions are needed for this method, remarks, see also. I can document a whole lot of other things. But again, you may say, who really cares? Or why should I use this format? Well, let's look at, if we had CW tab. Again, console write line, not really pertinent in this location, but pretend that it is. If I look at this right now, I see that it says it writes the current line terminator to the standard output stream. How does that method pass this information along? Well, it's by these / comments. That phrase right there, writes the current line terminator to the standard output stream, that phrase comes from the summary statement. Now, if I were to go down one level, say to this where it says bool value, notice it says value is the value to write. Where does that come from? Well, that comes from the parameter documentation for this item. Again, / comments. And that's what Microsoft does, but we can do as well if we use these same / comments. So if someone is calling this class library, instead of just seeing team competing, which may be descriptive, but this is definitely descriptive, or it should be, in telling you exactly what that is all about. We could even give an example of how to use a certain method, or even say who has access to a certain method or a certain property. So all of these things can be done using our / comments. My encouragement to you is definitely use these. So I'll go back through and add the / comments on the other properties in the rest of these models, but you don't need to watch that. Welcome to Lesson 7 in the C# from Start to Finish course. My name is Tim Corey, and today we're going to be building our forms. Just like with a class library, when we build our forms, we're just going to take the design we already came up with in the planning process and put it into an actual form. You might be tempted to write a bit of code in this step as well, but really we want to concentrate on just building our forms. We'll start wiring them up later. Now, if you remember, the designs we came up with were just rough sketches. In this step, we'll make those forms look good. That means establishing a design guide of some type. I won't bore you with the experimentation I went through to finally come up with my design, but instead I'll just walk you through the end results as we go. Before we get started though, I do want to point out that I am basing all of my work in this video off the designs we did in planning step number 4. If you have the companion workbook, you can refer back to those designs to help you follow along. Otherwise, you can look back at lesson 4's videos to see what our design plans were. So let's get started. Here we have our Visual Studio project as we left it when we built our class library. The only differences are that I did add those code comments on each one of the classes. But that's not really why we're here. Instead, we want to add a new project to this solution. So right click on the solution, say add new project, and we're going to select Windows Form Application. I'm going to call this project Tracker UI. This is a Windows Form application. So Windows Form, Tracker UI, hit OK. Now the first thing it does, it gives us this form1.cs. Now when we create our class library, I said delete that class1.cs and start over, start fresh. We can't really do the same thing inside of the Windows form. And the reason why is because in this program.cs, you'll see that we run right here, form1. So we have to have something here to run in order for it to be a form project. Now we could delete it and then come back here and manually update this, but I find that for forms, it's probably better just to rename it as is right over here. So I clicked and then I clicked again after a second, or you can right click and say rename. We're going to call this the tournament viewer form. And it's going to ask us, since we're renaming this file, would you also like to rename all the references to form1? We want to say yes. So now it renames the class, the partial class tournament viewer form, and also this partial class here, tournament viewer form. And that's what you want. So now the question is, what next? Well, we're going to start right away by modifying some of these properties. Let's actually pull the properties window out. like so. And I call this form, I call it tournament viewer form. By the top right here, where it says text, it still says form 1. I'm going to change this to say tournament viewer. And that just tells us, it changes the text up here to say something besides form 1. We can change that later if we feel like that's just not a great descriptive name. The next thing I'm going to do is change this back color. This back color is a battleship gray and it's really ugly, especially since most forms use this if they're built inside of Visual Studio. So let's change the back color. Instead of control, we're going to select under web, we'll select white. And that just gives it a little more modern feel. White is a great background color because it doesn't draw the eye away from our stuff on the form. So usually I start with either a white form, or if I'm going to go the opposite, kind of like this Visual Studio window is, I'd go with a dark gray. But let's choose white for this. The next thing I'm going to do is change my font. Now it's important to change your font right away on a form instead of later, because every control we add to this form after we change the font will inherit that new font. But any controls that were already on here won't get that new updated font. So if you change it up front, then all the new controls will have it. So let's change this font from the standard, which is Microsoft Sans Serif, to this one. Let's make a 16-point font. That's a nice thin font. It looks a little more modern. And of course that changes the size of our form because of the size of the font. It assumes the form will be a little bigger. We'll shrink that down just a bit. And the only other thing I want to do is I want to change this icon. So let's go to our demos folder, Tournament Tracker UI, and here's this Tournament Tracker icon file. Now, in case you didn't see me create that, which you didn't, or know how I created it, I actually just used the Metro Studio from Syncfusion. It's a free tool that allows me to take simple icons and make them into icon files or PNG files or JPEG files. It's a really handy little tool, and I find it's useful for creating these icon files. I am really not a designer, and so I don't have the tools or the experience and skill to create my own icons from scratch. So it's a great starting point. So I created this little clipboard icon. My thought was that's what I always saw my coach carrying whenever we had a tournament, where he'd keep track of things. And so I figured that'd be kind of a good representation of what this project will do. And so we'll add that icon to every form we create, just to kind of keep a cohesive look. So that's the basics of this form, but don't forget this is actually the tournament viewer form. It has more than just the base stuff. We have to actually add stuff here. So let's start dragging stuff on. So I'll open up my toolbox and pin it. And the first thing is at the top we have here is kind of this header label. And so I'm going to change this for color. Instead of control text, I'm actually going to give a custom color. I'm going to say 51, 153, 255, and that's the RGB code. Well, it has to be 255, not 555. There we go. So now it's that bluish color. And I'm going to change the font on this. Since it is a header label, I'm going to change the font to light 28. So let's go to the font here. And we'll change this to light and 28. Now we'll also change the name of the label. We'll call this the header label. And for the text, we'll say tournament and a colon. All right, that gets us started. And we can rearrange that how you want. I'll get it roughly in place. I may tweak it later, but that's good for now. Now I'm actually going to copy this and paste it. And I just did a Control C. Once it's selected, I hit Control C. And then I hit Control V and it puts a pasted copy here. And that's fine for objects. Just as a quick note, Don't do that for forms. That's just a real headache. I actually did that the other day. I was in a hurry, and I'm like, oh, I already have all these base settings I want for my other form. I'll just copy and paste the form. It'll be okay. It was a nightmare. You step on toes back and forth between the two forms. They actually kind of get commingled, and it's just ugly. So my quick piece of advice here is don't copy and paste forms. It's physically possible. You can copy here and then just right-click in your project and say paste. So it's physically possible, just don't do it. All right, enough of that. You can copy and paste objects like this. So it'll give it a new name, label 1. So let's change that. And this is the actual tournament name. And for now, we're going to just put none. That'd be a good starter name for it. And then we'll move that over a little bit more. All right. Next, we have a drop down with a label. So let's start a label. And I will call this round. And I'll call this the round label. And I will change the fore color again to the 51, 153, 255. I'm going to change the font itself to 20 point. Then I'll line that up, and that should be good for our round label. Now let's get the drop down itself, the combo box. Normally you'd align these with the pink line here. That pink line indicates that the bottom of the label text will be the bottom of the text in the dropdown. But because I made the label a little bit bigger of a font, I'm actually going to move this up and use the bottom guide here. So that blue line. And what that indicates is the bottom of the label's box, which is invisible, but the bottom of the box, will be the same as the bottom of the combo box. And that kind of moves the combo box text up just a little bit and makes it a little more centered. Then I will drag this out a little bit, make it a little bigger. Let's call it there for now. I will call this round dropdown. Next, I have to add a checkbox. I'll line that up. And again, I'm going to change the fore color to, you guessed it, 51, 153, 255. I'm also going to change the font on this to be 20 point, because the font actually applies to the equivalent of this label here. I'm also going to change the flat style to be flat, and that will make that checkbox actually turn blue instead of having a black check in it. And the last thing I'm going to do is come down here and change this to unplayed only. And I should also name this. To unplayed only checkbox. Now one thing to note here is I've called this round label, I've called this round dropdown, and I've called this unplayed only checkbox. You don't really have to put the type in there in that name. I like to. One of the reasons why is because this label here really is the same kind of thing as this. They both are for the same thing. This indicates it's the round, but it's the label for round, versus this is the drop down for round. And so putting the type in the end allows me to differentiate, but also when I am searching in IntelliSense, I can actually search for label. And even though it's not the beginning of the word, it will give me all the labels. And that makes my life a little easier if I forget what did I call it. Usually I don't mess with the labels, but I would mess with checkboxes or drop downs or whatever. So let's move that up a little bit. Something like that. So now we have a list box. Be careful to get a list view. It's a little bit different. I've made that mistake more than once, but I want a list box. And one of the reasons why I want a list box is because it behaves very, very similarly to the combo box. These two are basically the same thing with just a UI difference, which makes life a whole lot easier for me because I can treat the two of them in a very similar manner and not get confused on which is which. So there's our list box. I'm going to change the border style to a fixed single. And then the only thing left to do is to actually name it. In this case, it's the matchup list box. So that's half the form. The other half of the form is I have to have a label over here. Let's grab this one right here, copy, paste. Normally I'm not a big fan of copy paste when it comes to coding, but in this case it seems to work pretty well because it brings a lot of those same things along with it, the fore color and the font and the flat style and everything else. So I tend to use it for that, but you still need to be careful to name this something different. All right, so this will be team 1 name. And again, typically I wouldn't have this say team 1 or team 2 because I want to have some kind of flexible system where you can have more than 2 teams, whatever. But we've already talked about the fact that we're only ever going to have 2 teams competing in a tournament. And so it just makes more sense to have things labeled team 1 and team 2. Let's go ahead and do that. And we'll call this team 1, just so we have something to visualize right here. And then I will copy this and paste it down below. And I will say here, this is score. And team 1 score label. And then I'm going to grab a text box. And again, I will line that up at the bottom. And I will call this team 1 score text or score value. Let's call it score value. And I will copy all of this and I'll paste it. And since I copied all 3, notice how I highlighted that. I'll do it again for you. I clicked and dragged on a form. And notice that little gray outline of a box. This is my highlight window. It's now highlighted 3 items, this label, and this text box. Now I can Control C on that and Control V to paste. And we'll paste all 3 of those items together in the same layout and relationship. Then, if I select all of those and I drag one of the items, say it's label, I can line it up with the other label that is its companion, in this case, this one right here, and now these two are in perfect alignment. Now I just need to go through and change all of these. Let's see, I called this one team 1 name, so I'll call this one team 2 name. And I called this one team 1 score label. So I'll call this one team 2 score label. And this one is team 2 score text. Just a quick note here, because I was selecting items that had the same property, so this label and this text both have that name in parens property. And actually all items do because that's the name of the object instance. So because they both have these, when I switch between them, it keeps the box kind of highlighted. If you can see there, it's a little bit darker color and it's solid. And what that indicates is the box is really selected. And so if you start typing, and notice I'll select up here where it says team 2 name. Now I'm not going to click there. I've just clicked off and clicked in. I haven't clicked there. But if I start typing, notice how it turns blue and my typing goes in that box. That's a quick way to move from item to item, renaming things or setting a text property or other common property between objects. Just select the object and start typing. Let's come down here. We're actually going to change this to say Team 2. Now, the last thing we need to do, well, second to last thing we need to do, copy and paste this just so I have a label. And I'm going to change this to say VS for verses. And yeah, I might put a dash in before and a dash after. And I'll kind of center it ish. Make it look pretty good. And I will call this the verses label. Now note, I could use some of these tools up here. There's some tools up here that allow me to align things better. So you can use those to align them the same height or the same relationship with the page. But I'm not going to use that for this little thing right here. It'd probably be a little more complicated than I need to worry about. And the last thing on this page we need to do is add that score button. So come up here. Notice I'm in Common Controls. This is where I really live. Common Controls has pretty much everything you need for 95% of all forms at least. But if you really feel like you have to go beyond that, you could browse around in these other categories or go to all Windows forms and really browse around. Or if you think you know the name of something, you can type it. So for example, I'm looking for a button. Now obviously the button's right here. But if I were to start typing BUTT, it shows me that in all Windows forms, there's a button and a radio button. In Common Controls, there's a button and a radio button. The duplication here is because all Windows forms has all the controls, whereas Common Controls is a smaller subset of that has the most common ones. Kind of makes sense. So there's not two different buttons here. They're the same button. It's just where it comes from. In this case, let's grab the Common Controls button. I'll make this a bit bigger. I'm going to align it more like that for now. But before I go on, I'm going to change this to say this is the score button. And now let's change the flat style to flat. Let's change the flat appearance. We're going to change the border color to silver. We're going to change the border size. We'll leave the border size alone. We'll change the mouse down back color and the mouse over back color. So mouse down back color will be 102, 102, 102. And the mouse over back color will be 242, 242, 242. We can try that out in a minute. And then the font, we're actually going to change it to say semi-bold. We'll leave it at 16. And the fore color we need to change as well. Again, that's the 51153 255. Looks a little better. And now we'll change that to say score. There we go. So there's our score button. And that's pretty much it for our tournament viewer form. So we have our tournament and the name of the tournament. We have the round dropdown with which round we want to view. We can check a box that says only show us the unplayed games in this round. Then we have this matchup list that shows up all the matchups in that round. And then if you select one of them, it's going to highlight and say team 1 is this team's name right here. And their score is this, if they have any score loaded yet. And then again, team 2 and their score, if any. We can also fill in these boxes to give the score and then hit the score button. And that will complete that round for that matchup. And it will say, okay, who won based upon the score. So that's our whole page. Now let's see this in action. But in order to do that, we open up Solution Explorer. And right now, the tracker library is bold. That means that it is the project that will be started when we hit this start button. The problem with that is you can't load or run a class library. It isn't an independent project that can be run on its own. So this tracker UI is the one we want to run. So we're going to right click on tracker UI and say set as startup project. Now we hit start. And here is the form. Notice it's a little bit different than even the designer looks like. And the reason for that is because this is actually taking the settings from my Windows and applying it to this bar up here and these icons. So these are actually Windows 10 style icons and bar. So that looks pretty good. Also notice the mouse over changes the color of the button a little bit. And if I click on it, it changes to even darker. So that gives us a really clear indication that button was clicked. So that's form 1. Let's move on to form number 2. This should go a bit quicker as we continue to move and as we go over things you've already covered, so I won't have to explain them. So we're going to add a new form. We're going to call it the create tournament form. And again, go into the properties. Let's go ahead and pin this. And the text of the form we're going to change to say create tournament. The font we're going to change. And then the back color we're going to change as well. We'll change it to white. And that just mirrors what we already have over here. Oh, one more thing, and that's the icon. We'll use that same icon. Now we can do a little bit of shortcut in the fact that if we come back to our Solution Explorer and open up our other form, which is actually open up here, we can come back over here and start copying and pasting. We can actually notice it's already labeled header label. So we can just say create tournament. And now that is the right size for label, and it looks just like the label over here. Now we need the tournament name label and text box. So let's grab these two right here. I'm going to copy and paste. I'm going to say tournament name. Tournament name label. And tournament name value. And this is where the user will enter in the tournament name. Let's make it about like so. Next we have the entry fee. Let's align those two there. We'll call this entry fee label and entry fee tech or value. I'll come back over here and say entry fee. Get the alignment right. And that can be smaller. We'll also default that value to 0. Next, we need to have a drop down. Move that up a little bit. We need to have a drop down with a label. So let's grab these two. I'll copy and I'll paste. I'll put it above. I'll line it up like so. And this, we're going to say add team. I'm sorry, select team. The add team label will go next to this label here. So this is the select team label. And the select team dropdown. We'll make this dropdown a little larger, about the same size as that text box. It's probably good. Now the next item, the create new team, I debate a little bit on how that should look. And we can definitely discuss this in the comments if you'd like below. But this create new team link, I decided to make it into a link label, which by default is this blue color, which I thought about changing to maybe one of our accent colors. But the problem I have with that is if I change it to an accent color, and I have a green accent color I could use, which would stand out, the problem is that we've really been trained with the web that a blue text that's underlined is a link. And it's very obvious you click on a link to go somewhere. We kind of know that. And so to change that coloring to something that would be maybe more in line with our color scheme really would actually have a jarring effect in some ways. So there's a debate there. You can have it. I'm not a designer. I'm not really great at making things look wonderful. So you can kind of figure on your own if you want to do that or not. I'm going to leave it as is. Now let's say create new. I kind of pull that over so it's actually over the drop down. And these don't look quite right. There we go. Looks a little better. So now we have the tournament name, the entry fee, and then selecting a team from a drop down or creating a new team. And then we have a button. This is add team. So I'm going to copy that button, I'll paste it in. And I might actually play around with making it wider but flatter. And we'll call this add team button. And that looks pretty good. So I'll copy that and paste it. And then down below, I'll line it up. And this will be the create prize button. And the text will say create prize. Now over here, make it a little bigger, we have a list box. I'll copy that and paste it over. Really didn't need to probably since it's just a list box, but it doesn't really hurt. But I will change this name to call it Tournament Players List Box. And then I will put a label above it and call it Tournament Players Label. And let's actually shrink this up just a bit. You can count the number of rows if you want by how it clicks in. So that's 1 row, 2, 3, 4, 5. You can probably leave it at 5. So team slash players. And the other thing you want to do is you want to, let's pull this over a little more. We don't need to waste space if we don't have to. There is something they said for having some white space and some kind of breathing room in your form. But at the same time, you don't make it so open and empty that it's hard to see on a screen. It has to be huge in order to be visible. So there's that balance you have to reach. All right, so let's grab, I'm actually going to grab this button over here. I like its height a little better. Paste it over here. And I will put it right here for now. I'm debating if I put it here or if I put it up here. But let's leave it here for now, or maybe I'll even center it a little bit. Just trying to align over there with that bottom. I'm not sure that's right or not. I don't think it is. I'm actually going to select it and hit the down arrow. Kind of make it a little more in line. I could, again, align the middles of these two if I wanted to. In fact, let's see if we can do that. I hit this align middles button right here. And I kind of move this down a little bit, which actually means I need to realign this and then move all of these up to align again with that over there. So it's a whole lot of moving around for just that little bit of twitch, but that's okay. Some people will notice that and be off-put if it's not quite right. It's not me, but that's okay. I'm going to copy this and paste it and line it all up. And I'm going to call this prizes label, prizes list box, and we'll call this delete selected prize button. You can make these long if you want. The names really should be a little bit descriptive of what they do. I would recommend against abbreviations. Abbreviations are more confusing than they're really worth. We'll say delete selected. And actually move us down a little bit. And that throws the whole thing off, and that's okay, I guess. We should do the same thing here. Delete selected. We called this the delete selected prize button. So we'll call this the delete selected players button. Actually, selected player button. And then we'll make this a little bigger. We'll actually match these up. And it looks like about the same. So now let's make them kind of line up with where they should go, and I think we're good. Looks about right. So now we have our delete buttons, we have our list boxes, we have our labels. The only thing left is a button down here that says, let's give it a name first, the create tournament button. And we'll just say create tournament. Make it a little bigger, stand out a little more. And there we go. And that is form number 2. Let's move on to form number 3. So we're going to add Windows form, and we'll call this the create team form. And again, we'll go to our properties, say create team. We will change the icon. We'll change the font. And we will change the back color. There we go. Again, we're going to copy and paste from our previous forms. So we're actually going to copy this header label and this first text box and label right here. So I'll put them up there. I'll call this the create team. And this we will say team name. Team name label. And the team name value. And then we will do actually a drop down. So let's grab this right here, and actually the button as well. I'll copy those and paste them. Line up the labels. And we'll say select team member label. And the select team member dropdown. And the add member button. Add member. Select team member. And down below, we actually had this box around a set of controls. So let's build that. The way I do that is through a group box. Now it's not in the common controls, but if you type for group box, it's either in containers or all Windows forms. So let's drag this on. Now what this does is it puts a visual boundary around our stuff, whatever it is we have on here. Now, there are more benefits than what I'm using it for. I'm basically just using it for a good delineation to say, hey, here's a group of stuff that all goes together that's not really connected with the rest of the form directly. It's kind of like a subform almost. So that's all I'm using it for. But there are more uses. You can move the whole group around very easily. And it even has its own label and so on and so forth. But for now, I'm just going to say this is the add new member box. Now right now that's our standard font with a standard font color. I am going to change that, but I'm not going to change it until after I put my stuff in here. Now since I'm copying and pasting, it's not as big a deal, but if I were dragging new stuff in here, it would be kind of a big deal. And the reason why is because anything dragged into here will inherit this item's properties. So I'm not going to change the font size or color until after I've brought everything in. So let's bring in, we have this right here. Let's grab this, Control C, Control V. And I'm going to say first name label and first name value. And we'll make this a little bigger once I figure out how large this is going to be. First name. That's going to be pretty big, so we'll move this over. Actually, make this box a little bigger. I was kind of hoping to keep this small, but I'm thinking this will have to do. We can always go left or right a little more easily on a monitor because typically monitors are in widescreen format. Not all the time, but most of the time anymore, they're widescreen. And so you have more horizontal space than you do vertical space. And so that's just something to keep in mind when you're designing your form. Which way do I want to kind of lean or bend? In this case, I want to kind of make it a little wider instead of making it longer by stacking these on top of each other. I'll copy and I'll paste this. I will say last name. And up here I will say last name label and last name text value. I want to say text because that's one of the ways I sometimes do it, but it really is just a value. And I'm going to paste this again. Let's go ahead and align these and then do another one right away. Now here's the danger in doing two at once. I could easily forget to rename one of these items. And I'll have a label 1 or a label 2 or a text box 1 or text box 2 floating out there. That's not ideal. I really, really don't like to see that. So just be careful when you're copying and pasting. Don't do too much without making sure you go back and rename right away. So I'll call this email label and email value and cell phone label and cell phone value. All right, there we go. And now down here I can say email and cell phone. I can say cell phone number if I wanted to, depending how long that is. That's a little long. Everyone knows what I'm talking about when I say cell phone. I could probably put just cell there or cell number, but cell phone's a little more professional, it seems like. So let's do that. And make that a little larger. I'll Control C and V on this button. And maybe make it a little smaller. Not too much though. And I'll say create member. There we go. And now I'll come back to this, change my font size to the label size, and then the color I will change to my 51153-255. There we go. And now I can actually click and drag and bring this up if I want. So I might want to do a little bit of. And then I can actually, if I select one and control and select the other, it selects both for me, and they don't have to be next to each other. Because if I do this, I'm actually selecting the labels too. I don't want that. I just want the items, and so I select one and then hold down control and select the other, let go of control, and now I can drag and move these around as I want. So there we go. So now they're a little larger to match my box down below. And I can even move the add member over a little bit to better center it. And I can also bring all of this up just a smidge to better align with the create team. And now I need a list box on the right, which I can just copy from here and paste over here. Align it like that, so. And then I'll actually make it the same height roughly as this box over here, which in order to make the same height, I'll actually drag it down a little bit and then move my button down. In which case I have a little more space to make my button the same width. So there we go. So now I have the tournament player list box. I'll actually call that the team members list box. So I have a team members list box, which we're going to select team members or add them. In either way, they're going to be added to this box over here. We'll also need a delete button for this. So let's go ahead and grab one of those. Copy, and I'll come over here. I'll stretch my form out, and I will paste that in, and I will roughly center it there. And I will say delete selected member. And then finally we have this button at the bottom, which I'll probably have to scroll just a bit for. And I will say, instead of create tournament, I will say create team. And there we go. And there is the create team form. Now, right now I'm scrolling a little bit, but that's mostly because it's kind of shrunk down into the Visual Studio IDE. And so I can probably, that'll be fine on the page itself, as long as you don't have a small monitor. And that is the assumption here, that the monitor is smaller. But that's a pretty safe assumption these days. So let's move right along to form number 4. Right click on our project, say add, Windows form. And this is the create prize form. The first thing we do is go to our properties. We're going to change that to say create prize. We'll change the icon to be our icon that we're using. We will change the forecolor. I'm sorry, not the forecolor. We'll change the back color. Let's change the correct color here. Change the back color to white. We'll change the font. It's 16 point. And now we can create the create prize form. This one's pretty simple. We'll just grab this and we will grab, well, let's do this for now. We'll paste this in. It's still called header label, which is good, but we need to change this to say create prize. And now we need to grab, let's grab actually this one right here. We'll paste and put it right here. Make sure that's aligned. There we go. We'll say that this is place number. Place number label. And this is the place number value. We'll move this over. Now what we need to do is copy this and paste it 3 more times. Those don't look like they're in line. So here we can do. We can come over here and say make vertical spacing equal. And that makes a mess of things. So we hit undo. We select only one of the items. So let's just do the text boxes here and say make vertical spacing equal. Move that one down. And then we'll also say align lefts. Move that one over. And so now we can say, let's move this one right here. And then again, just start aligning all of these based off the first one. That last one does not want to line up. There we go. And then actually we're going to move this one down. So move it straight down to about here. So this is going to be the place name label and the place name value. And this is going to be the prize amount label and the prize amount value. And or this is going to be the prize percentage label and the prize percentage value. Let's go back and change all this text. So that's the place name, the prize amount, and this is the prize percentage. Next we have to add one more label, so let's just copy this and paste it. That's actually about right. And we'll do the dash or dash like so. And we'll move this around until it's about what we like. And we'll just call this the or label, just to give it a better name. And then finally come over here, grab our create team, button and paste this in, put it about the center, call it the create prize button, and say create prize. Looks a little big for this form. Well, you can address that if you want to, but I think that looks okay. And it keeps the same approximate size as all the rest of the create buttons, the big ones. So that leads us to conclude form number 4. We only have one more to go. So let's right click on Tracker UI, say Add, Windows Form, and say Tournament Dashboard Form. We'll go to our properties. By now you should be kind of familiar with this. We say Tournament Dashboard. Let's see if I can get it all right. Tournament Dashboard. We change the font. We change the, I'm sorry, that's the icon. We change the font. I'm getting ahead of myself. I have no clue how to pronounce that. Is it Sago UI? CGO? I don't know. Whatever it is, it's a cool looking font. And it's 16 point. That's what we want. And then finally, we want to change the back color to be white. That's our form. We'll actually make it a little bit smaller when we're done, but we can start with that. So let's grab the header. And this is going to say, and I actually centered this, so let's first change the text to say Tournament Dashboard. And so we can actually center that if you want. If we want to center that, we just say Format, Center and Form horizontally. That moves it over to center. And then we can say we want to drop down, and so we need to come over here, grab this, we'll copy it, we'll paste it. And if we're going to keep our centering format, we'll do that. So we can center all of these like so. And we can say for this, it is the load existing tournament label. And this is the load existing tournament dropdown. And we'll have a button below that, but first let's change this text. It says load existing tournament. Okay, we'll center these in a minute. I centered them once, and every time you change things, they have to be redone. So let's just wait till the end. Now I need a button over here. So I'll take this and paste it in. I'll put it down below here. I'll say load tournament. Load tournament button. And then we have to have that big one. At least that's the design we chose, which is create tournament button. All right, we can kind of move this form around. We can select all of these. I need less space here. Let's drag us down. Move us all up. We can say make vertical spacing equal. That's not really what we want, but instead you want to align the centers. And then shrink that down and maybe even move it up a little more. And then adjust our form accordingly. So there we go. Now we have our last form. This form is going to either select one of the existing tournaments and then load it, or create a new one. Now, the one thing I didn't really point out beforehand, but that I want to go back and talk about is this idea of, you're copying and pasting and creating all these different items. It's very easy to forget to rename one of them. But if you come over here to the properties, and if you do this drop down here, now notice how many things are in here. That's pretty impressive for this little form. But look at all the different names. If you see, group box 1, select it, it selects that group box, and now you can actually rename this to be something more intelligent. Let's say add new member or group box. So that's a great way to make sure that you haven't missed anything in the naming by just looking through here and making sure there's no 1s or 2s or anything that you don't expect to be there. Again, you can come here and very easily go from form to form and make sure that they're all the way they should be. Once we're done, we save them. And actually, the one that we need to change is this form is actually the first form that starts when the project loads. So let's go back to our Solution Explorer. And let's kind of collapse all these forms down and go to program.cs. And where it says new tournament viewer form, we want to say new tournament dashboard form. So now if we run this, I'll bring it over here. This is what starts up. And this is the starting point for our application. Now, in case you're not sure why I did that or how that works, if you're familiar with the console application, we know we have a static void main, and that's where all of our code runs. And once static void main is done, the console closes. Well, a Windows form is basically the same kind of design in the fact that we have a static void main. And that's actually inside of program.cs. That's right here. And once this method is done, the application closes. And so we have these 3 lines of code. The most important one for us, since these are basically saying just do what Microsoft's already set up. But this last one here says application.run new tournament dashboard form, which creates a new instance of a tournament dashboard form. But what that does is it actually pauses the application right here. At least it pauses this thread or this method, and it says don't end this line until this instance right here closes. Which is why when we start this up, we're running this form right here. If we ever close this form, the application closes, even if we have other forms open. So that's just a quick tip. You probably already knew that, but I wanted to point that out just to make sure. Also note, this right here, XML code comments, something that Microsoft did, not us. But it's just one more indication that yes, you should be using XML code comments. And in fact, when we come back through all of these projects, these forms, and view their code, we'll actually add our own XML comments to all of our methods that really need it. Anything that's being called outside of that form. So that's it. That is our form design project. That's really all there is to it. It went really quick in some ways, and in some ways it took a little long. But mostly the reason it took so long is because we actually talked through why we do things and how we do things and those kind of things. But the actual form creation process, once we got through the first couple and we covered all those topics, went really quickly, especially when we're copying and pasting. That made life a little easier for us. Welcome to Lesson 8 in the C# from Start to Finish course. My name is Tim Corey, and today we're going to look at our SQL database design. Originally, I had planned to go into logic design directly and assumed that you understood where the data came from. But after thinking that over, I decided that we should at least look at the design and structure of a database and then go from there. You could consider this a bonus video since it's not really about the C# project, but it is kind of important to understand if you're going to build this on your own. Now, if you aren't familiar with SQL, this video isn't going to be a comprehensive overview. I'm actually developing a start to finish series on Microsoft SQL databases that should be out shortly if it's not already. Instead, Today, I'm going to walk you through some of the basics on how I built this database. Everything is scripted out, so if you purchase the upgrade for the course, you'll get all the scripts along with the items in the package. So let's jump right into our diagram. So here we have our database diagram, and it looks a little complex, but don't worry, it's not that complex. What this is just showing us how all the different tables relate to each other. And I bring this up not to scare you away or to just confuse you, but instead I want to point out a couple of things. Again, I'm not teaching you all about SQL today. I'm just giving you an overview. But I do want you to understand how this is designed and how you really should be thinking about a design for a database. So for example, let's look at the team members right here in the middle. Notice that this is being a list of all the members for a given team. But you don't see a person here, first name, last name, all the rest. You see a person ID. And that links back to the people table with its ID. And notice the link right here. This is a one-to-many relationship. And so in the people table, first name, last name, email address, and cell phone number are all listed as columns. So you could have a person in the people table with an ID of 1. And you could reference that person more than one time in the team members table. The benefit of that is the same person could be on more than one team. For example, if there's 2 different tournaments going on at the same time, it makes sense that the same person is on 2 different teams. Or if a tournament has closed or ended and the next tournament has started, you wouldn't want to recreate that person, but instead just use the same person and add them to the next team. So the idea here with our design is that we don't store a whole bunch of information that gets duplicated. Duplicates are really bad in a database environment. And the reason why is because if you have a duplicate record, chances are you'll update it in one place but not the other. And then you have conflicting information and which one's right, and you're not sure. Because if my first name is Tim and last name is Corey, and my email address was tim@corey.com, but then somewhere else in the database it said Tim, Corey, Corey@tim.com, which one's right? It's hard to see. And so this setup right here tries to minimize duplicate information by always using IDs instead of the actual person or actual object. So just note, whenever we try and store information, we try and store it in as tight a formation as possible, meaning we don't have as more columns as we need to. For example, if I were to say, you know what, we're going to have at least 1, but maybe 5 email addresses for people, I wouldn't add 4 more columns for email address 2, email address 3, email address 4, and so on. Instead, I would then create a new table over here called email addresses. And then I would have a column for person ID, which would be this right here, and then a column for the email address. And that way one person could have 1 email address or 5. But in this case, I'd say, you know what? We're only going to capture 1 email address and 1 cell phone number, and that's it. So therefore, it makes sense to put them here so we don't make our database design more complicated than it has to be. And that's the balance we always play with when we're developing a database design. So this is it. This is our database design. It should hold all the information we need. So we have the tournament information, the prizes, the entries, the teams, the matchup entries, the team members. That should be basically what we need for our entire database. But, you know, especially when you're designing these things, not really on the fly, but you're designing as you go. Usually you forget something. And so I'm actually building this course in a way that takes you through those kind of decisions. So that when we get down the road, you might find out, oops, we didn't include something. How do you put that in? Because that's real world. The real world is you never get something fully planned out before you have to put it into code. And so how do you take those modifications after the fact and put them into place? And so we'll do that with this database as well. Now let's turn it over to the SQL Server Management Studio. And that's here right now. Okay, so this is the SQL Server Management Studio for Microsoft SQL Server 2016 Developer Edition. Now what I love about this is the Developer Edition is free. You can go to Microsoft's site and download it. But yet the Developer Edition has all the same power as Microsoft's Enterprise Edition SQL Server. Now Enterprise Edition is really expensive for a developer or a single person to buy. But we don't need to put anything in production, because that's the one limitation this database has, is we can't use it in production. But for development purposes, it's free to use. So if you were in a corporate environment, you could develop in this and then push the changes to your quote-unquote real production server without an issue. In this case, we just need something for testing and for developing our application, and this will work just great. If you're not familiar, over here on the left, I've connected to my instance of SQL Server. You can actually have more than one instance of SQL Server on your machine at any one point. In fact, this right here is the ./SQL 2016 instance, which means that it's not the primary or default instance on my machine. Typically, the default is just the dot. And so this is actually the named SQL 2016 instance on this machine. And the reason why is because I also have an instance for all of my work development, which of course I don't want to give away to the world. So in here I have one database, the Worldwide Importers database. That's actually from Microsoft. They give you a sample database to play with, and you can download that by Googling it, Worldwide Importers Sample Database. But today we're actually going to create our own database. Now, there are a couple ways of doing that. First, you can right-click on Databases and say New Database. And it brings up this dialog and has a whole bunch of options here. But here's what I find, especially for a development machine. You don't need to deal with all of this stuff. Okay? Now, you could just fill in a name here. So if you wanted to, I typed in tournaments and hit OK, that would use the defaults for everything. Now there is here, this is the actual data file. And so you can set some defaults here, like the initial size, how large it will grow, at what size, and to what maximum size, and then where that's located on the disk. Now, if you're an actual DBA, you'd want to change this path location because you want to get the most speed you can out of your disks. And so typically what you do is you'd put your data file, that's right here, the data file, on one drive, and then your log file on a different drive. Now, we're not going to do that today. We're not going to worry about any of those kind of defaults because this is just for development, not for production use. Now, that's one way of doing it. You just hit OK, you're done. But I'm going to show you a different way. If you go to New Query, this right here is the query window, and it's the place where you should probably spend most of your time as an entry level or even through advanced SQL developer. I find that it's much, much quicker just to do things here than it is to try and mess around with the GUIs for most things. And I'll show you an exception in just a minute. So to create a database, you simply say, and I'll tab down here, and I'll say create database tournaments. Now notice the semicolon at the end. That's one of the newer things in SQL Server, and by newer I mean I believe it came in around 2008 maybe. So newer as in 8 years ago probably. But it's something that is usually left off by developers just because we forget it. But it really should be added to the end of every statement. Not the end of every line, the end of every statement. So create database tournaments. And if I hit execute, that says command completed successfully. This message window down here is where you see the results when you have results. You come back over here, you don't see the database yet, but if you hit the refresh button when you're on databases, it now shows the tournaments database. And if you open that up, you'll see database diagrams, tables, views, and all the rest. And if you open up tables, there's nothing in there. That's because it's a blank database. Let's go ahead and change that. What I'm going to do is I'm actually going to run all of my table scripts, since running scripts is really boring, but then I'll come back and show you how to create a table and then also how to create a table script. I'll be right back. And I'm back. Okay, so I've created now all the tables using my script that I will need for this database. Now let's take a peek at one of them just to see how a table is constructed, and then I'll build a sample table for you just to show you the process that I go through. So let's look at prizes. I'm going to right click and go to design. And the nice thing about the design view is it shows us an editor for editing our tables instead of having just the SQL script. The SQL script can be a bit daunting. In fact, let's go ahead and look at the SQL script for this prizes. There's a SQL script. That's a lot of script, okay? And even remembering just this part, which is all we really need to worry about, this up here is nice, but not necessary necessarily. But even just this much is a little intimidating, especially when you're a C# developer, not a SQL developer. Because C# developers have to do some database work usually, but that's not our primary love. And so if we can get away from this, if at all possible, we probably want to. And that's where this designer comes in. This designer really makes things easy. So what I have here is my ID column. These are the column names right here. And so let me see if I can zoom in on that for you. There we go. So here's our column names. So my ID column, which I call ID, and that's a standard that I have. You don't have to have that standard, but I call it ID, and then anywhere else I typically call it prizes ID. So that's an integer column. That's the data type. So these right here are data types. And that's what you're familiar with when it comes to SQL. It's just they're named a bit differently. So my ID column is first. It's a type int. It does not allow nulls, meaning you have to put a value in there. And then this key right here indicates that's the primary key. And the way you mark that as a primary key is over here, you'll see this little key icon. And you click that to add, or in this case, remove the primary key from that column. And what a primary key does is it says, this is what we're going to order all the rows by. And why this is important is it allows SQL to optimize the database or optimize the table. If we don't have this, SQL does what's called a heap. And it's basically just what it sounds like. It just throws rows on top of the heap. But then every time we want to look for a row, it has to go sorting through that heap as if it was a garbage dump. Now, this is a key that we create. And in fact, this column right here, ID, I set as an auto-incrementing column. If we zoom out here and come down here, I'll pull this up. And down here in the identity specification for this column, we have, yes, it is an identity, and the identity increment and seed. The increment is how many we count up by. So in this case, 1. And the seed is the starting number. So the very first item is going to be number 1. And the next one will be 2, and then 3, and then 4. Which makes sense. We're just going to count up. But what that does is it gives us a unique identifier for every row in our table that SQL will sort by. That also means when we add a new row to our table, it knows immediately to add it to the bottom of our table because it has the highest number. You see, there's a lot that goes on behind the scenes when it comes to a table and how it stores information. And we want to make sure that we optimize our tables for most efficient storage and retrieval. And this seems to be the best way of doing that, creating this ID. Now, There will be obscure edge cases where that's not the case. But, and here's the deal, you're a C# developer, probably. If you are, and you're building databases, it's not because you need to build the most totally optimized database on the planet. You need to build a good, really good database. And this is the way of doing it. If you have your SQL developer friends say, hey, this is a much better way of doing it, which there isn't a much better way, but maybe a little better way of doing it, tell them, great, go ahead and build one. But this is the way that gets you the 98% of the way towards optimized for about 2% of the effort. So go ahead and do that. The next thing is the place number. Again, it's an integer. That's for our prize, it's going to be first place, second place, third place, but just the number. So 1, 2, 3, 4. Again, we don't allow nulls. The place name. Now this is a little bit interesting here, and I want to point this out for a minute. This is where you put the place text. So first place, FIRST space PLACE, first place. So we need to have a text field of some kind. In C#, that'd be a string field, real simple. But in SQL, where it's all about data, we have to optimize for what type of string do we want. Now, there's a few different string types in SQL. There's nvarchar, that's nvarchar max. There's varchar, right down here, and there's other types as well. But in our case, I have chosen nvarchar. And the reason for that is because this is the type that best fits my data. Now what an nvarchar is, it has three distinct parts right here. The n, the var, and the char. So let's start with char first. Char means a character. So it stores characters, meaning any kind of character you want. Numbers, letters, special characters, they all fit in here, spaces. Var means a variable length, meaning this number right here, 50, is the maximum number of characters that this column will hold. But var means that it could hold 3 characters, 5 characters, or 50 characters. Now it can't hold 51, but it can hold 50, 49, 1, or even 0 characters. That's what the variable means. The counterpart to that, it does not have the var there, it's just nchar or char. And what that does is it says we'll always have 50 characters, whatever that maximum number here is. And so how it gets away with that is if you store, say, a string of 5 characters, it's going to pad that string with spaces afterwards. So it's going to have the 5 characters you gave it plus 45 spaces. All right? And there are times when that's useful, but typically I find that it's not useful, again, for about 95% of the times when I want to store text. So I always default to varchar or nvarchar. And that brings us to this n. The difference between varchar and nvarchar is the type of characters it can store. A varchar, without the n front, can store just the typical ASCII characters. But the nvarchar stores Unicode characters. Now Unicode takes up twice as much storage space in your database, but the benefit of it is that it allows for other languages characters. Now, I'm in the US. I typically deal with US English characters, and so if I were dealing with just US characters, I would do varchar for practically everything. But if you are dealing with an international audience, or you're dealing with the option to have international characters for certain things, you want to have this nvarchar. And so that's the difference. You'll see me use both kinds in this database. And that's because of whether I thought that I would be providing the strings or the end user is providing the strings and what type of strings they are. So that's the decision to make, because it does, again, double your storage capacity or storage space taken up by this data. And when you're getting into millions of rows, storage space is important. Again, we probably won't get a million rows in this project, but you know what? You want to plan for as optimized as possible right up front. Best practices. Okay, so we can change this number here if you want to, up to, I believe, 4,000. But there's also the option here of nvarchar max. And that's a bit different. Max will hold a ton of data. It's actually handled a bit differently than the nvarchar, because that max data is not actually stored with your row. Now, when you access it and use it in the database, it's connected and it doesn't look like it's any different. But in the back end, it's actually stored a little bit differently in order to allow for some optimizations. And that the max field will be for when you're going to allow the user to type a book. I mean, lots of information or other types of data. One of the places I use that is if I'm storing a JSON string in my database to be used in my front-end web application. I'll usually do an nvarchar max. That way I can store a very, very large JSON string without a problem. Okay, we have the prize amount. Now, just like C#, where we have the decimal versus the double, in SQL we have that same differentiation. So the prize amount is dollars and cents if you're in the US, and probably something similar, or at least as similar as far as the actual numbers is concerned in other places in the world. So we have what's called a money column. And that is that precise column, that decimal type in C# is probably the closest equivalent. But then down here I have the prize percentage, which is just a percentage. Think a number between 0 and 1. So, 0.28, 0.83, whatever. Therefore, that is a float. And that's the equivalent of a double in C#. So that's a table. That's how you create it. There's a few more things to look at. The biggest thing is the relationships. So back on the diagram, we saw that the tables were all kind of connected to each other based off of these ID numbers. And in fact, if you remember back in the diagram, or if you have the companion booklet, you can back and flip back to it. We have this ID field right here, the prizes ID, connected to the tournament prizes table. And how we do that? Well, right up here, I know it's kind of small, but let's zoom in here. This icon right here, it says relationships. Now, if you're dealing with a previous version of a SQL Server Management Studio, you'll see the icons are a bit different. In fact, this used to be a yellow icon. It might still be. Nope, it's not. So it used to be a yellow icon, but it's not anymore. And this is a little bit different. But if you mouse over it, it says relationships. It's the same one. So we're looking for relationships here. And we get this. This is our relationships editor. So what we do here is we say these two tables are connected. In this case, we have one relationship. We have the prize ID to tournament prizes table relationship. And if I come over here to tables and column specifications and click the ellipsis, all right, the foreign key table is the tournament prizes and the column is prize ID. The primary key table is the prizes table and the column is ID. Now it's, again, terminology is sometimes difficult to get through, but think of it this way. The primary table is the one that actually has the quote-unquote real ID. That's the ID we just created that says this is the unique row, okay? Think of it as row number 5. How does that relate to the tournament prizes table? Well, in the tournament prizes table, there may be more than one entry that has 5 for the prize ID. So therefore, the tournament prizes table is the foreign table. So primary is the one that has it just as ID. That's the primary table. The foreign table is the one that uses that ID. So what this does is it links these two columns together and says, okay, these two columns are related. They're the same data. So when I say 5 over here, I mean the record over here in prizes that has an ID of 5. Now you can get into some really fun relationships. I didn't in this database, but what you could say is enforce replication. And you can say what happens when an insert or update happens. So I could say if I delete an entry, what happens? I can cascade that delete. And so what that'll do is it'll keep my two tables in sync. For example, if I delete a prize, then I shouldn't have that prize ID used anywhere. And so I can replicate then, go ahead and delete all the records where 5 was used. Or I could set them to null or default. And the same thing with update, I could update the information here. So for example, if I were to change the ID in the prizes table, it would then update everywhere it said 5, it would now have a new number, which don't change your IDs. Let's just get down to the bare facts here. Don't change your IDs. Think of them as unchangeable. Okay, so that's relationships. Tell you what, let's go ahead and close this out and create a new sample table. Again, we could do the create table right here, like that, and keep going, but that's really complex and not something you need to worry about. Instead, right-click on table, say new table, and then just start filling it out. So I start with ID. I apologize, this is so small. Not much I can do with this editor right now. So I say ID, and then I choose int for the type, and uncheck this allow nulls, and come over here to the set primary key button to add that as a primary key, and then expand down here the identity specifications. I double click on the no of is identity. Saying that to yes also changes these two to the default values of 1 and 1, which is exactly what I want, so that's good. Now let's create a table that stores, I don't know, person information. So let's create a first name. No spaces in the column names, don't do that. Just like with variable names, just don't do it. I'm going to change this to an nvarchar. And a person's name, 50 is the default value. There may be a time when 50 isn't long enough. I'm thinking probably not the first name, but you really don't want to have to mess with this later. So let's put it as 100. And I'll say, no, you're not allowed to have nulls. Then last name, it's nvarchar. Again, for sure, 50 is not long enough for all names because don't forget, people hyphenate their last name. So if they had a long last name and they hyphenated it, you don't want to, as a database developer, be rooting for their hyphenated name to include Jones because it's short. You want to make sure that you have enough space for them. So let's make sure you just give it 100. The nice thing about the variable character is even though we can hold 100, if we only use 5 characters, then the other 95 aren't stored. So it actually makes our tables a little more flexible and small. So you still want to put some limits there, but you do have the option then of getting a little more buffer to your items. All right, no to allow nulls. Let's do an email address. Again, nvarchar. This one's a little trickier because I believe the actual limit here is 2,000, and that's really big. but I believe that's the limit that's put on email addresses. The reality is no one has, or practically no one, has a 2,000 character email address. But you should make sure that you have plenty of space for even extreme examples. So I wouldn't do 2,000. You could even have something on the website or whatever application you're using say, that's just too long. Pick a different one. Use a different one. Email addresses are free or practically so. So we can definitely specify something shorter. Let's go with, let's make it 200. That seems reasonably long. And then let's add a phone number. And just like with C#, this should probably be a text character. But in this case, I don't think we need to have the N for nvarchar. We don't need Unicode characters, probably, since they're typically numbers. And so let's just do a varchar, and we will make it a maximum of 20. Now, the phone number, maybe we don't have phone numbers for everybody, or don't want to require that, so we can allow nulls for that. And then let's create another column. This column we'll call number of kids. And so we'll do an int. We're not going to allow nulls here, but we're going to put a default in. Now, probably my guess is that if we looked at every person in a reasonable group of people, the default number of kids would be 0. Because the people who aren't old enough, who aren't in a relationship or haven't been yet, as well as people who haven't had kids or whatever. So, and again, this is just an example, but we want to have a default value here instead of null, but we don't want to fill it in every time. We can put a default value right down here where it says default value or binding, and we'll set that to 0. All right, and it puts it in parens. Now it's the default value when we create a new record. All right, add one more. The create date. And there's actually a couple different dates and times and other things in here. There is date, date time, and date time 2, and then date time offset. I choose to use date time 2, and here's the reason why. Date is just the actual date, not a time as well, which for a create date for this row isn't good enough. Date time is the old standard for storing date and time. Date time is the new standard. So use a new standard. There's a reason for it. And then I don't need to store the date time offset. So let's store the date time 2 here. I will uncheck the allow nulls, but then down here for the default value or binding, I'm going to put get date time. And that throws an error. I want to cancel my changes. It's actually get date. There we go. Get date. I have a hard time switching between SQL and C# sometimes. So get date will get the system date and time for this unit. So wherever the SQL server is running, that's the date and time it gets. Now, if you are dealing with any kind of overlap between different time zones, it's a much better thing to do a get UTC date here. What UTC date will do is it will get the date and time with a time zone modification of 0. So that way, no matter where you are in the world, it's always the same time when it comes to relationships. So if I was using this database in California and then somebody else used a database in New York, they might have the same time, but because it's different time zones, it's actually 3 hours difference. And so this get UTC date would eliminate all of that. And it's usually not a problem, but in case it is, that UTC will really save your butt. So just note that if you're dealing with any kind of crossing the date line where maybe you have a SQL database on the East Coast and one replicated on the West Coast, and you use both of them, that would be a problem. So in that case, get UTC date. But especially for desktop applications, that's not a big deal because you're dealing with local databases usually. In that case, get date works just fine. And I'll leave get date in. Okay, so that's it. Let's go ahead and save this. And I will call this test person table. So test person. And now I can say from my query editor, let's go ahead and refresh this over here. If I were to say select star from test person, notice it's going to yell at me because I don't know who that is. If I do Control Shift R, that should refresh my well, it should refresh my window. It's not. That's okay. So what we can do is close it out and open up a new query window. Select star from test person. And now it's updated. And I can hit F5 and see there's no records in my table. And we'll get back to the query syntax in a minute. But I can also right-click on my test person table. I can go design if I want to look at it again. Or I can say select top 1,000 rows, which will essentially give me just what I saw here. Only if there's more than 1,000 rows, it only gives me the first 1,000. Or we can say edit the top 200 rows. Now this works great because it shows us a new editor and we can enter stuff in right away. Let's just enter Tim, Corey, test at corey.com, 555-1212. I can put a dash there. Number of kids. I'll leave number of kids and create date blank. So right now it's yelling at me. I have not put anything for ID and I have not put anything for number of kids or create date. But I filled in all the other fields. So if I hit down here, it actually creates that record. And if I were to hit the Execute SQL button by right-clicking the white space and saying Execute SQL, or by coming over here to this button right here where it says Execute SQL, the little green play button. It's going to refresh this, and notice now my ID is 1, my number of kids is 0, and my create date actually has a date in there. And that's great. Now, if I wanted to, I could come over here and say 2 kids, and I mouse off it, and that works. But if I try and change this to be 15, 4, nothing. So the reason why is because I cannot modify the primary key when it's an auto increment field. And that's by design. There is a way to get around that, but don't. Just don't. Okay? So also notice that if I were to not fill in a field where I should have, notice the first name is not filled in, it's still null. Email address is hello@world.net, 555-1234. I'll leave the rest blank. If I mouse off it, it says no rows were updated. The data in row number 2 was not committed. And the reason why is because we cannot insert a value of null into the column first name. And so the insert has failed. Now, it allows it to come back here and modify this. If I didn't want to modify, if I want to destroy the row, I can hit escape. But in this case, I'll just put Jim and then mouse off it, and that works. If I hit my play button here, notice it now has a 3 for the ID, not a 2. The reason why is because we generated a 2 when we tried to enter the null for first name, last name of Smith. It didn't work, but it still held on to that ID number and said, nope, can't use that. Now, some of you may be saying, oh no, I need to get that back somehow. No, just leave it alone. Let it go. It's better that it's gone. You want to keep with the normal system that SQL does for auto-incrementing your fields. It will not hurt anything, and it will be helpful in some instances. Okay, so we've entered some rows here. A couple things to note. This editor right here edits the top 200 rows. Okay, when I said edit top 200 rows, which means that if you have 300 rows in your table, you will only see the first 200. That can be very confusing, especially if you're adding new rows and then refreshing and they disappear. They're actually there, it's just that they're below the 200 line. They're 201 or below. That can be really confusing. I've bumped into it a couple times, and there are other ways of inserting and updating rows, but it comes down to manual SQL scripts. They're not as bad as it sounds, but it's a little more complex than I want to teach you today. However, one more thing I want to show you is back here I did this select star from test person. If you're not familiar with the SQL script syntax, actually the first thing that you should be doing is thinking about where you're pulling information from. So what I always do is I just say select star from, and then I put my table, and I'll go back and change my columns if I really want to. In this case, star means every column. Now, when you're actually creating SQL scripts and you're optimizing them for best performance and all the rest, you don't put star. Because there's a few reasons. I won't get into the whole list of them. Basically, a true SQL, developer or DBA will probably yell at you for a select star. But again, for 95% of your cases, it's probably fine. So select star is probably fine. That just gives us every column. And then since there's no limiters here, it'll also give us every row. Now, when I right click and it says select top 200 rows, how do you do that? Well, select top 1000. Select the top 1000 star from test person. We only have 2, so it's not going to make a difference. But that would limit us if we had a million rows in this table. Whenever you're dealing with big tables, always make sure that when you're testing things out or trying queries, limit those things down to a few hundred rows. Okay, so I just hit the execute or F5, and I got my 2 records back here, my ID of 1 and 3, first name of Tim and Jim, last name of Corey and Smith, email addresses, and so forth. What else can I do with this? Well, we can also do a filter. So where last name equals Corey. Notice it's single quotes, not double quotes. So single quotes around Corey. What will that do? It gives us just the Tim Corey record. Now, if you said, well, I'm not sure I know the full name, but I know part of the name. Not a problem. Where last name like COR %. And that's the wildcard character for, I don't know. We run that, get the same results because COR %, Corey fits in those parameters. Now, if I didn't have that % there, it's not going to find anything because last name like, without a %, it's essentially saying equals COR. So we need to use that %. Also, unlike C#, if I were to type all lowercase Corey and execute this, it still finds Corey with the uppercase C. So C# would not have found that because lowercase c o r e y is not the same as uppercase c lowercase o r e y. So SQL is not dependent on case. It's case insensitive. All right, so there's the select top 100 or 1000 star from test person where last name equals Corey. If we take that out, now we can take it out by either deleting it or 2 dashes in a row makes it a comment. And I can continue on and say order by, let's do a first name. So select top 1000 star from test person, order by first name. This is skipped because it's been commented out. And there you go. If you want to add that back in, we take the comments out. And now it's going to order, but because we only have one record, we really can't see if it's ordered correctly or not. But it is. So that's the basics. If you wanted to take off a top 1000 and instead of having star, say just first name, comma, last name, those are the 2 columns we want. Notice the comma separation. We execute that. Notice now that we have first name and last name. And in fact, if we wanted to, we could say as first space name, as surname. What this as syntax does is allow us to rename the column. So if I execute this, now notice first space name and surname. It kind of blends in together, but it does say surname. So we rename our columns in our queries. That's very helpful because we can separate then the display to the user from how we store it in the database. And so we can actually hide, obfuscate, change, or improve the names of our columns right in our queries. Now again, there's so much more I can show you here, but this isn't going to be a deep dive into SQL. See my SQL from start to finish course for that. Instead, I just want to give you an overview of this syntax because next we're going to create all of our store procedures. Now a store procedure, its job is to link together or expose a database script or a table script to the end user in some way. And so I use store procedures for just about all of my data access, in fact all of my data access, because it allows me as a SQL developer to secure my database much more thoroughly and make sure that bad stuff does not get in your database. If you're familiar with SQL injection or all those type of attacks where people actually access from your front-end application, they access your database and destroy stuff or change stuff or access stuff, that should probably scare you. But if you use everything through store procedures and then properly secure your database, then the hackers have very little to no access to do anything you haven't explicitly said they can do. And I love that. And so whenever possible, I develop directly to store procedures, not to views, not to tables. So a view is like a query. That's up here. I typically don't use views, or at least not often. Instead, I go right to store procedures. So to create a store procedure, there's no fancy editor, unfortunately. Just right click and say new store procedure, and you get this. And that's a little complicated. Now you can take the comments out if you want. Makes it a little cleaner. That's just who created and when for what. But you still have this. I'm going to show you a little bit cleaner view that it's a little less scary, hopefully, and it actually has some relationship to our current tables. So let's go ahead and I'm going to add those store procedures in, and then I'll come back and I will show you how to actually look at them and even design them. Be right back. All right, I'm back. So I've created these store procedures here. There's, I think, 7 of them. Let's go ahead and look at this store procedure. Right click and say modify. That's probably the easiest way of looking at it. One of the benefits of saying modify here is if I say, you know what, I need to make some changes here, I can go ahead and change this in any way and run it because it's already set for alter. And so that's the first thing I want to look at. Ignore this stuff up here. And then also this right here, use tournaments, go, is just saying make sure you're in the tournaments database right up here. Because if you're in the wrong database and you add the store procedure, that's a problem. So, but we're in the tournaments database. So I called this, so alter procedure. When I first created it, I said create procedure. And that creates this procedure. Notice the red squiggly says, hey, there's already a store procedure of that name in the database. And that's because we've already created it. So if I want to change it, I have to change this to say alter. And that's all I have to do in order to then make modifications to this store procedure. I call it dbo.sp prizes underscore get by tournament. So this is for the prizes table. I'm saying get the prizes by tournament. So get all the prizes for this tournament. And then this is the value I'm passing in. So I'm passing in int, and I'm calling it tournament ID. Think of this as your parameter in your method in C#. So this is your method name. This is the parameter. This is the parameter type. So we have then the as and begin. This is begin right here and then end right here. Everything for the store procedure has to be between these two blocks, between begin and end. Again, think of these as curly braces. All right, so no count on. What that does is it doesn't send back to the caller the count of how many rows occurred. And that's fine. Just set no count on, just says don't send that extra bit of information unless you wanted it. If you wanted it, then you'd take that entry out or set no count off. But in most cases, I have not found this necessary to send back a count. Especially when you have a select query returns data. So if it returns 10 rows, guess how many rows were returned? What, 10? We can count. So there's no reason to have it send back 2 pieces of information when just one will do. And that one being our actual data. So in this one, I'm saying give me all the information from the prizes table, but then I'm joining it. And that's a little more complex. And so I'll walk you through it. Again, select, well, p dot star instead of star. Why p dot star? Well, I renamed the dbo.prizes table to be just p. That's the rename right there. And that way it makes it shorter. So instead of saying dbo.prizes.star, I say p.star. Makes things a lot easier. Why p? Well, p for prize. And then I'm doing the inner join. And what this does is it connects 2 different tables. And I'm connecting them based upon the prize table, its ID, so p.id, equals t. T is the dbo.tournament prizes renamed to t. So t.prizeid. It's just that same relationship we set up earlier. We're using it. We're saying this is the connection here. And then saying where t.tournament ID equals that ID passed in. So what's happening is I'm saying let's find out the link across these 2 tables and then only give me the prizes that are in this particular tournament. Now again, it's going to take a little bit to understand that, and that's fine. If you're confused, don't worry. You just have to use this, not necessarily understand it yet. Down the road, if you want to understand it and if you want to do more with actually creating store procedures, which I would recommend, then go ahead and watch my course on C# from start to finish. So this is our store procedure. Now, how do we call it? Well, it's a little different, and there'll be a little bit difference in C# as well. But let's create a new store procedure, and then we'll call that. Since we have this, the test person table with sample data in it. So let's create, right-click on store procedure, and say, notice, by the way, that is inside of the programmability folder, then store procedure. So right click and say new store procedure. Let's get rid of all the stuff we don't need first. When I create store procs for my company, I actually fill this information in or create a similar template and use it. But in this case, we don't need to do that. And then let's pass in or give it a name. So I'm going to say DBO. Now, what's DBO? Well, that's database owner. Notice that all of my tables have DBO dot. All of my store procedures have DBO dot. By default in SQL Server, DBO is your primary owner and primary schema for your tables and store procedures and views. You could change that, and in fact, if you use a sample from Microsoft, you'll see all kinds of different schemas. Instead of DBO, it'll be person dot or address dot or company dot. That gets a little confusing, and again, for a rookie person just starting out with SQL Server, don't worry about it. Put everything in DBO. So create procedure DBO dot. And let's call this, I always start with SP. Don't do SP underscore, but SP. SP underscore will confuse the system into thinking this might be a Microsoft supplied store procedure. And that's not good. It makes things longer to try and figure out, and it could have some naming issues. So let's call it SP test person underscore get by last name. Now parameters, let's go ahead and wipe all this out. And let's wipe out this comment as well. And we will wipe out this as well. So it's a little more bare bones. Now in the parameters here, I want to bring in one parameter, and that would be last name. Because I'm going to get the test person by their last name. If there's more than one person with that last name, it'll bring more than one record back. So we will say at, because all variables in a store procedure should start with at. Last name, we'll say space, and varchar 100. Now, if you're not sure on the number, how big your last name should be, you can right-click on test person, go to design, and say, yep, last name was 100. You could specify in your store procedure less than the maximum. If you specify more than the maximum, you'll have a problem when it comes to inserting. So, but less than is fine. Equal to is probably the best. Since it's the same limitation, but it's really up to you. So last name, or at last name, space, and the type. If we had more than one, we'd put a comma here and say at, say first name, or whatever. But in our case, we only have one parameter being passed in. And then down here inside our begin, before our end, we will say select star from DBO dot test person. Now, do I need to do DBO dot? Technically, no. If I don't, then the system will say, I'll think it's probably DBO. And so it'll assume that and prepend it. But in this case, it's probably just a little cleaner to say DBO dot test person, where last name equals at last name. I'll put my semicolon to be complete, and we're done. That's our store procedure. I hit execute, and it says commands completed successfully. And at first, you might be thinking, if it's late or whatever, you'll think, wait, what? Why don't I see data? And you don't see data because this doesn't do data yet. What you're doing is actually creating a new store procedure. You're just creating a new entry here. If we hit refresh, you will see that test person get by last name is right there. And if we create a new query window, I can call this by saying exec dbo dot sp test person underscore get by last name. It's not there, so it's going to yell at me, so I have to refresh. And that's the Control-Shift-R, so it takes a bit. And I can say Corey. Now, even if the squiggly's there saying, nope, didn't find it, you can still run your query. It will still work. It's just that the editor hasn't caught up to the fact that there's new objects. That Control-Shift-R will do the refresh. It'll take a couple seconds. As you saw there, it took, 15 seconds or so before it actually refreshed our editor. Closing and reopening also works. So I'm saying exec. That's how you execute a store procedure. The name of the store procedure, the full name, dbo.sp test person underscore get by last name. Case sensitivity is not a factor here, so it could be all lowercase if you wanted to. And then after a space, I put my parameters, and I can either put them in order, or I can say at last name equals like so, and then comma separate in that way. I guess you should do them in order, and that seems to be fine for me. If you execute, notice it now says Tim Corey. And if we look up, I forget what the other person's name is, so you can select star from, and it's Jim Smith. So last name was Smith, and we execute that. Now Jim Smith is down here. So based upon what we select up here and run is what we get down here. So that's how a store procedure works. Now, one thing I haven't pointed out yet in the editor window, if I have this highlighted and I hit F5, look what happens. Could not find store procedure Smith. The reason why? Whatever you have highlighted in this window is what gets executed. So if I don't highlight the whole thing, then it won't run unless nothing is highlighted. If nothing is highlighted, then everything gets run. So for example, I could come down here. Let's just say select star from dbo.test person. If I can highlight anything and I hit F5, it executes the store procedure, and then down below it also executes our table, our select statement from our table. So both get executed. If I highlight just one, just that one gets executed. So that's another little tip for the editor window. So that's an overview of our database. That's really all there is to our database. I know it's a lot, but at the same time, it's not really. So I just want to give you an overview so you saw, again, this took over an hour to kind of give you a good overview of what's going on. But I thought it was important for you to get a good handle on things before you get into actually using this. Now, I don't want you to feel uncomfortable about later going into this and just poking around, seeing what you see, trying things out. Maybe you don't get as complex as store procedures, but maybe you can create a new table, try it out, maybe even try linking two tables together. I want you to feel comfortable at least seeing this data and seeing this data coming from SQL and not being concerned that it's a black box. Welcome to Lesson 9 in a C# from start to finish course. My name is Tim Corey, and today we're going to wire up our prize form. Now this is a simple form to start with, and it doesn't have many dependencies. Basically, it just takes data that you give it, it makes sure it's correct, and then it saves it to the database or text file. And that is where the first tricky part will come in. How do we know where to save it? Quite frankly, this is where you'll probably get stuck when you're trying to build an application. This is a spot that tutorials try to avoid or try to make sound easy. It isn't easy, but there is hope. We're going to tackle this problem head on because I want to make sure that you can know that you can do the hard things and that they can be made easier if you don't panic and if you break them down into very small pieces. Here we have our prize form. Now before we do anything, we need to plan out what needs to be done. You should always know what to do before you do it. And this is a great example of why. You see, initially this form seems simple. when the create prize button is clicked, this one right here, we take the data from these 4 fields right here, create the model, and save it. But where do we save it to? The database? A text file? Both? How do we know? Where does that information get set up? How can the code save to both types of storage without being, well, ugly? So let's start off with the ugly way that it might work. And let's just sketch this out in Notepad. And this is going to be a pseudocode just to kind of illustrate the first take at this, the first try at building this form. So pretend we've already done all our validation, because the validation is just simple. It says, is this a number? Is there text in here? Is this a number? And is this a number? And it's one of these 0. Okay, that's pretty simple stuff. And we say we've created this model. Remember, we have the prize model here. So we have that model. And let's just call that model, model. Okay? So we have that model, it's populated. Now what do we do with it? Well, we could say, if, and somehow know if we are doing a database using SQL equals true. We have our curly braces here. This is just pseudocode. It's not real syntax. So don't get overly hung up on making sure everything's right. But if we're using SQL, then open database connection, save the data, and maybe also get back the updated model, because we want to have, when we create an entry in a database, we get an ID for it. And so we want to have the ID back so we can say, okay, this particular prize is prize number 5 or whatever. So we do those steps and you'd say, okay, but then down here, if using text file, which again, we don't know where using text file or using SQL comes from yet, so we have to figure that out too. If we're doing that, if that's true, then we do something like this where we'd say open text file. We need to know the name of it and the path to it and all the rest. Save the data. But first you probably generate an ID, because text files don't create IDs. So we need to have some way of saying, okay, there's 5 records in the text file. The last ID is number 8. Therefore, this is number 9. Whatever it is. Save the data. And so now we've got the, if we're using SQL, it saves. If we're using a text file, it saves. And then we're done with creating this prize. But this code right here will work. Okay. Now, of course, you have to fill it out with real code. But this idea of a code, this is pseudocode. This would work, but think about all the places where we talk to our database. In every one of those places, we have to have code like this, where we say, if using SQL, if using text file, actually connect to the database. This form has to know what the database is and how to connect to it and all that kind of stuff. And the same thing with text files. It has to know about the text files and where they are and all the rest. But so does the create team form. So does the create tournament form. So does the tournament dashboard form, possibly. And also the tournament viewer form. These all have to know about stuff like this and do this kind of stuff. That's an awful lot of duplicated code, and it's quite frankly pretty ugly. I mean, imagine if we said, okay, we want to change where we're connecting to the database. Well, now you got to change this code right here everywhere. Maybe we say, yeah, we're going to add MySQL as a database option. Oh boy. Every form, we have to now add a third if using MySQL equals true, and so on and so forth. For every form. Multiple places for some forms, because some forms have more than one button. They do more than one thing. So this code isn't really scalable. It's definitely not dry, as in don't repeat yourself. So there's got to be a better way, and we're going to investigate that better way, okay? Because we don't want to write hard to maintain code that's quite frankly ugly and overused. All right, so let's start over. So the method that I use is to keep pulling the thread. Okay, what I mean by that is I take the issue and start asking questions. And sometimes I just write those questions down. And sometimes I get an idea or a thought and I'll write that thing down too as well. And then I start just keep working at it until I drill all the way down to the bottom of the issue or to a place where I can say, okay, I can do this step and then come back and pull that thread again. All right, so this isn't going to be easy because it's not something small. We're not doing just for this form. We're building a system that can be used by every form. What we do here determines what every other form in the database does. So therefore, writing things down and mapping it out means we're less likely to forget a step, and we're very, very clear on what happens. So the first thing we need to do is connect to our data source. So the question I have, and we're going to write this down, is this. How do we get that connection information? Remember in our previous pseudocode example, we weren't even sure where that came from. We just knew we were going to have it. Okay, so that's the first question that gets generated. But then that question leads to the next question is, how do we connect to two different data sources to do the same task? Okay, so part of this system, part of this application is we wanted to have the ability to save to either text files or a database or both. Okay, and so we want to be able to accommodate that, and really the actual act of saving is the only thing that's different. How we actually put it into a text file or into a database. But from this form's perspective, all we need to do is say, I have a model, save this. And then possibly get a model back that says, okay, we've saved it, and here is the ID along with the rest of the data you saved. Okay, so this form doesn't need to care if we're saving a SQL or if we're saving to a text file, or if down the road we're saving to MySQL. It just needs to care, I'm saving it. So the first question here though, how do we get that connection information? It sounds like we need some type of data that's accessible from everywhere in the application, and it tells us which data source to use. That sounds like a global variable of some type to me. Normally we try very hard to avoid global variables because they take up memory unnecessarily, but in this case we need something globally accessible for the lifetime of our application. And that's the exact definition of a global variable. So in this case, I'm thinking about using a static class to hold our data. Normally, again, you wouldn't store data in a static class because it's global information and anyone can change it. But since we want global information, I'm going to need to work on the safety part of the data, but I want to take advantage of the global use. And by making it a static class, I can keep all the global data in one place. So let's write that down, come down here. These are my questions up here. Down here I'll have just some notes. So I'm going to say that I want to have a static class for data source info. And this static class is going to tell me which data sources are available. Right now it's SQL or a text file or text files. That's going to tell me that and how to connect to those items. But before we build our class though, we need to address our second question. How do we connect to two different data sources to do the same task? The key here is you want to do the same thing, just with different data source. So if you need to do the same task, but behind the scenes, it will be done two different ways, you need an interface. Now an interface is a contract. What it does is to make a promise that any class that implements the contract will have the following items, whatever's in the interface. So those items are specified in that contract. Now I've got a video all about interfaces. So if you get a little bit lost here, or you want to get some more information before you continue, go ahead and check that video out and come back. But the best way that I have found to understand interfaces is to create one and use it, or at least see one created and put in use, because then it kind of clicks what happens. So now we have, and let's write this down, we want an interface. We want an interface for our data sources. So that's the bare bones of a plan to get started. We're going to create global variables to hold the data source information by using a static class. And we're going to use an interface so we can call either data source the same way. Let's start with the interface because we're going to need to do that in order to build a static class. We're going to have that interface. So over here in my tracker library, we want to move all of our code, if possible, into this library. Don't forget that one of our requirements is that we might not always use this WinForms application to track tournaments. We may use other systems like a web-based system. And so the more logic we can put into this library, the easier it will be later to create a new user interface to do the same thing. So in our tracker library, and you could create a folder for this if you want, I'm going to create it right in the root. I'm going to right click on my project and say add new item interface. Now, one of the pretty hard and fast conventions for interfaces is they start with a capital I. And that tells you this is an interface. And that's really important when you're actually using an interface. And I'll explain more in a bit, but let's start by just doing an I data connection. So anybody that implements this interface is a data connection, whether it's a SQL connection, a text file connection, or later on down the road, maybe a MySQL connection. And this is an interface. So the first thing I do is make it public. Let me go ahead and change that font to there we go. Let's make this public. So I have public interface iData connection. Now remember, this is a contract. And so in this contract, I'm going to specify what methods, properties, and other items that need to be in here. So in this case, I want just one method. And I'm going to say it's going to return prize model. And it's going to be a create prize method. It's going to take in a prize model called model. So this is a contract for a method. It looks pretty similar to a method, except for the fact we don't have the public in front of it, and we don't have curly braces afterwards. We have this semicolon. And that's because in a contract, in an interface, you only ever have public items. It makes no sense to have hidden contract terms. We don't allow that. We're not sleazy. Everything's up front. Everything is visible. And so therefore, we say since everything is public, nothing is public. Nothing is marked as public because it already is public. So it looks like a method otherwise, except for the fact there's no curly braces, just a semicolon. And that's because we can't put code in here. This isn't code. This is just saying that whoever implements iData connection will have a method called create prize. The code inside their method may be radically different. It doesn't matter. All we care about is that when you call create prize and pass in a prize model, you get back a prize model. That's it. So in this case, in the form, when we create this model, and in the create prize method or event, we say, I want to save this, we're going to call something that implements iData connection and say create prize. We're going to pass in our model, but it won't have an ID populated. When the processing is done, it'll return that same data, only now it will have the ID populated. because it's been saved either in the text file or in the database. So that's it. That's our interface. That's our contract. Right now, it's pretty simple because it does one thing. It saves prizes, or it creates prizes. But down the road, we're going to add to this contract as we have to do more things. But for right now, that's all we need to do. So we stop there. Now, let's move on to our static class. So again, I got to right click on Tracker Library and say Add Class. And that just selects the class up here. A static class is like a regular class when you create it. So therefore, let's call this global config. And now we're going to make this a public static class. What that means is you can't instantiate global config. It's always visible for everyone. So if you think of instantiated classes like a blueprint where you create the house off the blueprint, in this case, it's not a blueprint, it's the actual house. And everybody uses the same house, which normally means we wouldn't want to put data in there. But in this case, we actually do because we actually want global data. So let's create a property. We'll create it as a list of data connection. We'll call it connections. Now, two modifications here. First, we need to make this static. So now it's a static property. Next, remember I said that anyone can mess with this. Anyone can set it and change it for the entire application. I don't really want that. So I'm going to say private set. And what this does is it says only methods inside of this global config class can change the value of connections. But everyone can read the value of connections. So how does that help me? Well, I'm going to create a public static void initialize connections. And I'll start off by asking for bool database and a bool text files. All right, so here is where I'll actually initialize the connections. Now you may say, wait, Tim, you created a list of data connection. Why is that? Well, one of the things that I said we're going to do is we have the option of saving, we may save to both a text file or text files and the database, both. And so I created this list of data connection because we could have one or more data sources to save to and pull from. So that's what this is all about. This initialize connections method is what we're going to call at the very beginning of our application to say, these are the connections I want you to set up. And in this case, I've just had it pass in, do you want a database and do you want text files? Now, right now, this is not scalable, this method. It does two things, a database and text files. But in the future, if you want to scale this out, it'll be very easy to change this method to do something else. Maybe to have an array of items, or just to add one more, bool MySQL database, or something like that. But for now, we're just going to have these two. And it's okay to develop a method to do just what you need to do today. It's just a good idea to keep in mind what might come down the road tomorrow and make sure that you can still adjust if you need to down the road. You don't want to over-engineer your application to the point where it's unwieldy and yet it does one little thing, okay? But on the other end of the scale, you don't want to build your application just for today with no thought about tomorrow, because tomorrow the boss will probably come to you and say, I need it to do these extra things, and it makes your life miserable to try and redo it. So just think down the road and make sure that you're at least keeping in mind potential upgrades or changes for the future. So we have two Booleans passed in, the database and text files. What that's going to allow us to do is say if database. Now I could say if database double equals true. And that's more explicit. And if it helps you understand how things work, this is fine. This is definitely okay. But whenever you have a Boolean value, you don't have to do a comparison because it already is a Boolean value. Whatever's inside these parens has to finally get to a true or a false value. That's why we have the equals and not equals and greater than and less than. Because if we say I is greater than 0, the result is either true or false. But in this case, this variable is already only true or false. So in this case, if database, so if we're going to use a SQL database, then do something. Let's come down here and say if text files, do something. So a couple notes here. First of all, I didn't really do anything. I left a comment that says, do something with this. And in fact, what I would do is actually make this a to-do. Okay, and a to-do list will show up in your task list. See the task list down here? If you don't have that, go to your view, and the task list is right here. Okay, but the task list, now I have two to-do lists items. Create the SQL connection, create the text connection. So right now, I don't have anything. We're going to come back to this and put something simple, but we don't have actual classes to implement yet. We don't have anything that uses this kind of contract. So now we have to think about creating it. Now I want to pause here for a minute and say this. Don't give up. Some of you may be a bit lost, and that's okay. This isn't a simple tutorial. I'm not teaching you how to do Hello World. I'm teaching you how to build a real-world application. And of course, that may frighten you as well because you may say, oh no, if I can't do this, then I can never be a programmer. Not true. You can do this. But here's what I recommend. If at this point you're lost, just watch the rest of this video to see how it works. Don't stress out about it. Just watch it. Try and pay attention. Try and follow along. But then go back to the beginning. Watch it again. This time, pause the video every time I do something and do it along with me. Knowing the end result can help you understand what's going on, and repeatedly watching will help reinforce what you're learning as you create it alongside me. Now, it also means the first time you watch this, you probably shouldn't be building it along with me unless you're really tracking. And the reason why is because sometimes typing will distract you from what I've said and you kind of miss things. So I recommend if you're at all unsure the first time, don't type anything, just watch. Then go back and type a second time. All right? So that's just my aside. Don't freak out. I've done this for years. I know I can get you through this. So now that we have a static class, right? Well, here. Okay. So now we have a static class that holds our connection interface. And it has a method that identifies which actual classes to put in that list. And that's this down here. Now it's time to create those two classes. Well, sort of. We're going to make those classes, but we aren't going to create the full logic yet. Instead, we're going to create placeholder code that we can get back to finishing off our form. And as long as we put that code on our to-do list as well, it's fine to do. In fact, it's really good because we've been creating some code here. We want to make sure we can get to the point where we can actually use it to make sure at least the flow works. And they can start making it actual real code. So let's create our class that will connect to our database. Right-click on Tracker Library. Say Add Class. And this class we're going to call SQL Connector. make it public. And here's the interesting thing about this one. We're actually going to say colon after the class name and say I data connection. Now it's going to yell at me right away. And the reason why it yells at me is because we have not followed the contract. We said we're going to use this contract, I data connection. But there is no method in here called create prize. So what do we do? Well, if we select this, we can either use this drop down here or hit Control Dot. And there's this implement interface. So if we do that, and notice there's explicit interface and implement interface. Do the first one, implement interface. And what this does is it creates a new method called create prize. It returns a prize model and it takes in a prize model called model. Sound familiar? Well, this right here is this right here. So it said, okay, you got a contract here. Here's what the contract says you're going to do. Therefore, you can go ahead and create this method to do exactly that. Now, you could hand code this if you want, but it's pretty easy to just to say implement the contract. And the great thing is, as the contract changes, let's just pretend I add another contract entry here. Let's just do that. I'm going to copy this just to show you what will happen. We'll create a create prize 2. It's a horrible thing to do, but we're going to do it. We come back over here, and I did a contract connection. It's going to yell at us again. And it says, you're not following the contract. You're partly following the contract, but not the whole contract. And the way contracts work is you have to follow the whole contract. But if I do my Control Dot here and say implement interface, notice it only adds the extra method that I need. It doesn't touch the first method because it already has that method. It just says, what are the differences? What parts of the contract haven't you implemented? And I'll add those. So that's really nice. Let's take us back out. I'll save that. Now note, it's not yelling at me now because the contract is covered. I still have that create prize method. And I have this extra method now called create prize 2, which isn't in the contract, but yet it's in this class. And that's okay. You can have extra stuff in this class. You just have to make sure you at least have the contract stuff. So I don't really need this. I'm going to delete this. The other thing I note is this throw new not implemented exception. And this is brilliant. Microsoft has said, we create some code for you, but we don't want you to pretend like this code really works. But at the same time, we don't want to give you red squigglies. So what they said is, this method returns a prize model. They're not going to scaffold out a prize model and pretend to return it. Instead, they throw a new not implemented exception. So this code will compile. There's no red squigglies. But if I were to call this method, the first line it hits is going to throw an exception. And that exception is not implemented, meaning I haven't actually put code in here. This is a dummy method. And so that's a brilliant way for the system to have this method and yet at the same time not pretend like it's real code. But in our case, we're going to make a modification to this. We have to return a prize model, but we get a prize model in. So let's start by saying model dot. Now there's no ID yet, but we want that ID because in the database, and let's go there. In the database, we go to the table for prizes, we see there's an ID. And you want to capture that because that's what uniquely identifies a prize. So therefore, let's go back to our model, our prize model. And up here, I'm going to say prop int ID. All right. And that's the unique identifier for the prize. So now we have a new property. So I do Control J here to bring that list back up. I see ID. So ID equals, let's just say 1 for now. That's our sample number. Then we can return model. So now this method actually does something. Now, does it go out to SQL and save things? No. It just pretends like it did. And in this case, what I would do is come here. Oops. Yes, I should put my code comments, and let's just do that. All right, so there's my / comments, and those are great to have because it describes what your method does. That way, later on, you say, create prize, what does that do? Well, it saves a new prize to the database. But I'm also going to add up here a to-do. Make the create prize method actually saved to the database. Okay, and now I have in my task list yet another to do. Now you could say, well, but go ahead and actually do that. Make it save the database. I'm not going to do that because I'm already down a rabbit trail pretty far. Because remember, the original intent for us for this lesson was to wire up this form. And we haven't even looked at code behind this form. We've talked about it. We haven't even started there. Because first we created, our static class, and then we created our interface, and now we're creating a class. We still have one more to create. So that's a lot of stuff to do when really we're just trying to save our prize. So I'm not going to implement any more code than this. But now let's go and add the text file connector. All right, so right click on Tracker Library, add class, and we're going to say text connector for the name. And that is a class. We'll make this public. And we're going to implement, using the colon, I data connection. And again, control dot implement interface, which looks eerily familiar to our SQL connector. Now, before we go on, I also want to mention the reason why we put I in front of interfaces. And this goes back to object-oriented, because right now, this is just a contract, and you can have tons of contracts on one class. In fact, if we wanted to, I could say I disposable, and then add that interface, and that just adds one more method. So now I have 2 contracts on this one class. This contract says you must have a dispose method. This contract says you must have a create prize method. So we can have both of those if we want. But if we want to actually inherit from a class, which means we don't just bring a contract, we actually bring code with us from a class, we can only do that once. We can only inherit from one class. And so when you're inheriting, the first item here has to be what you're inheriting from before any contracts. But in this case, if I didn't call this I data connection, how would I know if this is my class I'm inheriting from or if it's a contract? The only way I know is a mouse over this and say, oh, yep, it's an interface, which only works if you're actually in this IDE inside Visual Studio. But if you're looking at this in a text document, that doesn't work. So it just makes it a lot more clear if you have this I in front of it. Every interface will have an I in front of it. That's very clear then to know this is an interface. Now, if the class you're inheriting from starts with I, say the class name is Indiana, maybe not the best class name, but it starts with an I, the difference will be obvious. And the reason why, let's type it out. Now, I don't actually have a class called Indiana, but notice my casing here. The N is lowercase. This D is not. You see the difference? That's how you can tell an interface from an actual class name, even if they both start with I. And that's why casing is important. All right, that's way off the rabbit trail. I just want to make sure that you really grasp that. And again, I have a video on interfaces on my YouTube channel. But here, we're going to do kind of the same thing as what we did in SQL Connector. In fact, we're just going to grab that code and do the same thing. Copy and paste. Now, saving to a text file is radically different than saving to a SQL database. But at this point, we're just doing sample. We're just saying, pretend like we actually saved it. So in that case, we don't need to worry about, differences. We're just saying, pretend like it works. And then I'll add my to-do here. So that I actually have a reminder to come back and actually do this, since this is sample code and not just that throw new not implement exception. And the reason why I did that is because I actually want to use this code just to show that it will work. Okay? So now we have both of our real classes, our full classes created. Now they're pretty simple, basic stuff. But we can come back to our global config, and here we can actually wire up our classes. So if it's a database, we're going to say we want to create a SQL connector, and let's call it SQL equals new SQL connector. And then we'll say connections dot add SQL. Now, this is going to break, and here's why. This list has not been initialized, but one of the perks of C# 6.0 is I can say equals new list of iData connection right in my property list right here. Now, if you're using a version of C# before the C# 6.0 came out, which it's really vague how Microsoft does this. It's very hard to find out what the C# version is versus the .NET version is and where they all fit. But essentially, if you're not using .NET 4.6, which I believe is Visual Studio 2015, if you're not using that, you can't do this. But never fear. If you can't do that, in your initialized connections, before you do anything else, just say connections equals new list of connection. It'll do the same thing. Okay? So you can do that if your code won't accept this. But this is a new way of doing things. So now I have created the connector and have added it to my connections list. I'm going to change my to-do here to set up the SQL connector properly, because there may be some initialization stuff that I need to do on that class that I can't do yet because I don't have any initialization stuff yet. So let's just make sure that we check that out at some point. We come back to that. And we'll come back to that in actually the next video. But for now, this works. Now I took SQL connector, that's the class type, I create an instance of that, and I added it to my connections list. But my connections list isn't a list of SQL connector. It's a list of iData connection. That's the interface. And so what this list does is it says, I'll hold anything that implements the iData connection contract, which is amazing because they don't care if it's a SQL or if it's a text file. In fact, let's do that. Text connection, text equals new text connection. Connections.add text. So now I've added my text file connection to my connections. And again, both of these are based upon if you said yes to this Boolean. If you said true to database and true to text file. So both of these can live inside of this connections list. Now, one last thing to note before we move on from this class is that I have two if statements. I didn't combine this into an if, else if. And the reason why is because in else if situation, if this was true, if database was true, we'd never add text file, even if text files was true. So you can't do this. Else if. That won't work because you'll get unexpected results. You'll only add a text file if you don't have a SQL database. Which, if you're saying, well, I only ever want to have one connection, then yeah, that's how you do it. That's one way of doing it. But that's not what we want. We want to have the option of having one, the other, or both. In this case, it's two if statements. Now, the final piece to all of this is determining when to call this initialize connections. Because remember, this is when we actually set up, do we have SQL, do we have a text file? So we should do that when the application starts. Now down the road, we may say, well, I want to change how that works. But for now, we know where the application starts. Down here in program.cs, this is where our form application actually launches from, the static void main. So we have 3 lines of code that Microsoft has created. Application.enable visual styles, application.set compatible text rendering default, and application.run new tournament dashboard form. This is where we determine which form gets launched as the startup form. Now this is going to be the startup form that we use for our application when it's finally done. This is the real startup form. But I want to modify that form in just a minute to actually point to my create prize form because I want to see that in action. I want to see it working. So we're going to change this line in a few minutes. But for now, before this line, I want to add this code. So I'm going to start by putting a comment that says initialize the database connections. And I'm going to say my class name, tracker library. And I don't think I have a reference to that. So let's right click on references, add reference. Go to projects, tracker library. Notice it says library. So I can feel free to check this box. That's my convention, but it's a way of making sure that you don't add the reference the wrong direction. You don't want to add a reference to your form in your tracker library. You want to add a reference to your library while you're in your form. So hit OK. Tracker library dot global config dot initialize connections. And now we're going to say, do you have a database and do you have a text file? I'm going to say true, true. For now, let's initialize with everything. Now that this is initialized, everybody can use that global information because it's global. So when tournament dashboard form would load, it would have access to the connection information. But I'm actually going to change this to say that I want to start up my create prize form instead because I want to see this working when I actually wire up that form. So I'm going to copy this line. because this is the line that I want eventually. Instead, I'm going to add my own line that is create prize form. So now, instead of the tournament dashboard form launching, when the application runs, it will launch the create prize form. All right, in fact, we can start it now and make sure that at least it compiles and it runs. And sure enough, the create prize form started. So now we can actually get back to our create prize form and actually wire it up. Amazing. It only took us like 50 minutes to get here. But that's how coding works. You really need to think things through, make your plans, and then implement them in that order in order to safely create your code. Otherwise, you create that weird, junky code that I talked about at the very beginning, that pseudocode that I created, that really doesn't work. All right? It doesn't work for scale. It doesn't work for maintaining it. It just isn't great. So again, let's come back now to our prize form. We're actually going to double click on this create prize button to launch this event. All right, so create this event called create prize button underscore click. So whenever we click this button, then this code will run. Now, what do we do here? Well, here, the first thing we need to do, let's close these other items. Yes, I'll save this. I'm actually going to open that form back up. All right, so we're going to validate these 4 fields first. That's the first thing we'll do. I'm actually going to create a private method. You don't have to do this, but I like to keep my events clean. So private void. Let's do a private bool. Private bool validate form. Now this validate form, we can run from anywhere. It doesn't have to be just when you click this button. So you could validate this form after this last field is filled out. And so this way, it just is on its own. We can call it from here and say, oh, you weren't valid. You returned false is not valid. Therefore, stop the process. So we return bool. So actually create a bool output equals false. Return bool. Output. So what do I do there? Well, I like to create this variable called output. And that output variable is what I'm going to return. In my case, I'm actually going to set this to be true. Now, I would love to set it to false, and then whenever I returned it, the form would be by default not valid. But it's just so much easier to say no, something is not right and set as the false than it is to say everything is right, set the true. And I'll show you what I mean by that. So this first field right here is the place number, and this needs to be an int, meaning a whole number, and it has to be 1 or greater. All right. So we can say, let's start with this, if int dot try parse, the string is our placeholder, our text field right here. So place number. So place number value dot text. Because remember, these are text boxes, not number boxes. Therefore, this is a text value, not a number value. So we gotta do a try parse. We need to give an out int result. Okay, so this out int result will be what we change the value to a number. So we have to create an int variable here. Let's call it int place number equals 0. And then we'll say right here, out place number. Now what this does, let's actually break this down into 2 lines, just to make it a little clearer. Control X and cut that. Bool place number valid number equals our int.tryparse. So int.tryparse, what it does is it takes a string, in this case, our place number value.text, the value of this text box right here. It takes that string and it tries to make it into an int. So say that value is the number 1. Then it will try to convert that. It'll say, yep, that converts. It will put that into the place number variable. Now this is an out. What that means is we can only return one value from our tryparse method. And so it says, I'm going to return a Boolean saying if this worked or not. But I also want to return the value, the actual number. Therefore, I'll do an out parameter. An out parameter goes the opposite direction. Instead of passing data into this method, we're passing information out. So I have to say it's an out parameter, and I have to say a name of a variable to store the information. If that's a little confusing, don't worry. We don't use out parameters anywhere else except for tryparse. And in fact, in C#7, which is Visual Studio 2017, we actually can change this and not use out parameters and instead return what's called a tuple, which is 2 values instead of just the one return value. But we're not getting into that today. We're not going to worry about covering that yet. I want to cover what works now and will work in 2017 as well. So in this case, we're going to return back a number here, which we really don't care about. We just care about whether or not this tryparse worked. Because you see, if this text would be the text ONE, which we all know that ONE translates, into 1, and that would represent a number. But when it comes to programs, they don't know that. And so they're saying it's not the actual number 1, it's a text. Therefore, this parse isn't going to work. But it's a tryparse. And so a tryparse doesn't crash when you get bad information. Instead, it returns a 0 here, and it says the actual method returns a false, saying, nope, it didn't work. So now I can take this Boolean value and put it right in the if statement. If place number valid number. So, but I don't really care about it being a valid number. I want to know if it's invalid. Because if it's an invalid number, I change this to be false. Now I could say bang place number valid number. And what that means is if not place number valid number, meaning if this is an invalid number, then do this. But that can be a little confusing, especially for new users. The other way you could do it would be to say double equals false. If the place number is not a valid number, then do this code. And one of the things we'll do is we'll say output equals false. Now, one trick here is do not put an else statement here. Do not say else output equals true, because this is only one of many checks. If the last check in line is valid, it would set the output to true, and then the whole form is valid. But that's not really how it works. Instead, we only set it to false if something fails. We don't ever set it to true because it's already true up here. So that's our first check. Checking to see if it's a valid number. If it's an invalid number, set the output to false. But the next check, if place number, that's the actual number that came out, is less than 1. Because remember, you can't have a place of 0 or -1 or so on and so forth. Output equals false. So if it's a valid number, but that number is -1, it's not a valid form. Now we can go on and validate the other items as well. The place name needs to have an actual name. So therefore, if place name value dot text dot length equals 0. Basically, if you have nothing in the place name value, then output equals false. Now in all of these, you could put some kind of logging statements or update the form. Maybe have an area somewhere, maybe over here or down below or something like that has all these error messages. And each time you get an output equals false, you would set an error message right here that says the place number is not a valid number, the place number is less than 1, the place name is empty. You could add those statements and then add it to some kind of form or field in your form. But in this case, I'm just going to say valid or not. All right, so in this case, we've done these first two fields, and then we have to have prize amount or prize percentage to be greater than 0. One of them does. All right, so we're going to do the same thing, but remember that the prize percentage is going to be a whole number because we're saying, okay, it's 15. If value is 15 here, that's 15%. Whereas this one here, prize amount, could be is a decimal. All right, so it's money. So we're talking about $30.15. Why? I don't know why. You'd think you'd want a whole number there, like 100, 200, 50, 10, whatever it is. But we have to allow for the fact that they might want to say, no, I want to give you $9.50, not $10. So therefore, the prize amount has to be a decimal. So let's create a spot for that. So we'll say decimal prize amount equals 0, and the other one, which is prize percentage, is a whole number. So int prize percentage. Now it could be a double if you're going to allow for 15.5%. But we're going to say no. You have to have a whole number here. We're going to say equals 0 again. And now we're going to do the same kind of thing we did up here with our conversion. So let's move this down a little bit. Let's say bool prize amount valid equals, and this is a decimal, try parse. It works the same way as the int try parse, it just converts to a decimal. And we're just going to say that the prize amount value, dot text is our string, and then out prize amount, that's our decimal that we're going to send this value to. And we'll do the same exact thing, bool prize percentage valid equals int dot try parse. We're going to say this is the, not price percentage, it's prize percentage. It's prize percentage value dot text and out prize percentage. All right, so make sure you get the decimal here and the int here because we're returning these values as. So that's important to get right. But now you can come here and say if prize amount equals false, prize amount valid equals false, or prize percentage valid equals false. And the reason you do both is because both of these should have a number in them. They should start at 0, but one of these has to have a valid number in it. So they both have to be a valid number, meaning they both have to have at least a 0 in them. So therefore, if either one is invalid, then output equals false. But then we're going to say if prize amount is less than or equal to 0 and prize percentage is less than or equal to 0. So what this is going to do is say, we could just say if they're both equal to 0. But that doesn't capture it because what if one of them is below 0? That would trigger a this is okay. But really, they have to be both, one of them has to be above 0. So this is saying if this one is at or below 0 and this one is at or below 0, they can't both be that. So if they both are, then output equals false. All right, and now we could do some more checks since we wanted to. One of the checks we could do is if the prize percentage is between 0 and 100, because it could be 0 if we're using the prize amount. But let's just do that. If prize percentage is less than 0 or prize percentage is greater than 100. Okay? Remember, a percentage has to be between 0 and 100. You can't have anything above 100%. So, if the tournament brings in $1,000 and you're saying, I want to give them 150%, well, that would mean that you are going to lose $500 on this tournament. That's got to come from somewhere. So basically we're saying, no, you can't allow that. So therefore, output equals false. So that's if the prize percentage is below 0 or if it's above 100. All right, so that's our validation. That whole code right there. We'll save that. So now we're going to say if validate form. So if it's a valid form, remember this returns true or false. Oh, and one more thing I want to note here. You could, instead of having the output variable and all the rest, you could just return false here, return false here. And the very bottom, return true. Some people will say that's better because it doesn't do all these other checks if the first one fails. The reason I did it this way is because that way it does all the checks. In a real application, you'd want to alert the user that they did something wrong. And here's what you did wrong. That's why I said, right here you could say that it's not a valid place number. You could put that in the form or something like that. And you do that for all the places where you say input equals false. So if you did that and you did the return false up here, you'd only check the first thing. So if this form were entirely invalid and they hit create prize, they get one message back saying, hey, change the place number. They do that, hit create prize, and get a different message back. They fix that, do that, they get another message back, and that'd be annoying. Whereas if they hit create prize and nothing is valid, they'd get all 5 or 6 messages at once. They could fix everything and then run it. So that's just a little quirk there. You may see it a little differently other places, but that's why I did it that way. Now I don't have those messages. It's just set up for those messages when I'm ready. All right, so in the prize button, click. If the form is valid, then we need to do something. Well, we need to create a model. And what model is that? The prize model. And it's right now yelling at me because it doesn't see a prize model. Well, I hit Control Dot and say use tracker library. And now it knows about it. So let's just call this model equals new prize model. And we can say model dot place name equals place name text, or I'm sorry, value dot text. Then model dot place number equals place number value dot text. And right away we have a problem because that's not valid. That's a string, but place number is an int. All right, so there's two ways you can go about fixing this. One way is we can do this try parse again. We can try parse the place number and also the prize amount and the prize percentage. That's a lot of work right in here. Or I can come to a prize model and I can come down here and I can create a constructor. Now this constructor is an empty constructor. And what it does is essentially nothing right now. It takes nothing in and it just says, do this code, whatever this is inside curly braces, which is nothing. That's cool. We actually want that because that allows us to do stuff like this. That's calling that empty constructor. Notice the no parameters. But now I want to do CTOR again. CTOR. And it creates another constructor. And it yells at me and says, you can't do that. But we can create an overloaded constructor. And that overloaded constructor says string place name, string place number, string prize amount, and string prize percentage. Now notice they're all strings, not numbers. And what this allows me to do is I can create this prize model on the fly and populate it and do all the parsing here once. And then anywhere that calls it can call this method and have the stuff parsed. So the simple one, place name, oops, capital P, it's important, equals place name. So I'm taking this parameter and putting it into this property. So that's the easy one. But now we need to do all those other parses. So int place number value equals 0. And then we're going to do int dot try parse. And we'll say the place number, that's the string being passed in. That's our string. And then out place number value. That's the string we're storing it in. And then we'll say, in fact, let's tighten this up so we'll have it all in one grouping. We're going to say place number, the actual property, place number, equals place number value. Now, I uncheck to see if this passed or failed. Why? Well, because I don't really care. At the end of the day, all I care about is a safe parse, meaning it doesn't blow up if you give me a string that's not a number. But if you give me an invalid string, I'm going to change place number to be 0. Because that's what the default is when it comes out of try parse if it's invalid. So I'm going to set to 0, which, guess what? That's the default for an int anyway. So I'm going to say, don't care about it. Just do it. All right? So let's do this again for our prize amount. Now, prize amount is a decimal. So decimal prize amount value equals 0. Decimal dot try parse place amount, prize amount. There we go, prize amount. And then out prize amount value. And then finally, prize amount equals prize amount value. So it's the same thing all over again, just for the prize amount. And then finally, I have the prize percentage, which the prize percentage is actually a double. Let's go back and fix this over here. Because here we said it was an int, all right, for the prize percentage. So let's just change this to be a double. And the prize percentage here, double. All right, works the same way. It's just now we're using double instead of an int. Okay, so back over here, we're going to say double prize percentage value equals 0. Double dot try parse prize percentage. And then out prize percentage value. The thing that you'll probably forget when you're doing this at some point is to add the out. That's what I forget half the time and then wonder why it's yelling at me. So prize percentage equals prize percentage value. So now we have taken these 4 string properties or string parameters and converted them if we needed to and put them into their respective properties. We save that, we come back over here to our form, and instead of doing all of this, we can take all of this out. And notice when we do this open paren, we now have a 1 of 2. And let's just zoom in on that for a minute. So if we do this, we get 1 of 2. That's because we either have the default constructor or this constructor. Now I left the default constructor because I want to have the ability to just say, nope, new prize model, I'll take care of populating the properties on my own. But in this case, I can pass in those 4 properties. So let's do that. Place name value.text. Next is the place number value.text. Next is the prize amount value.text. And the final one is prize percentage value.text. Notice how it scrolls off my page now. The way you can fix that is before the first parameter, you can hit enter, and then every parameter afterwards do the same thing. And now it's kind of a collapsed or a shortened version of it. It makes a little more visual sense. It's easier to read. So that's up to you. So now we're creating this new prize model, and it's immediately populating with the values we need without having to do all that conversion on our side. So now we have this. What's next? Well, once we have a model, we actually have to save it. So here's how we save our model. We say for each. We can say var here if we want, or we can say the actual data connection. It's up to you. And let's say db for the name. We're going to say global config dot connections. And what is that? It's a list of those connections. It's a list of data connection. So for each one of those that we have, we're going to say db dot. Now look at my options. In fact, let's zoom in on those options. I have the standard equals get hash code, get type into string, but then I have one method called create prize. What does that pass in? A model, which I already have. What does it return? A new model. So what I can do with that model is I can save that if I want to, or I can just ignore it. In this case, I don't need it at this point. Maybe later I will, but for now I don't need it. And guess what? We actually have a completed form. But are we sure it's complete? Are we sure that all that code he wrote is going to work? And I really get uncomfortable when I start writing, 50, 100, 200 lines of code without testing it. So the way to test it, we can put a breakpoint right here, the very beginning of our create prize button. Click and hit start. And that pops up our form. The very first thing I'm going to do is hit create prize. Well, it goes there. That's good. Now it's going to validate form. So let's step into, or F11. And it's going to come down to our validate form method. We can keep stepping through this. We can say the first one is try parse for a number value dot text, which is nothing. And if we step into again, we can expect this now and see that the place number value is invalid, it's false. Therefore, we're going to return output false. The place number is 0, so it's less than 1, it's false. The place name value dot text dot length is 0, therefore output is false. And we can keep going if you want to, but I'll just put a breakpoint down here and say continue to that point, hitting the green button, and then I'll step again and come back here, and it just exits out. That's all it does. So we'd probably want to add some kind of message there that says, hey, it's an invalid form. Let's actually do that, just a real quick one. Hit stop right now. Just a real quick one. So let's take our breakpoints out. And this time we're going to say, if it's not a valid form, else, and let's just do a very simple message box dot show this form has invalid information. Please check it and try again. And we could make that a little more fancy with the buttons we have and all the rest, but let's just do just that. If we launch this again, I'll move it back over to where it was. I hit create prize, and nope, it's invalid. Okay. We can come back over here though and put our breakpoint inside of the valid form. Now let's go back and put a place number, first place. The amount, the prize amount is $50. That's going to be 0 for prize percentage. Remember that 0 is the one we ignore, but you have to have a number there. We create prize, and hey, it's valid because it got to this line right here. Let's step into this, and notice it comes down to this constructor. We can say, all right, check that out. Place name is first place, that's good. We can do a try parse, and that seems to work because place number is 1. The prize amount is 50, that's good. And the prize percentage is 0. Great. And in fact, if we step to the next line, we can mouse over our model and see that all of that information has been entered. The ID is still 0. So now for each iDataConnection DB in global config.connections, let's go into this. First, we mouse over this and see that there's 2 connections, the text connection and the SQL connection. So that's great, we actually have something. So for the first one, which if we mouse over DB, it's the SQL connector, we're going to create that prize model. We're passing in our model. When it comes right to our SQL connector, and notice we're modifying the ID to be 1 now, and returning that model. Now we're not doing anything to that model, but at least we know that it actually pretended like it went to the database and saved it. Now we're looping through the next one, and that's our text connection. And again, we run this, and it goes to the text connection class, and it calls the create prize to actually save this model. Now it's not actually doing anything, but that's okay. And we're done. So we hit continue. This form is now working. Now there's a couple of tweaks you want to make to it before we're done. One tweak is when you're all done creating a valid form, you actually create it, then go ahead and wipe out these values. The other thing I want to do is I want to add that these 2 fields start off with a value of 0. That way you don't have to add 0 to the other field. So that last one's easy. We'll go to our properties for that text file or a text box. And for the text, we'll put 0. And down here, the text, we're going to put 0. And that's it. That's our properties are now set. The other one is to clear out that form. Well, if it's a valid form, we don't want to clear it out if it's invalid form. We're going to say these 4 values. And let's just grab these and actually copy them. And paste them down here. We got to take the commas out. And it's going to yell at us for a bit. And that's okay. We can move them back. We can say equals empty string and a semicolon. We can do that there. These last two, we don't really want to say empty string. We want to say that it's a string with 0 in it, the prize amount and the prize percentage, because again, the default value for prize amount and prize percentage is 0. Now if we run this, and we won't put a breakpoint this time, so let's make sure that's cleared, and it is. So now we can say it's second place. The prize percentage is, let's leave them both 0 for a minute. Oh, it's invalid. Okay, prize percentage is -15. Nope, still invalid. Oh, it's +15. Yep, that worked, and it cleared our form. All right. So that's a lot of work, but at the same time, now we're done. Now we've got this form created, and we've got a pattern for how to save to a database, a text file or text files, or both. Okay, so that's all taken care of for us. So that's great. Now we need to move on to actually wiring up those classes. So we have the SQL connector class, and we have SQL connector class and the text connection class. We need to wire those up to actually do the work. So in our next video, we're going to start off by doing our SQL connector and actually talking to our SQL database. So don't forget to stay tuned for that. Welcome to Lesson 10 in the C# from Start to Finish course. My name is Tim Corey, and today we're going to look at connecting to our SQL database. In the last video, we built the prize form, but we only wired up to the class that pretended to talk to SQL. Now we're going to actually take out that sample code and put real code in place to talk to SQL. So let's jump right in. Here we have our solution, our 2 projects, and just by way of review, down here in the Tracker UI, which is our user interface, in the program.cs, we made a couple of modifications. The first thing we did was we added this line right here. And what this does is it wires up which database or databases we're going to talk to. So in this case, we're connecting to both SQL and the text file. And then next, we change the application run from the tournament dashboard form, which is going to be our final form, the actual real form. We change it to our prize or create prize form so we can kind of test things out and make sure things work. So those are a couple of the important changes we made to the program.cs, which is where our application will start, since Tracker UI is the bolded of the 2 projects, which means it's the startup project. So before we jump in today, I want to make a couple of modifications to our library though. The first modification is I want to clean things up a bit. So I'm going to right click on my library and say add new folder, and I call this folder models. And then I'm going to drag anything that says models at the end into this folder. Just click and drag. And there we go. So there's a folder filled with models. And that just helps kind of keep things clean, because now I can do this, and all of a sudden, instead of having 8 or 10 CS files in this one list, all the same level, we can now kind of break these out by level. Now that didn't change anything on how those models work. The folder structure really doesn't matter, except, and here's the one exception, if I were to add a new item now. So if I right click and say add new class, and let's just leave this as class 1 since we're going to delete it. I want to show you the one change that happens. So let's look at team model for a minute. Team model, the namespace is tracker library. If we go to class 1, the namespace is tracker library.models. And that's because by default, what happens is that when you're inside a folder and you add something new, it takes the path of the namespace, it takes from the project name and then any path down to it. So if I had models and then in here a folder called people, it would say tracker library.models.people. So that's just something to note. Now when you drag a model or a class in here, when it was not created here, it will not add that into the namespace. Because adding that namespace would break our application because we are pointing to the root of this for all of these models, if we are using them. Most of them we aren't using yet. But that means you have a choice to make. You can either change the namespace on all of these to match this tracker library.models, or you can leave it off. If you leave it off, then you'll have to, anytime you add a new one, just take it off as well. And that's really up to you. It's whether you want to have that separate out or not. I kind of do. And the reason why is because that way it differentiates. This is a model versus this is a class that does something. Okay, a model essentially a model holds data. And so we call it a model just to differentiate it from the stuff that does work, like global config. Global config does work. It does hold information, which, remember, that's the use case is not normal to be a static class and have static property here. But it does hold information, but really it's doing work. That's its primary job. Whereas the person model, its only real job is to hold information about one specific person. So in this case, I'm going to take this namespace right here, and I'm going to actually add it to all of my other models. And you notice for a minute that I had red squigglies, and that's because they were referring to other models and the namespace had changed. Now, whatever namespace you're currently in, you don't have to have a using statement for that namespace. So we don't need a namespace or a using statement for the namespace tracker library.models because we're currently in that namespace. But if I were in the namespace tracker library, then I would need to add that using statement in order to bring in these models without putting the path models dot team model. See, if I put models dot, it's happy now because it knows what the namespace is, because again, the beginning is actually assumed. The beginning would be the tracker library. So that's the full path. But this is assumed because we are in the tracker library namespace. So now we can take that off, and we'll actually take that off as well. And we're now in the models library. All right, we can delete that class one. That was just an example. Okay, so there we go. We've got our models inside a model folder. And now I'm going to do a little more cleanup. I'm going to do another folder. I'm going to call this folder Data Access. And these names aren't necessarily really important. It's just for me to know what this is for. And so in this case, I'm going to move, and here's the debate, global config. Do I move that into data access? I say no, because it's not really about data access, it's about configuration. And so I'm going to leave it alone, but I will move the iData connection, the SQL connector, and the text connection. And that also brings up another issue, which is this is named differently than this. We have SQL connector and text connection. So I'm actually going to rename text connection to text connector. So let's rename this to text connector. And it's going to say, would you like to also rename the project and all its references to text connection. So what it does, it says over here, oop, it was named text connection. Let's change it to text connector, which is why I renamed it over here in the file name first, because that renamed the class name. It does not go the other direction. So therefore, if you need to do a rename it over here, and then it will fix this if you say yes to that dialog box. Now I've got a dialog yelling at me saying, hey, I don't know what prize model is. That's because we don't have a using statement for tracker library.models. So if I do my control dot, using tracker library.models, that puts it right there. And now life is good again. And now this I did a connector or connection is yelling at me because it's saying I am not implementing properly the create prize interface. And it's actually not really true. But what happens is if you come over here to our interface, it says, I don't know what prize model is. But if I say using tracker library.models, and I save that and I come back, this should be good now. And it is. And SQL connector, we're going to do the same thing. We're going to do the control dot, add the using statement so we can change this so it works. We will save that. In fact, we'll save all. This little two save icons together is a save all, which means it saves all of my files here, which is nice. So now I can move these files, the I did a connection, I'm going to drag in a data access, the SQL connector, and the text connector. And now we can actually change that namespace if we like, which I do. .data access. Now how do I know that's the new namespace it should be? Well, that's because this is the name of the folder, and it is case sensitive. So it's going to yell at me for a bit, no worries. We're going to change our namespaces here. That should solve that problem. Then global config, it's referencing the I did a connection, so I need to change to add the using statement for using tracker library.data access. And that solves the world's problems. So now I've kind of cleaned up my tracker library. It's a little more logical. Now I have my data access folder, I have my models folder, and then I just have global config right in the root. The last thing I want to do is actually do a build solution, because I'm assuming there's going to be other issues that I've missed. In fact, right there, I got a red squiggly. The build failed, it said. It's got 3 errors. So if I come here and say view code, it says I did a connection, prize model. I don't know what these things are. So if I hit control dot, add the using statement. And then down here again, control dot, add the using statement. Now see, there's 2 different using statements because one is for .data access, one's for .models. But with that being said, now if I build the solution, everything works. If you see in the lower left-hand corner, build succeeded. So now we can actually get to writing that data access code. And that's a lot of extra work before we actually got to our quote-unquote real work. But I want this project to be as close to real world as possible. And this is real world. You know, real world is you come back to a project and go, oh man, I was coding late at night and made some mistakes, like calling one connector and one connection. Is it a big deal? Not really, but at the same time, having that consistency of calling the same thing the same way every time really helps you when you're looking for a new thing. You know, so if we were going to look for a new data connector and it said data connection instead of data connector, we'd be a little confused. Is that really the same thing, or is that something different? And so by naming it connector every time, then I know that yes, this is the same thing because it fits the same pattern. So that's just something to keep in mind. And again, cleanup, that's not something you should let wait until the end of the project, just like documentation isn't. These are things you should be doing as you go because it's fresh in your mind now, and it's also much easier to change. You saw the number of tweaks I had to do to change those namespaces, and they were just for one form. I had those namespace changes to do. So if I had all of my forms wired up, even this small project, it would still be a much more significant change. I have to do a number of changes. And so the earlier you can do these changes, the better. And just make sure when you come back to a project that you look it over and make sure things are clean in the way you want them. All right, so on to the actual work of today. So let's right click on this tab and say close all documents. I just want to close everything out. I know the document I want was open, but it's just easier to clear everything else out and start again opening things up. So in the SQL connector, we have this to do right here, or we could have gone to our task list and looked for that to do, which is right here. And double click it, it would take us to it. In fact, let's close it down, double click this, and there you go. Just to show you that that's a quick way to navigate your project. It's also a quick way to remind yourself of what I need to do yet in order to get this project to work. Because notice there's actually 3 there. There's one for wiring up the text files and then set up the SQL connector properly. So in that one right there says, yep, that's not right. So let's go back here and start planning out how we're going to wire this up. And this is important to get right because we're going to do this over and over and over again for all of our different forms. So let's think this through a minute and start planning out how we're going to do it. Now we're going to use Dapper as our connection ORM. And an ORM is just a tool that helps you connect to a data source like SQL in an easier manner. It helps kind of take away some of the complexities of connecting to a SQL server. So I love Dapper because it's practically as fast as doing it with just straight C#. I used to do just ADO.NET, which is a little more complicated, especially when you start getting into the data sets and data tables and converting a data table to a list of model and all that went into it. Whereas now with Dapper, it kind of just does it for us and it takes us straight to our list of model. And yet it's almost as fast as the way I was doing it, which was the fastest way you can do it. We could use other tools like Entity Framework, but Entity Framework can be quite a bit slower to the point where it's 10 times slower than even Dapper. And so I don't like to use Entity Framework. It's also much more complex. And you can find out all my views about Entity Framework in my YouTube video on connecting to SQL from C#. But to start with, let's add a reference, manage NuGet packages. We're going to add a reference to Dapper. So go to Browse and just start typing Dapper. Hit Enter. This first one right here. We'll install the latest stable version. Just click Install, wait for it to be done. All right, there we go. So now it's installed. We can close out of this. And so now we can see in the references, we have Dapper right here. So now how we're going to use Dapper? Well, the first thing you need to do is we need to use Dapper with a connection string. If you've watched my YouTube video, I just mentioned the C# SQL connection. We have to have in our app.config a connection string. That's the best way to do it. That way we can change it even while the application is running. It's not hard coded in our code, and it also allows it to do some other things with it as well. But in the app.config, notice the app.config is not in our library. It would seem to make sense it'd be in our library because this is where we're going to actually do all of our work with Dapper. The UI doesn't know anything about Dapper. It just knows I call this method right here, I pass in a prize model, I get back a prize model. That's all it cares about. In here is where we're going to do Dapper. But this is just a DLL. The DLL doesn't actually have a user interface, and it also does not have a .config file, whether it's a web.config or an app.config. And so instead it uses the config file from the user interface, which means that the connection string actually goes in this tracker UI app.config file. And so here is where we'll put our connection string. To do that, under configuration, we're going to do our less than sign to open up a new section and type connection strings. Close that out. And inside here, we're going to add our new connection string. So we're going to say add name equals, and this is any name you want to give it. I typically give it the name of my database. Oops. So we call this tournaments. And then I'm going to say connection string equals, and inside here I have to first give it my server. In my case, it's ./SQL 2016. And a semicolon database. That's tournaments. Trusted underscore connection equals true. What that trusted connection is, it's saying use my Windows credentials in order to connect to the database. And that's usually the best way of doing things, is having that trusted connection, because then no one can come in here and read my username and password to SQL. Now, if they have access to your application, they have access to SQL at that same level. So if they were to quote unquote steal that username and password, if you had one in here, it shouldn't give them any more access than they'd already have. So if you find yourself having an issue where you have people connecting to SQL Server that you don't want to give many rights to, you really need to lock things down the SQL side. And there's ways of doing that. I talk about a little bit in my SQL course on imtimcorey.com, but really the best way of doing things that I know of is to, if you have to use a username and password here, to make sure that username and password only has access to execute stored procedures. That's it. They don't have access to connect to the database, to read the table structure, to write to the tables, or anything else. They just have access to stored procedures. That way, the permissions they have, if they were to take those credentials, are the exact same as if they were going to use this application, which is what you want. So that's the connection string. If you go to, again, if you watch my video, I cover much more depth connecting to SQL. But if you go to connectionstrings.com, I believe, just Google connection strings. They'll show you all the different connection strings for SQL and all the rest that you can connect to. And then finally, provider name equals system.data.SQL client. And that's just saying use a SQL connection or SQL client for connecting to this database. All right, so that's our connection string. Why is a connection string important? Well, this string right here tells Dapper how to get to SQL Server and then how to get in. So it says, here's the path of SQL Server. Here's the database you're going to start in. Now you can go to any database with this with these credentials if you have permission. But this is the default one. And what that means is it's kind of like a namespace where if you're in the tournaments database, you don't have to specify, I want something from the tournaments database. So it just makes life a little bit easier. And then finally, the trusted connection just says, these are the permissions I have. So location of the SQL Server, default database, and what permissions there are. So Dapper needs that in order to talk to SQL Server. And we can have as many as you want as far as connection strings in this list. So you just do an add down below this line and add another one. Also note that this string right here can be transformed with a config transform. So on build, if I do a debug build, I could transform this to something else. If I do a release build, I could transform it to something different. So for example, at my company, we have multiple transforms, one for the development server, one for the staging server, one for the production server, and then a couple other miscellaneous ones. And we're not going to get into transforms today. We're just going to leave it as it is and call it good. That'll be for a different video. We don't want to make this too long. So back over here, we now have a connection string in place, and we call it tournaments. So we can rely on that, but how do we even get our connection string? Well, I can go over to the global configs file. I'm actually going to add a new entry here, a new public static void. Let's just kind of, we can't really scroll up here yet. There we go. All right, public static, and it's not a void, it's going to be a string. Public static string, and we'll call this CNN value, and that's connection value, or connection string, let's call it that. And it'll pass in a name of the connection string when I get. All right. And let's just call that name. All right. So what that's going to do is it's going to go to the app.config and get me the connection string by looking up this name. And it's going to look up this name and then return for me the value inside of this string. So this right here. So I give it this, it gives me this. And this is pretty simple. The code is configuration manager dot connection strings, oops, square brackets, name dot connection string. And we'll return all of that. Now it's yelling at me because we don't have access to this namespace. And in fact, if you do the control dot, there's not a add using statement for that. And that's because we have to right click on references and say add reference, come to assemblies, click in the search box here, and start typing configuration. And usually don't get past config. You can see here config, configure, and configure is as far as I got in a couple different attempts. So here we have system.configuration, not the .install version. The one is just system.configuration. Check that box, hit OK. It's going to add a new reference here to system.configuration. And it's still yelling at us, but now if I do the control dot, or do this little drop down by the little light bulb here, we have the using system.configuration. And now life is good. Now, whenever anyone calls global config.cnn string and passes in tournaments for the name, they'll get back this string right here. So that's perfect. Now back here again. So I've done a couple of setup things. Now I need to actually put some kind of code in here that does something. So let's get rid of our sample code. I'm going to add a using statement. Using, and then the open parens, IDB connection, and that's not in the using statement list, therefore I do control dot using system.data and say connection equals new system.data.SQL client .SQL connection, and I can say global config dot CNN string, and then quotes inside the parens, I'm going to say tournaments. Now that's a lot for one line, but that's okay. So now what this is I've said I want to create a new IDB connection. Now notice the I in the front, which we've now realized means an interface. An interface means we can have any hard code behind it, meaning we can have, in our case, we have our SQL connector or we have our text connector. They both are an iData connection. But this IDB connection is something that Microsoft set up. And in this case, we are going to fill this connection with a system.data.sql client connection. We're going to put that in there. So we could put a MySQL connection in here, or a text connection in here, or a number of other different databases, or anything that fits the IDB connection interface we could put into this connection. In our case, we're connecting to SQL. So that's this code right here. And again, if you watched my C# to SQL database video, you'll be kind of familiar with this. And I say basically just keep a copy of this basic structure on hand and just copy and paste it, because you don't have to memorize stuff in programming. It's probably not the best use of your brain power trying to memorize things. It's good to know the basics and good to know a good bit. But the reality is you can keep this in a file somewhere and just keep using the same structure. As long as you know why you're doing it, it's not a problem. Now the using statement here is interesting, because what it does is it says, I want to wrap this right here and say that when you hit this curly brace right here, this connection gets destroyed, and destroyed properly. And so that way, this prevents against memory leaks. So it used to be that if your application, had an exception or did something weird when you were trying to connect to a database, you could accidentally leave a connection open. And if you do this long enough, then you have lots of connections open. And your SQL server gets slower and slower, and your application gets slower and slower. And you're wondering, what's going on? My computer's bogging down, my application memory usage is going through the roof, and all this other stuff. And it's because of memory leaks, because you had crashes and other unexpected circumstances that prematurely got you out of code but didn't close the connection to the database properly. This using statement fixes that. What it says is, it doesn't matter what happens. When you hit the end of this curly brace, whether it's through exception, through anything else, when you hit the end, we're closing it down. And so that's just a real safe way to connect your database in such a way that you don't leave connections open. What that does mean, though, is I'm not going to open a connection at this root level of the class and then reuse it over and over for different methods. I'm going to open this connection every single time. So now we have our connection to the database, but what do we do with that connection? We haven't really decided how this data goes in the database. So let's go over the database itself. We have the prize table, and we could, if we wanted to, write a query that said something like insert into dbo.prizes, and then put values, and then basically take that query and just paste it into code here and call it. But that's not really what I'd like you to do. Instead, what we're going to do is create a store procedure. Now we have already created some store procedures. We have the gets, get by tournament for prizes for team and all the rest. But instead we're going to create a new store procedure. We'll delete this. Now we could keep this here, but I'm just going to delete all of this and start right from the create procedure. I would encourage you to put the comments up above that says who created, when it's created, what it was for. That's really helpful down the road. It's especially helpful if you put a changes section in there where every time you change the store procedure, you put a note as to what you did and when. Because that way you can see the history of the store procedure as well. So the name of this create procedure is DBO. We always start with DBO, unless we have a different namespace essentially in SQL. All right, so DBO dot, I'm going to start with SP prizes because this is on the prizes table. And we have this convention of starting with the name of the table. And now you know what parameters to pass in. And this is where it's beneficial to have two screens because you can put your prizes table on one screen and your store procedure on a different screen or something like that. What I'm going to do is actually expand out prizes and go to columns. So now I know which columns I have in my prizes table. Because that's the columns I'm going to pass in. So I'm going to pass in 4 values. The first one is at place number. Now when you pass in a variable, you start with an at symbol. Okay, so this is a variable called place number. And it's a type int. And then at place name, and it's a type nvarchar 50. And that's really helpful. You know, right down here, I can see nvarchar 50, so I can match that up here. That way I know that I'm not allowing more data to come in than can be stored in this table. At prize amount, and that's a type money. And at prize percentage, that's a type float. If I can spell it right. All right, so let's get rid of the comments here. Set no count on. What it does is it says, let's not pass back how many records you actually modified. And that's fine. So I'm going to say insert into dbo.prizes. And then I give it the 4 columns I want to put the values into. Place number, place name, prize amount, and prize percentage. Notice I don't insert the ID because the ID is going to be auto incremented. I can't write in that field, or I shouldn't write into that field. There is a way to write into that field, but it's unsafe unless you know exactly what you're doing. So instead I'd say insert into the prizes table. Here's the 4 columns I'm going to write into. And then for the values, I'm going to say at place number, at place name, at prize amount, and at, comma, at prize percentage. Semicolon at the end. So there's my insert statement. Now, the one thing I'll go back to my code real quick and show you, let's pop back there, is that we return a prize model. It says return the prize information, including the unique identifier. So if I call this store procedure as it is right now, it would create a record in the prizes table, but I wouldn't know who is, what the ID is of the person who was inserted in this prize table, or what the prize was. So I wouldn't know the ID of the prize inserted into that table. To fix that, what I can do is I can say at ID int output. And I can actually say int equals 0 and output. And so what that's going to do is I'm saying the ID, you don't have to pass a value in, because if you don't, I'll just say the value is 0. Because I really don't care if the value is coming in. We're not going to use that to write to the prizes table. But I did say at the end of it, output. What that means is this value will be sent back to the person calling this store procedure, which is how I'm going to take the ID and send it back. But how do I get that ID? Well, I say select at ID equals scope identity. And I'm done. So what this scope identity is going to do is say in the current scope, which means that in our case, just this store procedure call. Okay, so there is an idea of scope in store procedures, or in SQL, where you can say, I'm going to call these 3 store procedures in the same scope. And that'd be really helpful for bank transactions, where we could say, I want to take money out of a checking account and then in another call, put it into a savings account. We wouldn't want those 2 actions to be separated, because if you took money out of my checking account and then crashed, that money would go away. It'd be out of my checking account, but it wouldn't have gone into my savings account. And so we can link those together in what's called a transaction. So in that transaction, that would be the scope. But in this case, we're not saying specifically that I want a transaction. Instead, what happens is this call becomes its own little transaction. So in this transaction, I want to get the identity. And what that is, the last identity written to a table. And so in this case, we only did one identity insert, and that's in the prizes table. So we said insert a new record, which would have created a new ID for that record. That ID is the last identity created. Therefore, when I ask for it, the last identity created, it's going to put the value of whatever's here into this variable. And since this variable is an output variable, I can then capture that on the other end. So I'm going to say execute, which is not going to run this store procedure, but instead create it. Now, don't do what I just did and have something highlighted and say execute, because you're going to get this error right here. This error says incorrect syntax near create. And you say, but that syntax looks right. Well, that's because I highlighted just this section. Remember that in SQL, wherever you highlight, that's the code that gets run, and that's it. So what I would do is either highlight the whole thing, or if this is the only thing in this file, then you can just highlight nothing and execute. I love the idea of highlighting just what you want, because that way, if you're in that habit, later when you have 2 statements in a file, you'll be more likely to protect yourself by highlighting just the statement you want, versus being used to just hitting run on any blank file. I'm going to run this, and it says command completed successfully. And if I come down here, my store procedures, and I right click and say refresh, we will now see that I named this improperly. I named it SP prizes, but nothing else. Oops, no worries. We'll do this, SP prizes underscore insert. We'll run it again. And now if we refresh this, we see that we have the prizes, the wrong one, prizes get by tournament ID, and prizes insert. So how do we get rid of SP prizes? Well, I could right click and say delete. That works. I could also wipe this out and instead say something like drop procedure dbo.sp prizes. And it's not a list because IntelliSense has not updated for this window yet. So if I hit Control-Shift-R and wait for a minute, it will update, and then it will know that that's actually the correct file. And if we run this, it's completed successfully. And if I right click and say refresh on store procedures, the incorrect SP prizes goes away and life is good again. So the issue with programming is not that you don't make mistakes. We all make mistakes. The issue is knowing how to correct your mistakes and then also working at putting things in place to not repeat your mistakes. All right, so we have a store procedure. The store procedure's name is SP prizes underscore insert. And in fact, let's call that up. So I'm going to modify that. Notice the modification, when I right click and say modify, it brings it back up, but it has alter procedure instead of create procedure. And that's the syntax to modify a store procedure. So I'll keep that up, but we'll refer to that in a minute. Let's go back to our code. Okay, so we have our store procedure. We know how to at least put the information in if we were in SQL. So how do we do it in code? We're going to start off by saying var p equals new dynamic, if I can spell, dynamic parameters. I do a control dot on that and say using Dapper. This is a Dapper thing. So dynamic parameters, and we're just going to use var because it's a little simpler with something like this. But in here we can say p.add. And this is where it's a little trickier than the way we did it in our C# to SQL Server or SQL Databases video. But once you kind of see it once, I think you'll get the hang of it. So the first thing we need to do is add our variables. So and what are the variables we have? Let's do this. I'm going to copy these. I'm just going to Shift Tab once and copy these. And come up here. Let's do it up here. Paste them in, and I will then comment them out. So that just gives me my variables and what types they are. So I have them. So at place number is the variable name. And then the value is model.placeNumber. And that's it for that parameter. So what we're doing is we're creating a list of these parameters, and we're adding them all to P. So p.add, and we'll say this one is model.placeName. And let's actually copy this place name and paste it here. P.add at prize amount, and that's model.prize amount, and then p.add prize percentage, model.prize percentage. Notice I tried the copy pasting thing from up here. It was just too distracting. When you're typing these out over and over again, trying to do it the same way every time, sometimes it's more distracting to try and copy something and paste it than it is to type it in, and if you have to, later come back and copy and paste to make sure you got it right. So p.add, and this is the interesting one, ID, because this is the one that goes the wrong direction. It comes out, doesn't go in. It's going to pass a value in of 0. I'm going to say a db type, db type, colon. Notice it's trying to do the IntelliSense was trying to say, I think you mean db type with a capital D in the front, and that's not what I mean. Instead, what I'm doing is I'm saying we have optional items here. Notice a db type question mark and the parameter direction question mark. By saying db type colon, that's saying, yep, this is this parameter right here. Whatever's after the colon, that's its value. So that way you can actually mix up the order if you wanted to, or when you have lots of these optional items, and there's even more with this right here, like with scale and precision and size and all the rest. When you have lots of these optional items, you can specify which ones you want to fill in and leave the rest blank. So db type colon, and the type here is db type dot, and here's the types we have. In this case, we want int 32, and that's the standard lowercase int. So that's what we want. So int 32, comma, direction, colon, and then notice when I hit space, it immediately opens up IntelliSense and goes right to parameter direction. because that's what it's expecting, a parameter direction. So if I hit tab, now I can hit dot, and I can say this is an output variable. So this parameter direction is an enum. Notice when you mouse over it, it says right there enum. So it enumerates the options we have available to us. In this case, we have a few. We have the standard input. We have input output, which goes both directions. We have output and we have return value. In my case, I'm using just an output, but if I wanted to, I could also pass information in on this ID value, in which case I could say input output. To change that in SQL, there's no change to make. As long as it's an output variable, I can use it as either an output variable in C# or an input output variable. And like I said, by default, they're input, therefore we don't need to specify because that's what it assumes. So output it is. So there's all of our variables and their values. Now I can say connection dot execute. And this is going to actually run some kind of store procedure, and it's assuming that nothing is going to come back as far as a data set goes. So what it's assuming is that we're not going to say, give me all of the prizes and return back a number of rows in a table. That would be a query instead of an execute. But execute, it's saying you're just going to call something, probably an insert, an update, or delete, and not really pass information back. So we want to do an execute, and then we're going to say in double quotes dbo dot sp prize. I'm going to double check to make sure this is right. It's sp prizes underscore insert. So prizes underscore insert. Always make sure you get that right, because otherwise the first time you run through this, it will error. All right, the next parameter is our parameters. In this case, p. And then next, the command type, or I'd say command type. It's right down here, colon. Notice I'm skipping over a lot of these. I'm skipping over IDB transaction and the command timeout to go right to command type. And the command type is command type dot store procedure. Again, that's a enum, so it popped it up in the IntelliSense. I just hit tab, I hit dot, and it pulls up my options here, which are, looks like 3. Store procedure, table direct, and text. We want the store procedure option. All right, and that's all there is to it. Now, this code, and that's all there is, this code is going to execute this store procedure, pass in all of this information, and then it's going to get back information, but we haven't actually captured where this comes into. So let's do that. So I'm going to say, let's take the model itself. Let's just modify this. So model.id equals p, that's our dynamic parameters, p dot get. We have to do a less than, greater than signs because it's a get of t. What that means is that it's generic, meaning you can get any different type you want. You just need to specify the type inside of these angle brackets. So in this case, the type is an int, and then we put in quotes inside parens at ID. And what this will do is it will look at this dynamic parameters list called P. It's going to find this particular parameter by using this, and it's going to say, give me the value of this, and oh, by the way, it's of type int. Therefore, we can put it directly into my ID because my ID is also of type int. Quite a coincidence, right? Of course not. We planned it that way. All right. So finally, I return model. And now life is good. Or at least it's mostly good. Now, there's one thing we haven't really covered here yet, and we're not going to in this lesson, but that's the idea of what happens if things go wrong. As a developer, you need to think that through. For example, what if this tournaments didn't exist? That app.config entry. What if it's actually tournament? Well, that'd probably blow up in some way. How is it going to blow up? We don't want to just crash the application. We want it to actually show a message, possibly, or maybe we do want to crash the application. One of the things that programmers, when they first start working with error handling, one of the things they tend to do is say, well, I could wrap this entire thing in one big try catch. And then if I do that, then things are safe because I can give a message saying, hey, something didn't work. The problem with that is you can also leave your application in an uncertain state, meaning maybe this is one of 3 tasks that need to be done, and it actually broke on task number 2 of 3. Well, that means that it got half done, and then the other half isn't done. How does your application recover from that? If you haven't planned a way to recover from that, it can actually be worse to have your application continue to run, because your user will continue to do more and more things to compound that error. And so sometimes the best thing to do is actually crash your application. Now, we're not going to say, okay, the solution then is just have no error checking. That's not the case. But I'm just saying that error checking is more than just saying wrap everything in a try catch. So we're actually going to have a lesson entirely dedicated to tracking and catching errors. And so we'll do that later on. But for now, we're going to leave this as it is and assume that things go well or everything will crash. So let's actually see if this works. And really, I don't have to do anything else to try it because we've already wired up. Remember the create prize form is already wired up to both a text file, a text connector, and also a SQL connector, which would be this one right here. And it already calls this create prize method. We can see that in the code behind where we have this loop, and it's right. Validate form. Oh, here we go. It's too simple. There's the loop. So for each iDataConnectorDB in globalconfig.connections, and we said both SQL and text connector, I want you to call the create prize method, and here is the model, which just happens to be whatever you filled in here on our form. So it's already gets called. So let's run this and see if it actually works. Now, before we do anything with it, and here's the form. Before we do anything, I'm going to go to my, close that out, and go to my database and do a new query. And say select star from dbo.prizes. And I have no prizes in my prize table. You can see that right down here. So now let's fill in information. I'm going to say the prize number is, or place number is 1. First place. The prize amount is, let's be generous, $100. And we're going to leave the percentage alone because it's an or here. We're going to say create prize. And wait for it, cleared it out. So something happened. We come over here to SQL and say execute again. Check that out. First time's a charm. Place number is 1. Place name is first place. Prize amount is 100. And prize percentage is 0. Now let's test it again. And this time we're going to say to second place. We're going to leave prize amount blank, but instead we'll do something like 50%. Create prize, it goes blank. That's quicker that time. And if we execute this, we now see that we have a percentage of 50. So it's good to test these things out both ways just to make sure that things are working. And the other key thing here is to make sure that things are going in the correct fields. I've had that happen before where I'm putting stuff in the wrong fields. And so I try and, you find a 2 over here and a 1 over here. And you find these are empty or null or something like that because I try to put first place, a string, into a number field, and that just doesn't work. And you'll go, oh, I swapped those two around. You go in the code and fix it. So it's just a matter of making sure that all the data goes in and it goes in the right spots. And I tested both the prize amount and the prize percentage to make sure that I indeed had both working the way I wanted them to. All right, I'm going to zoom out here. I'm going to minimize this and close this out. The one thing, and this is one of those things where this application is being built as if it were real world. And so I've left a couple of things in here that were frustrations that I found during the design process. But I'm like, you know what? No, I'm going to leave that in there, and we're going to work through it live, essentially. Because I don't want to hide from you all the struggles that go on with a design process. Now, there's some things in here, I'm not trying to act like I know everything, okay? There's some things in here that'll pop up that I'm like, I didn't even think about that. But in this case, this issue is one that I came across in the design process and went, I wish that could be different. But that's the idea of having both the SQL connector and the text connector writing together, meaning they're both working. The issue with that is this ID right here. Now, if I write to SQL, I may get an ID of 25. But when I write to my text file may have less records in it. So I may get an ID of 15. When I go to use this value somewhere else, I can't have two different IDs to identify this one record. That's going to cause some confusion. Now, I could wire up my SQL connector to be the primary one, and then it's going to fall back to or have a copy written to the text file, in which case whatever ID SQL has will then take that and write it to the text file. That kind of works, but it kind of defeats the purpose of having that just drop in whichever one you want to do kind of database. So I'm not going to do that. Instead, what I'm going to say is, instead of having as many different connectors as you want running at the same time, we're going to back it down to you can only have one connector running at a time, but you can swap it out at any time very easily by saying, okay, now I want to work with just text files versus tomorrow I'm going to turn on the database instead. It'll be different data, but at the same time, you won't have that stepping on toes with the IDs. So with that being said, we have to kind of rework some code. And now's a great time to rework code before we get too far down the road. And really, in my design process, it was when I was wiring up the SQL connector that I went, oops. And so that caused that thought process to go on. And the worst thing you can do as a developer is freak out and say, oh no, I messed everything up, and destroy everything and start changing everything at once. Take a step back, breathe. The world is not going to end, and it's not going to be solved by you just writing more code real quick. That's not the solution. The solution instead is to plan. Planning causes so much less hassle in the long term. Because even though I planned this application and I started to write code and ran into an issue I didn't plan for, my solution for that is to actually plan for it, even though I have code written. And that does mean a little bit of rework here, but not much. So the first place I want to rework is where we have the global config. I want to change a couple of things. First of all, we're not going to have a list of iData connection. We're going to have a iData connection. That's it. And so when we initialize the connections, we're going to say, if it's database, then the connection equals SQL. And then here, what we'll do is we will say else if. Remember before I said, don't do else if because then you can only have one or the other? Well, now that's what you want. else if, and we're going to say text file. So that solves at least this file, except for the fact that this isn't clean. So I'm going to change this to say string connection type. And then I'll say if connection type equals database, or let's be more specific, SQL. Else if connection type equals text, we can do that. Now we can come back and even make this a little bit cleaner. You know what? Let's make it cleaner. Again, this is part of that. Do you plan now or do you plan later? Let's plan now, and I'm going to add a enum here instead of a string, because this is getting me a little bit nervous. Do you type SQL, or you type, capital SQL, or you type text file? That's just a little squirrely. So instead, I'm going to create an enum. And the way I do enums is I right-click on my project and say add class, and I call it enums. Now you could create a class file for every enum, and that's fine. But what I do is I find I don't use enums that much, and instead of saying, oh, that's actually enums and where is that, I just create one file called enums and then wipe out the class inside of it and instead say public enum, let's call this database type. And we're going to say SQL and text file. So now I have SQL and text file. Get that out of there. So now I can come back over here. I can save that. Come back over here and instead say I want the database type. Now let's call it DB. And so now I'll change these again. DB double equals database type dot SQL. Or DB double equals database type dot text file. Now another way you could do this, instead of having your if, else if, all the way down the row, you could do a switch statement. And enums are wonderful with switch statements, because in enum, it has to know what the types are, at least currently. Now, when you go to Visual Studio 2017 and the C#7 features, the switch has gotten a really big upgrade where it doesn't have to have that very limited number of items it could be in the list. It can be pretty much anything. It's pretty powerful. But in C#6 and below, in Visual Studio 2015 and below, the switch statement is limited to things like numbers, where it's very easy to say equals, so that value equals. So if I were to say, let's type it right here, switch, and I tab twice, switch on DB, and I hit enter, it's created case statements for me already. Case, SQL, case, text file. Because that's an enum. It has a limited number of types. It has, in this case, just 2. And so I added 2 case statements we could have, and then also the default case. And that's essentially the same as this if, else, if, with no else. The default will be the else at the end. But I'm going to leave my code as it is. Switch statements at this point, before 2017, are a little bit limited. I like this a little better, so I'm going to leave it as is. The great thing about programming is it really is up to you as a developer. All right, so I have this new way of doing things. Now if I come over to app.config, oops, I'm sorry, not app.config, program.cs. It now says, oop, you got a problem. I'm not passing in 2 booleans, I'm passing in a database type, in this case, SQL. Now, if I didn't want to have that tracker library dot, I could delete that, then do my control dot here and say using tracker library, And now I can use that. I'm saying just SQL, which means that I've turned off my text files for now. I'm just using just SQL. Now, if I build this, we should have at least one more error. I go to that error and it says, all right, for each, do this. For each IDB connection in global config.connections. Well, we don't have that anymore. We only have the one. So therefore, what we can do is do this. We can say global config dot, and it shouldn't be connections. So let's change this connections to be connection. I hit control dot. I'm going to say rename connections to connection. Let's go through and rename these two. And so now they are correct. I could have just renamed this, renamed anything that broke, but that's a little bit easier, and it does know about scope, so it knows what is really calling connections and what's not. But over here, global config, control dot, connection dot create price. So we now know, let's just put that where it should go. So global config.connection.createPrize.model. Which connection is it? Is it SQL? Is it text? Don't know, don't care, just know we're doing it. So again, all is right with the world. If we run this, we can create a new one. Let's create prize number 4, fourth, and the prize amount is a measly $5. Create the prize, it wipes things out. If we go back over to SQL and run this again, we see that in fact, yes, we have place number 4, fourth, and $5. What that means is all those changes, they all worked, okay? And we'll get into looking at testing a little bit and writing tests to check your application as well, because that can be helpful. But for now, we just ran a test ourselves just to make sure things worked. So with all those changes that happened, we've refactored our library to be a little cleaner. We have redone how our code works a little bit to make a little more sense with some of the things we thought through. And we've also, it seems like a minor footnote now, but we've also connected to our SQL server and inserted a value into it every time we run this create prize. And oh, by the way, we learned about output variables and how to get them back using Dapper. Welcome to Lesson 11 in the C# from Start to Finish course. My name is Tim Corey, and today we're going to be looking at how to save data to text files. In the last video, we wired up our connection to SQL. We also did a few housekeeping things that hopefully will set us up for success going forward. Now, we need to make the text connection work like the SQL connection does, in that we take in a prize model and we return a prize model with that ID filled out. So let's look at how to do that. Here we have our solution. We can go directly to the text connector inside the data access folder. And this is what we need to wire up. So right now, this is the sample code. And just like before, we're going to delete that out. Now, again, just like with a SQL connection, the very first thing we need to do is figure out where we're going to store these text files. Now, it is plural. We're going to store our data in more than one text file. My thought is that for each one of these models, so matchup entry model, matchup model, and all the rest, for each of these, we're going to store them in their own text file. So essentially, it's a list of that item in each file, or if you think of it in SQL terms, it's one table per text file. And text files are really cheap to make, and that's the best way of putting data in a way that's efficient in getting it back out and not confusing one with another. So we're going to store our information in multiple text files, and in this case, we'll store the prize information in the prize text file. So we need to know where to store these files. And so instead of storing a file name, we're going to store the path to where all the files go. And then all the files will be in one folder path. And that seems a little bit like the connection string. So we'll actually store this information in the same spot. So we'll go over to the app.config of the tracker UI project. And here we have our connection string. And we're going to, in here, add a new section under configuration and call it app settings. Inside app settings, we're going to add, say, key equals file path. And the value equals, and in my case, that value equals this path right here. So C:/data/tournament tracker. No slash at the end of that. So it depends if you want to put the slash there or not. We're going to have to add that slash in when you put a file name, but I like to have this without the slash because that would be the more correct syntax for Windows. So let's leave it like that. So this now is the key and the value. So it's a key value pair, kind of like a dictionary object. So we'll be able to look up based upon this name and get this value, just like we look up by this name and get this value. The only difference is this is more generic, just any app setting, whereas this is specific to a connection string. So back over here in our text connector class, we need to start wiring up the helper methods that will allow us to talk to those text files. But before we start writing code, let's work on the plan. And I'll show you what my plan is. So here, when you say write a prize, create a prize, so save that created prize to the text file, what I'm going to do is first read the text file of the prizes. I'm going to load all the text or the prizes that are currently in that text file. And the reason for that is because I need to know what the new ID is going to be. Unlike SQL, text files don't create auto-incrementing IDs. So I'll load all the prizes up. I'll read through to find what's the highest ID and use the highest ID plus 1 as the new ID. So I'm first going to load the text file. Then I'm going to convert the text to a list of prize model. And from there, I'm going to find the ID, add the new record with the new ID, and then finally, I am going to convert the prizes to a list of string. And from that, I'm going to save the list of string to the text file. Okay, so that's a lot of work, but when you're talking about text file data access, you're going to need to do some work. And that's just what it comes down to, because text files are not the intelligent systems that a relational database is. They're pretty much just stupid. And so we have to be the smart ones. With SQL, we rely a lot on SQL smarts. But with text files, it's all on us. So in this case, we're going to load in the text file, and that's going to come in as a list of string. We're going to convert that list of string to a list of prize model. We're going to find the ID, the maximum ID. We'll even say max here. We'll add the new record with that new ID, which is the max plus 1, to our list. We'll take that list then, the list of prizes, and convert it to a list of string. And then save that list of string back to the text file, overwriting what was currently there. Seems kind of simple, right? Now, these steps right here, each of them is going to be a different action, and we're going to try and keep these separate because loading the text file, that isn't based upon which type of model you're using, in this case, prize model. We just load the text into a list of string, which means that we don't have to limit that code just to this method. Converting the text into a list of prize model yeah, it's pretty much limited to just this method. There are ways and tools we could do if we got really complicated, where we could have one method convert anything to any kind of list. And if you want to pursue that path, I would recommend using a tool like AutoMapper to map from one type of object to another. Next, the find the max ID. That's pretty simple. We'll use some the link queries in order to get us the max ID. Adding the new record is just adding one to a list, but then converting that prizes to a list of string, that's going to be a custom to this type of model. But then this right here again is something that any method can do, which is save a list of string to a text file. So you got to kind of break these apart, first of all, so that each method does one thing and does it well, and then also so that other methods can use the methods that are kind of generic, the ones that don't really rely on a specific model type. Now to do this, I'm actually going to create a new class. And there's a lot of different ways you could do this new class. There's a lot of different places you could put it, and there's not seemingly a great place to put it. I'm going to put it right in data access because it kind of fits with data access. It's just as more data processing. And it's related specifically to the text connector. So I'm going to add a new class. And I'm going to call this text connector processor.cs. Now this is in the in the tracker library.data access namespace right now. I'm actually going to change that namespace. I'm going to say .data access .text connector. And the reason why I changed that namespace is because I don't want everyone to get cluttered up with what I'm going to do in here. So I'm going to give it a separate namespace so that only people that have that using statement get the extra clutter this is going to create. And I'll show you why in a minute, but the key thing to point out here is these namespaces, they're really anything you want them to be. You can change them however you want as long as it's a valid string. I would stick with just letters and the dots to separate. Trying to go crazy with special characters, that can just make things ugly. But in this case, I'm going to say .text connector. This class, I'm going to make it public static class text connector processor. And that's a mouthful, that's okay. The very first method I'm going to put in here is a public static string full file path. Takes in a file name. And what this method does, or is going to do, is it's going to take in the file name. Now the file name would look something like, let's go to prize models.csv. That would be the file name. What this is going to do is take that file name and return back the entire path. Remember that in the app.config, we have this c:/data/tournament tracker. That's the path where all of our files can be located. And currently, just so you know, that's an empty folder right here. So right now it's empty, but once we start saving things, we'll start seeing files appear here for each of our different models. So this one right here, it's going to take this, it's going to prepend this right here. So it's going to put this first, then put a slash, and then put whatever you pass in for the file name, in this case, prizemodel.csv. How do we do that? Well, this is actually pretty simple. I'm going to one-line this. I'm not always a fan of one-line. Here's why. When you do things in one line, it's hard to debug because with one line, it does everything in line and you can't see what the value is at any one step as easily. But in this case, it makes sense. So I'm going to do that. Return. Give me a $sign syntax, which this allows us to concatenate strings together, put them together, kind of, add them together easily in a way that's more intuitive and also more performant. So I'm going to just put my semicolon at the end just so I'm complete before I go back and start writing in here. I'm going to start off right away with my curly braces and say configuration manager. And it says, nope, I have no clue. So I control dot and say using system.configuration. So configuration manager dot app settings, file path inside quotes, and then inside those square brackets, file path, close curly brace. So what this does right here, this section, is it goes out and says, okay, configuration manager dot app settings. Well, that just happens to refer to these app settings. And it says, here's the key. Remember, it's a dictionary. So here's the key. And it's just going to say, okay, go look for that key. Oop, found it. I'll return the value. So that value comes in place of this. So now we have that C:/data/tournament tracker. After the curly brace, we need a slash. But here's the kicker. Inside of a string, if you put a slash, that's the escape character. What the escape character allows us to do is to escape out of that string to put a special item. But we don't want that. What we want is a slash. Now, if this is a regular string, we could put the @ symbol in front of the string, and it would say, no, everything inside a string is just text. It's not a special character or escape character. But in this case, we can't because we're using the $sign. So instead, we have to say slash. Because now we are escaping. This is the escape, the first one. The second one is what we're escaping. So it's saying, treat this next thing as a real string, and it's the slash. So essentially, this will translate into one slash. All right. Next, we're going to put the curly braces again, right after, no space. We're going to say file name. We'll take that extra space out at the end. So file name is the file name you passed in. So in this case, what we do is we start off with C:/data/tournament tracker. That's this right here. Then we have this double slash, which boils down to one slash, like so. Then we have the file name. The file name is prizemodels.csv. And that looks like a valid file path and name. And it is, except for one fact, and that is the file doesn't exist yet. And that's no big deal. So we'll take our comments out here. So this method, all it does is it says, you have a file name? Cool. I'm going to give you the full path. And in fact, we can change this to say this. So now it says this string file name. And what does that do? Well, now this becomes an extension method. And so anytime we have a string, since it says this string, that means that we're attaching to this string right here. And it says, okay, that's whatever we're passing in goes into file name. So it's going to say, whatever string we have, dot full file path, open, close paren, will return the name of the file in the full path. So again, that's C:/data/tournament tracker /prizemodels.csv. And this will be a little easier to understand when you see it. If you're confused about extension methods, I do have a video on my YouTube channel that will help you out with that. And we're going to use a couple more of these. And this is the reason why I have this special namespace that only this file uses. Because I don't want this extension method everywhere. Otherwise, if I'm in my SQL connector and I have a string and I put a dot at the end, it's going to say full file path. Well, that makes no sense. The SQL connector doesn't need to have this text file manipulation stuff. The only place it really needs to have this is the text connector class. But in order to have these extension methods, I have to have a separate class, and it has to be static class, and each method in here that's a extension method has to also be static. So that's why I had to create the separate text connector processor.cs and why it's static and static. All right, so that gets us started by saying, okay, in here, we're just going to pass in the name of the file, which we can hard code if we want to say prize models. So we can pass that in, and it's going to give us the full path to that file. Before we leave this right here, we need to add another extension method, public static, and this is going to return a list of string. And this will be load file, and we're going to say this string file. And what this will do is it will take in the full file path, which we're going to get from here. It's going to take that and it's going to load that string. Now let's grab this over here. Let's grab this right here, because it'll be easier to see when it's in here. All right, so this right here, load file, corresponds to this first entry right here, load the text file. All right, so first thing we need to do is check to see if this file right here exists. Remember I said that this folder is empty, and that's okay, which it really should be. We don't want to create these empty files for everything we need. We want to let the system do that. So the first thing to do is say if not file, not lowercase file, uppercase file. And it says I don't know what that is, so I do my control dot and say using system.io. If not file.exists, file. Okay, so what that is, oops, there we go. What this is, it says this method right here, file, which is built into Microsoft, it's in the system.io namespace. So if system.io.file.exists. So the exists returns a Boolean, a true or false. We pass in the full path to the file, and it's going to check to see if that file already exists. And I'm saying if it doesn't exist, that's the not in front of it. If not exists, now if that confuses you, or if you really think you might skip over this, you can most definitely take this out, and at the end here, before the last paren, put double equals false. If file exists equals false. Okay, it's the same thing. And in fact, there's no performance hit to doing this versus the not. Therefore, if that's what you're comfortable with, please by all means do that. You will see, got rid of my F there, you will see this more commonly in the production environments of businesses. It's just a more accepted syntax because it's a little cleaner, a little tighter, and it's what we do. So you're going to see this, and a lot of people will swear by this and say that's the only way you do things. It really doesn't matter, except if you're trying to match somebody else's standards. If you're just learning how to develop, do what's going to make sense to you. Okay, that's my little soapbox. Just do what makes sense to you. Don't get suckered into the, well, this is the best practice for when I'm an Uber developer. That's great, but if it's going to limit you from becoming a good developer, don't do it. Do what's going to get you to the next level. Don't try and jump 4 levels up all at once. Okay, so the file does not exist. We can't read from it. In that case, return new list of string. But if the file does exist, we're going to bypass this right here and come down here. And we're going to say return file dot read all lines. Again, baked right in. Here's the file. The last thing you do is say to list, open, close paren, and semicolon. So now this method takes in that full file path and returns back a list of string. And that list of string represents all the lines in the file. The first line is in the first value, the first entry in the list, and down it goes. So that is this right here. Next, we need to convert the text to a list of prize model. Now, this is going to be a method that is specific to prize model. We're not going to have a generic method for this, but I'm still going to put it in this file here because it makes sense from a standpoint of I'm going to use it as an extension method. The eventual goal here is I want to be able to chain these together so I can read it very easily, where it's going to say, give me the full file path of this file, and then load that file, and then convert that file to a list of prize model, and so on and so forth. So down here, I'm going to say public static list of prize model. I have to use my using statement, so control dot and then hit enter. And we'll call this convert to prize model. Let's make it plural, prize models. And say this list of string lines. So it's going to take in a list of string. Where would I get a list of string? Well, that's the lines from the text file right here. It's going to spit out a list of prize model. That's the eventual goal. Now, again, it's an extension method on the list of string type. So here's how this works. We're going to start off with our output. List of prize model is our output. And we'll initialize that output. Then we're going to say a for each. String line in lines. When you're doing a for each, it's okay to have a single letter if you want, and we'll probably do that at some point, but just to make things shorter, because you know what it is, it's a line in the lines, especially when you have user in users. That gets a little confusing, so I might do user u in users. But in this case, we use line. That's fine. And it's a string. So now I'm going to say string array. I'll say calls for columns equals line.split on single quotes here, not double quotes, and a comma in between. What am I doing here? Well, if you watched my text files video, you'll know that for each line, I'm going to have it comma separated, like a CSV file. In fact, we're saving it as a CSV file. We'll see that in a minute. But for each line, I'm going to have these entries separated by commas. So I will split the values. I will split the line on the comma value. And that's going to put it into an array of string called calls. And now I can say prize model, I'll call it P, equals new, not sure why I said models.prize model, but you can take that off. And we will say P.id equals calls array position 0. And you may say, how do I know that we're at array position 0? Well, because that's the first one I write, that's the first column. You're going to have to know what your columns are and how they line up. And that's a little ugly, but that's what we're going to have to do. Now, it's going to yell at me here because this is a string. I'm trying to put it into an integer value. Now, there's a lot of ways we can deal with this, but remember I said that we're going to deal with exception handling in a different video. But that sometimes you want your application to crash rather than trying to make it limp along with half-formed data. In this case, that's exactly what I want to have happen. I don't want to worry about trying to protect the application from crashing. I'll let something higher up the food chain handle that. And instead, I'm going to crash if things don't work, which means I can say int.parse, and then in parens, put this string. Now, int.parse is going to take the string and convert it to an integer. And as long as that's like a 1, 2, or 3, some kind of integer, that'll work. If it has the value of Frank in that field, it's going to crash the application because Frank is not a number. So that's just something to keep in mind. This is going to crash if the data is not correct. Now, who writes this file? Only this application, in theory. So when this application reads from this file, it should be correct data. But you never trust things to go as planned. But in this case, it's going to have to blow up until I can put some exception handling in that's a little more intelligent and probably farther up the line, because I want this whole method to crash if it can't convert one line. Because if there's bad data there, we've got a big problem. We need to stop right where we're at. We can't continue on with half good data. All right, p dot, the next thing in line, the next column would be the place number. And the place number is also an integer, so int dot parse calls 1. Next, we've got p dot place name, and that's a string, so that's easy. Calls 2. P dot prize amount. Now, prize amount is a decimal because it's money. So therefore, we say decimal dot parse calls 3. Again, same thing. If it's not a decimal, it's going to break. P dot prize percentage. That's a double. So double dot parse calls 4. So there we have our model being built based upon the 1, 2, 3, 4, 5 columns in this text file. And again, they have to be in the correct order and they have to have good data. And at the end of all of this, we say, we take our list, output dot add p. And then at the very end, we return output. And so what's happening is we're going to loop through every line in our text file. And you may say, whoa, 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 we don't have a text file yet. So what are we looping through? Well, remember we said return that new list of string. Essentially, a list of string that's initialized but has no records. Therefore, when we say for each line in the list, well, there's no lines. Therefore, we skip right over and return the output, which is an empty list of prize model. Perfect. Now we can come back up here and look at convert the text to a list of prize model. Done. Now we need to find the max ID. Well, that seems like something that the method in the text connector could do, since we're doing an insert, and an insert is unique to needing to have that ID, because an update would already have the ID, and it's just going to change some values in that row. So therefore, that's pretty unique to this create prize right here. Therefore, we're going to put the logic in here. So how do we put this logic in? Well, first we need to add the namespace. And the namespace is tracker library.dataaccess.textConnector. I'm going to copy that. Let's come over here and say using that namespace. And immediately I notice I have a problem. trackerlibrary.dataaccess.text connector. Does that sound familiar? How about trackerlibrary.dataaccess.text connector? So now my namespace is the same as a class name. Would that survive? Sure. We just couldn't use a using statement. But that doesn't really seem like it's a helpful thing for me. So instead, I'm going to say, let's change this namespace. Again, we can change these at will. Text helpers. And so now I can come over here and say, it's not text connector, it's text helpers. That looks better. Okay, here we need to start working with our file. So first I'm going to come up here to the class level. All right, we're going to say private const string. We're going to call it the prizes file equals prize models.csv. Now what is this? Well, it's a private constant, meaning this value, the value inside this variable right here, will never change. It's going to be prize models.csv forever. So now I can take this variable and use it as a constant wherever we go, and we know that it's the same value everywhere, and we didn't accidentally overwrite it somewhere. It's also a little more efficient. That's the const, making it a constant. Now the notation is a little different in the fact that it's private and it's a variable of a type, but yet we have the Pascal notation of the uppercase first letter of every word, not just the first letter of the second word, with the first one being lowercase. So typically if this was a private string, this would be a lowercase p. Because it's a private constant string, the notation is uppercase. I'm not a huge fan of that just because it is a little confusing with anything public. You know, these things are publicly used, and so we do methods, we do class names, we do namespaces, and they're always Pascal notation, whereas private variables are always the camel case, where the first letter is lowercase and all the other first letters of words are uppercase. So it's not a favorite, but at the same time, this is the most preferred way in the industry of doing things. And I typically try and keep my style as close as possible to industry standards or the generally accepted practices, just because it's much, much easier than to transition into a new location and not have to change my style dramatically. So with that being said, prizes file. And that's the location where we're going to store our prizes. Now I could say the full path right there, but what would that do for me? Well, it'd lock me down to that particular path unless I change code. Whereas right now, in the app config, we can change that at any time and relocate where our files are. That means we can actually put our files onto a network share or onto a different drive entirely, and this application would still work just by changing the app.config location for file path. So we want to keep this as it is, and we'll have a few constants here, one for every model, but I'm not going to add them now. I'm going to add them when I need them. Just makes more sense that way, and you don't accidentally create duplicates. So with that being said, I need to take my prizes file dot, and this is where we're going to use our extension methods. Our first extension method is the full file path. So dot full file path. That's an extension method. And I don't pass anything in because it's going to take the first value, the one that says this, from this string right here. So that's going to convert that to a full file path. But I'm not done. I then hit dot. And now that I have a full file path, I can do this load file. So Control J to pull this back up. Load file. Which file? Well, the full file path of this file. I don't pass anything in because that's this value right here is what gets passed into here. And then I say dot convert to prize models. So it takes this list of string that comes out, We're going to convert that to prize models. And do I pass in anything? No, because that list of string is all I needed. Open, close, and now at the very beginning, I can say list of prize model prizes equals, and have that full section right there. So it takes the prize file, it finds the full file path, it loads the file, it converts that to a prize model list, and returns that to my variable. See how kind of compact that is? And yet it's also readable, and yet it's doing 4 different things. Well, 3 different things. 3 different methods on that data, and it's chaining it all together. So now I have in one line my list of prize model from my text file. Next, I need to, and that's these 2 lines right here are now done. And in fact, I could just take this and put them right above, load the text file, and convert the text file to a list of prize model. So there's the first 2 steps done. Now for this next one, I'm going to say int current ID equals prizes dot order by descending. So I'm going to order this list descending by x equals greater than x dot ID. So what this does is it takes my list and says, okay, I'm going to order by descending by the ID property. So if I have 2 records, one of the ID property of 1 and one of the ID property of 2, 2 is greater than 1, therefore 2 comes first because we're going 2 then 1 because that's descending order. So now I have my list ordered, but that's not good enough because that's not an integer. Instead, I then say, give me my first value. And what does that do? It gives me that first record, which is the record that has the highest ID. And then I say dot, in the list I have ID. And I'll say +1. What that does is it finds the ID of the highest ID in a list. So if we have 3 IDs in our list of prizes, ID of 1, 2, and 3, it's going to find the record the ID of 3, and then get just that ID, so then it's just a 3. And we're going to say 3 plus 1. Now the current ID is 4. And that current ID is the one we're going to use to write the new record. So I'm going to say model, and that's what we're passing in right here, model.id equals current ID. Now, to be totally complete, what you should do then is say current ID plus equals 1, meaning now the ID is moved up 1 because we've used that ID. And that would be in case you wanted to write more than 1 record at a time to this list. But in this case, we don't, so we'll go ahead and not add that extra code since it's not necessary. And now we have our record we want to add, so we say prizes.add model. So we've added our new model with the new ID to our list of prizes. So that's find the max ID. We're going to grab that, and we'll put that there. And we're going to add the new record with the new ID, and that's right there. And now we need to convert the prizes to a list of string and save the list of string to a file. That sounds like we're going back to our text connector processor and doing some more work. And writing will be a little bit easier in the fact that we'll just do one method and it will do everything. Just because writing is so easy. We're going to say public static, and we'll say void because there's nothing we need to return. We're just going to write these files. We're going to call this save to prize file. Call it say to prize file. We're going to pass in this list of prize models. And then we pass in also the file name. Okay, so we passed in our list of models, and that's our, this is an extension method based upon this list of models. So therefore, when we're over here, we can say prizes dot save to prize file and just pass in the file name. So now we have its list. We can say we need to convert this to a list of string. So list of string lines equals new. Wow, messed that up. List of string lines equals new list of string. That's better. Then we're going to do a for each. And this is going to be a for each on our prize model. I'm going to call this P in models. So I called it P because I want it to be as short as possible because of how I'm going to have to create this entry. Now I have this list of string here, and C# is great about writing a list of string to the database, so I will use this, but I have to add a line for every single model. So I'm going to say lines.add. I'm going to do my $ double quote syntax, and I'll put my semicolon at the end and come back here. Now, what's the first thing? P.id, comma, make sure not to put spaces where it's actually going to count it. Keep the spaces limited to inside your curly braces if you want to use them at all. Next we have P.place number. And the order is important here. Remember, this order here is the order up here. So you can even look up here for your kind of a cheat sheet. That's always a good thing to double check. So next is P.place name. And then comma, P.prize amount, comma, P.prize percentage. So I have the ID, a comma, the place number, a comma, the place name, a comma, the prize amount, a comma, and the prize percentage, no comma at the end. And that's how you do a comma separated line. Now it's going to loop through every line in my list of models. And so now at the end of that, I have a list of string that represents all of my models. So now all I do is say file.write all lines. And it's going to ask for two things. First of all, the path. So I'm going to say file name. You're going to say, but wait, that's not the path. No, it's not. Now we have to say file name dot, and what's it's full file path. So Control J down here to open that list back up. Full file path, that's the file name. And the contents is, right now, if you look, it says it's an array of string, but if you do this little arrow here, you can see it's IEnumerable of string. If you keep going, you can see other options as well. We're going to use this second one, the IEnumerable of string. And list is an IEnumerable, therefore list will work. Let's zoom back out here. We can say lines. And guess what? That's all we need to do. So we take our models and our file name. We take the models, we convert them to a list of string. We take our file name and convert that to the full file path. Then say write all lines. Here's a full file path, and then here are your lines to write. And we're done. And with that, we come back over here. We can actually just move this up. And then right under here, we call this the save to prize file. Oops, let's not do that. I accidentally double clicked here and it popped it into a new window, which will allow you to drag it to a second monitor if you want. I use that quite frequently when I'm trying to both read something like this right here. You know, I'm reading save to prize file and coming back over here and using that because I try to remember things. I try to make sure and double check and verify by reading. It just makes a whole lot less of a mess later when you go, oops, I forgot that, or I transposed something. So I just don't remember things intentionally. I actually go back and double check. So I could drag this tab into a different monitor and read it while I type. But in this case, with one monitor, it's not as easy to do. So I'll just go ahead and go back and forth. I could also split these, right click on a tab and say new vertical or horizontal group. And that'll allow me to see two files at once. But in this case, I'm just going to come back over here and say save to prize file. Okay. And so I'm going to say prizes dot save to prize file. It does take something in because we have two parameters. The first one comes from here, the prizes. The second one is the file name. And what's the file name? Well, it's the prizes file. And notice the little icon right here indicates that it is a constant. So, with that being said, we have now saved our prizes back to our text file. We've overwritten that text file. You see back over here, this write all lines. If you notice the comment, what it does, it says it creates a new file, writes the collection of strings of the file, and then closes it. It writes a new file, meaning it's going to overwrite the file that's already there. So if you didn't want that, that'd be different. But in our case, we want to blow the original file away, start over. So now we're almost done. We have this red squiggly here, and it says, hey, you're not returning a value. What is the value to return? Well, return model. Why? Because the model is what we added that ID to, and now it's the prize model fully formed with that ID. So now you can refer to anything else we do by that ID, and we'll know we mean this particular record. Now, how do we know this is going to work? Well, we need to test it. Again, we'll cover unit testing in a future video, but for now, I want to get into actually just running this thing. So let's come down to our program.cs, and we have this initialized connection. We're going to use a data type of SQL. No, we're not. Control J. We're going to use the text file instead. Now we're saving the text files. Again, there's nothing in here in any of these text files. There's no text files. So let's start this application. And it's going to start off screen like it always does. And I'll pull it over. I'm going to open my folder here and just put it next to it. And I'm going to say place number is, let's give it place number 2, place name of second place. And the prize amount is 50. Create prize. And it blows up on us. Excellent. And it says, sequence contains no elements. Wah wah. Why is this a problem? Well, we said we didn't care if our text file was not there because we would just add that first model to our list and then save that list of 1. But we have a problem. We're trying to get the ID. And we're assuming, and that's where you get into trouble, we assumed that our list of prizes had at least 1 record. We could then sort by the IDs. It does not when there are no records. How do we fix this? Well, first we stop. And then we say, let's copy this. I'm going to say that this equals 1. And then I'm going to come down here and do an if statement. If. And I'm going to say prizes dot count is greater than 0. So what I've said is the initial value of the ID is 1. Now normally the initial value would be 0. But I want it to be 1 because if the prizes.count, the length of our list, is 0, meaning this is false, it will not do this, and it will put the ID of the current ID, that'd be 1, into the model.id. So the first record. Now over here you see that I have the value plus 1. Think of this as 0 plus 1. That would be the equivalent of what I'm doing down here. But it's kind of silly to do math on an assignment like this when I can just do that. So that's why I'm going to do that. That should take care of our bug. So now if the prizes count, the number of records and prizes is not 0, we're going to find that ID. Otherwise, we'll skip over it and put the ID of 1 into model.id. Let's run that again. I'll bring up my folder and also my file. And I'm going to do this again and say, let's do third. I always like to change the value that I test from the previous crash just to make sure that the old crash information didn't somehow slip into. Now, that's the wrong place for third. That should be 3, and this should be third. And the prize amount for this we'll say is 25. We're going to create prize. And look at that. We have a file over here. And if you notice on my system, it says, hey, that's a Microsoft Excel file. It's actually a Microsoft Excel comma separated values file. Well, sure it is. But I'm actually going to open this with Notepad. And look, we have 1, that's the ID. 3, that's the place number. Third is the place name. 25 is the prize amount. And 0 is the prize percentage. That's awesome. We're going to close it back out, and we're going to say 2 for second. Place name is second. Prize amount is 50. We'll leave prize percentage alone. We'll create that. We're going to do it again for first. Prize amount is 100. We'll create that, and I'm going to create fourth place just to exercise my prize percentage. And we're going to say this is 5%. And create the prize. Let's open this up again. Open with Notepad. And look, I have 4 records. Notice the IDs are 1, 2, 3, 4. The second column is not the ID, that's the place number. 3 for third, 2 for second. Let's zoom in here. 1 for first and 4 for fourth. Notice that the first 3 have the value of 25, 50, and 100 in this column right here, whereas the fourth place does not have a value in that column, it has a 0. And instead, we have a 5 in our percentage column. So it's working. We're saving our values to our text file. And in fact, we could open this up in Excel if we wanted to and actually add new columns. I recommend you be careful with that because this is very strict about how it puts values in. And if you make a mistake with a typo or adding an extra column or something weird like that, you might actually cause an issue where your application crashes. So let's not crash our applications just yet. We'll do that later when we're trying to work with exceptions. In the meantime, we now have a working application that can either save to our text file or to SQL. Before we go, I want to point out that in our text connector, we have all of these extension methods. So this is a string dot full file path. But if I were to go to SQL connector and come in here and just give a string, whatever it is, test, and then say dot full file path, it's going to say, no, I have no clue what that is. If I hit control dot, it's going to say add the using statement for tracker library.dataaccess.text helpers. Now I'm not going to do that, but that just goes to show that all those extension methods aren't on our values, our strings and our lists and all the rest. They're not there unless we add that using statement. Let's just get all the way out of there. All right, so unless we add our using statements, which up here we have our using statement, when we add this using statement, we get all these extension methods. When we don't get them. And that's actually a really good benefit, because as we go on, if we have lots of these extension methods, we can double and triple the size of that list of possible options, and we might even step on our own toes where we have two methods with the same name that do something different. And so the best way to make sure that we keep those separate is to keep them in separate namespaces and only pull in the namespaces of the extension methods we really need. Welcome to Lesson 12 in the C# from Start to Finish course. My name is Tim Corey, and today we're going to start working on the Create Team form. In our last couple of videos, we worked on getting the data access set up for our Create Prize form. In this video, we're going to do basically the same thing we did in the prize form, only this time it'll be to add a new team member or a new person. And before we get to the code, I want to point something out. And this is something I touch on often, but I want to drive this point home. Don't get overwhelmed by complexity. Break it down into small chunks. Figure out which chunk you can do, and then do that chunk, and then come back and try again. Figure out a new chunk to do and do that. By the time you've eliminated all the chunks that you can do, the problem should be fairly small. Let's take a look at our form. As you can see, there's a lot going on in this form. And especially if you're a newer C# developer, I'm sure this can be a bit overwhelming. We have 4 buttons, 2 lists, and a bunch of tables behind the scenes that we need to use to support this form. But if we look at this in chunks, we can see there's an Add New Member section that's practically a separate form. And it looks and it operates just like the prize form. And that makes it a very clear chunk that we can do. And since it isn't really tied to anything else in this form until the very end, after we've created the new member, let's start there. Now the first thing to point out is that the Add New Member is actually adding a new person. We come to the database and look at the people table and do the design view. We have first name, last name, email address, and cell phone number. When we talk about a team member, all we're really talking about is the person ID and the team ID. So this is more an add person. But in the form, it makes sense to call it Add New Member since we're talking about team members. So with that in mind, let's create the event for this button. Now there's a couple different ways you can create events. If you want the default event, which we do, you can double click on the button and that will create the event in the code. Or you can go to Properties, go to this lightning bolt up here. We click on that and find the event we want and either do a drop down and select an already created event for us, or we double click in this area in the gray space, the white space, whatever the color is that your background is. If you double click here, it will create that event as well. And you can do that in any one of your events. Now we're doing a default event, so I can just double click right here and it creates that event for us. Now this comes back to naming. We worked hard to make sure that everything was named properly. And we did that up front because when you start creating events, this created the Create Member button _click event. Well, that's tied to the Create Member button. But if I had called this button 1, then this would be button 1 _click. If I come back over here and change this to the Create Member button, this event will not change its name. We have to go in and manually change that name. And that's just a pain. So my suggestion is get your naming done first. The first thing you do right out of the gate so you're sure that your naming's locked in before you start creating events. Now in this event, essentially what we want to do is we want to take the 4 fields here, create a person model out of them, and then save that to either the database or the text file. So just like, let's go over and look real quick at the prize form code. We validate the form create a prize model, save that prize model, and then clear out the form. So that's essentially what we're going to do again in this one. So the first step is to validate this form. And what validation do we want to have on this form? Well, we can just create a method Do we call it is valid? Let's check it out real quick. It's usually good to keep, now we call it validate form. It's usually good to keep the same naming convention so you just know what to expect. When I see validate form, I know it's going to do a certain task. And really here, we could do something very, very simple, or even if we said, you know, at this point we're not going to put validation in, we could say to do add validation to the form and then just return true. Because now we can use this and it will work every time, and it's not going to validate anything yet, but later we can come back and say, okay, now I want to put validation in. I go as to do right here, and I actually do validation and return true or false. And so that's a way to kind of bypass the work of validation now and come back and do it later, or come back later and say, I want to up the validation, make it more impressive, more, more robust. For example, for right now, we're just going to say these 4 fields have to have a value. For email address, we could actually validate it to make sure that it has the @ symbol, and that something's before that @ symbol, and there's something after that @ symbol, and there's a dot in there somewhere for, so it'd be tim@iamtimcorey.com. So we can validate certain things, or we can get really robust and say, okay, there's certain special characters it shouldn't have, and all the rest to validate just the email address, same as cell phone number. We could get really specific on, especially if we're expecting US, we could say, okay, a US phone number has 11 numbers maximum. That would be the country code, the area code, and a 7-digit phone number. Now it doesn't account for extensions, but we're saying it's a cell phone number, not a business line. And we can do all those validations, but for right now, I'm just going to validate first name, last name, email, and cell phone all have some type of string in there. So if first name value dot text dot length equals 0, return false. Okay, so I've got this first check here. I'll actually copy this. Now I'll paste it in and change this from first name value to last name value. And then once again for email address and cell phone number. Oops. Cell phone value .text.length. So .text.length, what it does, it says here's the number, the length says here's the number of characters in this property, which is the actual value, whatever is inside of this box. And so it's going to say, is it equal to 0? If it is, return false. So we're going to say if validate form. So if that's true, it's a valid form, therefore we do something. We can also have our else here and say just our message box.show and say you need to fill in all the fields. We can leave it like that. But if it's valid, then what we need to do is create a person model. We have to do control dot, Add the using statement for tracker library.models. And we'll call this P equals new person model. P dot first name equals first name value dot text. P dot last name equals last name value dot text. P dot email address equals email value dot text. And finally, P dot cell phone number equals cell phone value dot text. Once we're done all of that, then we have to send this off to be created. We have the model. Now we actually save this to our database or text file. And if you ever get lost as to where you are, since we've already done this once, you can come back over here to the code for our create prize form, validate form, create the model. Now we go to globalconfig.connection.createPrize. Only instead of create prize, we're going to say global connection, right? Nope, that's not right. Global config, there we go. I'm going to copy that and paste that so I make sure I type it right. Add the using statement for tracker library. Global config dot connection dot, and we have just create prize. We don't want to create a prize. We want to create a person. And pass in our model. So how do we do that? Well, we have to come up here and first look at our iData connection. We have the prize model create prize, passing the prize model. In the same way, person model create person, person model model. So that creates a new entry in our interface. Now that's going to break all of our current classes that implement iData connection, which is actually a good thing. Because that'll remind us, we need to implement the solution or the contract for this iData connector or connection. And so in this case, we have to add the create person method. We come over to text connection, and the same thing happens. It kicks in and says, oh, nope, you can't do that. We have to hit control dot. That little light bulb there kind of goes away. It's hard to track down. Half the time I get it, half the time I don't. And so I have to control dot and hit enter for the top one. In this case, we have now the create person for the text file. So we'll come back to the text file. Let's start with the SQL file. And the SQL file is going to do exactly the same thing as this one does, only with different values. I can copy this. Now, I said before that copy and paste is dangerous, and it really is. So if you're not absolutely sure you can go step by step and replace these things, don't do this. Actually type it out. It's up to you. For this video, it's much more convenient for me to copy and paste than it is to go ahead and type all this back out. All right, so now I've got to fill in my parameters. Well, I don't have place number. The first thing I have is first name, and I have last name. I have email address and cell phone. So those are 4 fields I have. I will probably name these the same. Now again, right now I'm guessing because I haven't actually created this insert store procedure yet. It'll be sp people insert. Now the other thing I don't have is that model.id. If you notice in the prize model, I have this ID. I'm actually going to copy the whole thing. the person model, we haven't created that ID yet. Remember, we didn't actually put our IDs in yet in our models. We left that off accidentally. And so we have to create those IDs because we need to know what those are. All right, so we have an ID now. So now we can actually pull the ID back out and return the model. And really everything here is wired up the way it should be. We're connecting to the tournament's connection string. We're creating our dynamic parameter list, which just happens to be the same, or the 5 parameters. They're different parameters, but it's still 5. The first 4 are first name, last name, email address, and cell phone number. And the last one is our ID, which gets passed the other direction. And so we pull that ID back out. It's called ID. We put that into our model and return the model. So let's take this and go over to our store procedures here and say new store procedure. We can get rid of all this top stuff. Create procedure. What's the procedure name? Well, it's actually dbo.sppeople_insert. What are the parameters? At first name. And that's going to be of type. Let's look at the columns here. That's of type nvarchar100. At last name, nvarchar100. At email address, nvarchar100. And at cell phone number, varchar20. So be careful on that we get the types right, nvarchar versus varchar, and the number correct, so we can limit to the same limit as the table does. And if you get lost here, I do have a course on SQL that is very helpful for C# developers because it kind of gives you a good introduction all the way through actually building real databases that actually work and are a little more complex than just a starter tutorial, but more real world in how they're built. And so that really gives you a good foundation to work with SQL databases. All right, so at ID int output. Let's say equals 0 output. I said equals 0 because we may not even pass in this variable. Now we will, but if someone wanted to call this without passing it in because they don't have it yet, that's fine. We'll default it to 0. Now we can take this out and we can say insert into dbo.people, and that'd be first name, last name, email address, cell phone, and that's it. Values at first name, at last name, at email address, and at cell phone number. And then finally we need to say select at ID equals scope identity. Remember that pulls in the ID of the last created item or identity field in this scope, which is scope is this procedure. So that's our insert here. It'll grab the ID and pass it into the ID variable. And that's going to go the other direction. So if we execute this, we're good to go there. We can actually refresh our list. Make sure it shows up in the list. And it does. Right there. So now we should have an implemented SQL database save for our person. And now if we come back to our, not the prize form, the create team form, we can say P equals and pass it back in. But since we're not actually going to use that anywhere, let's not create a new variable unnecessarily or overwrite that variable unnecessarily. And the reason we're not using that yet is because this is only part one of this form. We're just creating the new member. And really we're dropping it off at that point. We're done. We're not putting it in this list yet. We're not putting it in this list yet. We're just done. And that's because this right here, this add new member section, is one chunk. We're going to do that chunk and then move on. Not try to do 3 or 4 or 5 at once, because that's where the issues slip in, where you start forgetting about sections like, oops, I didn't implement the text connector. So back over here, the last thing this form needs to do is actually clear out first name value dot text equals empty string, last name value dot text equals empty string, email value dot text equals empty string, and cell phone value dot text equals empty string. All right, so that clears that form out. And now we have created a new member when you say create new member. Now we've just done a SQL connection, but let's test it to make sure it works. And I'm big on testing before you move on. So if you can get a little bit done and test it, that's great. Do that. So in order to do that, we have to come back here to Program and change our database type back to SQL. We had changed that before to test our text connector for the prize form. Now we're coming back to test our SQL connector for the create team form. All right, and we're going to test right here. The other thing we need to change back over here is we are running the create prize form, but we're not testing that anymore. Instead, we want to test the create team form. So let's change that in our startup. And now we can run this. We get it started here. Okay, I also want to open up SQL here, and I'll close this out, the procedure. And instead, I'm going to open up a new query window and just say select star from dbo.people. And we have nothing in the list. That'll be important to know for when we actually create somebody. All right, we're going to say Tim Corey, Tim at imtimcorey.com. The cell phone number is 111-555-1212, as in, no, I'm not giving that out. Create member. It blanks this out, which means something happened. If we run this query, we now have Tim Corey, Tim at imtimcorey.com, and 111-555-1212. Don't forget that right now we're not validating this, so it just goes in however we put it in. But SQL works. So that was really quick. That didn't take much time at all to implement this form. And part of the reason why is because we've done this before, and so we know what to expect and know the pattern to use, and so it kind of gets a lot easier. It's a lot easier than it was the last time when we had to figure out how to create the interfaces and how to set things up and so on and so forth, where this one we just say, use the same system we already set up. As you grow and develop as a C# developer, you'll have some of these things in your library, your personal library, where whether it's a formal library you have set up or just the patterns that you remember doing, you'll have these things to refer back to. It makes your job easier and easier, which is why it seems like senior level developers just fly through code. It's not really that they're flying through the code as much as it is they're just re-implementing the ideas they've already had. And they get some new and different ways, and they get some, a little twist on things here and there, but they're just solving the little areas that are complex, and the big areas that are just kind of generic, they're reusing patterns from their previous development career. So that's just something to keep in mind. that as you get more and more experience, this becomes easier and easier. And that's just my encouragement to you to always be practicing. The more you practice, the more you push yourself, the easier and easier these patterns become, where you can just re-implement it quickly. Okay, enough of the soapbox. Let's move on to implementing the text connector. So before I leave this, I'm going to switch this back to text just so we have it ready for ourselves. So I can close this out. And now I'm going to open up my text connector and essentially do the same thing as this, only up here for the create person. And the very first thing I need is this file up here, the file name. So private const string, and this would be the person model, or people, wow, people file equals, we can call this either person models.csv, or you could call it people models.csv. I'm going to call it person models to fit in with the prize models, because see, this lines up pretty neatly. Prize models store prize models. So therefore, person model goes into person models. Now, you know, the casing here, the singular versus plural, you can figure that out for yourself. Naming's hard. Figure out what you want to do. My encouragement to you is always keep the same pattern going. In this case, I'm going to call it plural here, and then I'm going to call it the name of the model, and then pluralize that for the file name. Okay, so that's really minor, but that's up to you how you want to do it. So the first thing I want to do is say, just following the same pattern here, I want a list of person model called people equals, I'll even call it people file dot full file path, and that works the same way, dot load file dot convert to person models. Now we don't have a convert to person models yet. So we need to create that. Where do we create that? I'm going to copy that. We create that in the text connector processor. And that's right here. Convert to prize models. Well, down below it, we're going to have the public static list of person model. Convert to person models. This list of string lines. And this really is essentially the same thing as above. So it's going to be a list of person model. We're going to call this output equals new list of person model for each string line in lines. Now at some point you're probably thinking, wait a minute, you preach dry, the don't repeat yourself acronym. And how is this not repeating yourself? Because I'm essentially copying from up here down to here. And yes, it really is pretty close. The difference is it's not the same. We're using different models, and we'll use the different mappings down here. So it is different. With that being said, there is a way you could create one method that does any different type. It would be kind of complex, and I would encourage you, if you want to go down that road, instead of rewriting all that code, and it's really could be kind of complex, instead think about looking into a library called AutoMapper. AutoMapper will do a lot of this mapping for you from one type to another, or from even this, this list of string here. It can map that out into something different like a list of prize model. So there's ways you can map it, and I'd encourage you to look at AutoMapper if you want to go that direction. But I will tell you this would get a little complex. And the reason it gets complex is because we're not mapping a string to a string most of the time. Most of the time, we have other values as well, like decimal and double and int. These all need parsed. These need to be parsed properly. And you need to handle the idea of error handling, which we haven't done yet. But the idea of what do you do when those things blow up. And all that work needs to be somewhere. And it's different for every column. Therefore, it's kind of complex. Therefore, the easiest way to do this is to spell out your mapping in a method, and then have a method for every single different type of model. Yes, it's a lot of code, but sometimes you have to write a lot of code. All right. So I'm going to start writing code. String array calls equals line dot split single quotes with a comma inside. And that splits our line, which is one record. It splits it up by commas. Therefore, we can have it comma delimited. The key here, though, to note is we're splitting on commas if you have commas in your data. That could be a problem, because with commas in your data, then you're adding extra columns essentially and putting the wrong data in the wrong columns. And that's a problem. Now you can wrap your strings inside of quotes, and that won't happen then if you're careful, but this split will still split on that. Since the split is really just a really basic splitter. It's not the more complex CSV processors that are out there. The quotes will help with opening Excel and those type of things. The quotes won't help you here unless you do a little more processing in this code. So just note that the cheap way, the easy way to fix that, if you do want to have commas, is to use a different character to split on. Instead of comma, it could be any character. So you could even have, something weird like the pipe command, the pipe key, that. You could use that. You could use the hashtag. You could use the @ symbol, which wouldn't work really well because you probably have email addresses and that uses the @ symbol. So you have to think things through, but you could also split. There's an overload of split. If you do the Control-Shift-Space in here, we are using the char separator, but we could also do down here the string separator, which is the double quotes. With a string separator, we could actually separate on more than one character. So that looked like this, the double quotes. Inside here, we could say, double pipe or triple pipe, or we could have, something even weirder like maybe it's pipe and then the caret and then pipe. And if you have that in your text, you're going to have problems anyways. So you could do something complex like that if you want to split in order to get around the idea of having commas in your data, or possibly have commas in your data. But in our case, I'm going to assume, at least for now, that we have no commas in our data. If we find there are commas, I'll either change this right here to something else, or I'll take those commas out in the validation process. Okay, so now we need to create our person model. We'll call it P. We're going to start adding to it. So P dot first name equals calls 0. Remember, ordering is now important. Calls 1. P dot email address. I'm using the same order I've used over and over again. Notice since they're strings, it's really easy. There's no parsing to do. All right, so there's the 4 lines. And then I can just say output dot add P. And I forgot one. And it's going to change the order, which is a problem. Did you catch the one I missed? P.id equals calls 0. And that's going to yell at me because I need to have int.parse calls 0. And again, that parse will blow up and crash our application since it's an unhandled exception if we pass in a non-number string. Okay, so we've created our person model. We have added the 5 values to the 5 properties. And then we've taken that and added it to our output list. And so the last thing is return output. So we can save that. We can come back to our text connector and pick up where we left off, which was we were just creating this final piece here so that now we have our people, which is a list of person model. That people has now been created. And what this line has done is it has taken our file name, personmodels.csv, converted that to full path using our app.config. It's loaded that file, making sure it exists. And if it doesn't exist, it returns back an empty list. But it takes that list, if there is a list of the empty list, and it converts it to a list of person model. Again, if it's an empty list, we get an empty list of person model. Otherwise, we get a list of all the people in our CSV file. Next, we're going to need to find the max ID. In current ID, we're going to start off, initialize it at 1. Remember down here we said that we start off, the current ID is going to be the max ID plus 1. So if we can't find any records, then we're going to leave it at the default, which is 1, which is what we want to start the first ID at. So if people.count is greater than 0, the current ID equals people.order by descending x arrow x.id. So that's going to order this people list descending by ID. Take the first one, take its ID, add 1 to it, and that's the value of the current ID. Then we're going to take our model, the one passed in to create person, model.id equals current ID. Then we'll take that, say people.add our model. So whatever we have on our list, whether it's an empty list or a list of 5 or 10 or whatever, people, we're going to add our new person that we want to create into that list. Just what we did down here. And then we're going to say people.save to people file. And take the people file and pass that in. We don't have that method yet. What is the people file? Well, just like the save to prize file, we're going to create a save to people file. And that again is over here in the text connector. It's the text connector helper or the processor. Save to prize file. Well, we're going to public static void save to people file. This list of people or person model models string file name. Now let's comment this out for a minute. I just want to show you something. Over here in our overload, and give it a second to refresh, this is going to have a red squiggly under it saying I can't find this. But if we look on our Control J list, if we look under the S's, it hasn't updated yet to say, no, there isn't a saved to prize file. Oops, I'm in the wrong spot. That's why. All right, there we go. Save to people file. It's not there. If I hit Control J and look for my even saved to prize file, the method we created before that we're already using and down below what we're using, I don't find it. Why is that? Well, because the extension method for save to prize file is on a list of prize model. Over here we have a list of person model, not prize model. Therefore, it's not even going to find this extension method. It will find this one though. All right, we're going to have a list of string lines equals new list of string. For each, we're going to say person model p in models. We're going to say lines.add. We're going to do our $sign syntax. And I'll finish it off with a semicolon so it can be complete. And then inside the double quotes, we're going to say p.id, comma, remember no spaces here, p.first name, and order is important. Oops, no space. p.last name, p.email address, p.cell phone number. And what's that doing? It's creating one string that is the ID, comma the first name, comma the last name, comma the email address, comma the cell phone number. And that's the same order as ID, first name, last name, email address, and cell phone number. There's our columns. And there's our columns laid out. So that's going to loop through our list of person model, our models. For each one, it's going to add that entry to our lines string. And then finally, we have the file.write all lines, file name dot full file path, oops, file name dot full file path, and lines, just like up here. Could have copied and pasted. What this does is it writes all the lines we're going to pass in. That's these. Where does it write it to? This file name, but the file name is not good enough. We need the full file path, including that name, which is what this extension method does for us. With that being said, we can save that, come back over here. This is now working properly, at least it should be. The last step we need to do is return model. Why? Well, we have created our list of the existing people. We've found the max ID and add 1 to it, or given a 1 if we don't have any people. And we've taken that and put it in as our model's ID number. Now it has an ID number. We have saved this model along with all the rest of our models, if any, back to our text file. And now we're passing back the original model it got passed in, only this time it has an ID associated with it. Okay, that's it. So now let's start this up. I can pull this over. I'll also pull over our folder. Notice our folder has the prize models.csv file, but not our person models. So let's add Joe Smith Joey at smithy.com. Let's just do a 555-1234. Not a great phone number. It doesn't have the area code or country code. That's okay. Create member. And now we have a person model.csv. I can open that with Notepad. Pull that over and it says 1 Joe Smith Joey at smithy.com and our phone number. Just to make sure that still works if we do another one, let's do Sue Storm sue@stormy.net, and a cell phone number is that. We'll create the member, and we'll look at this file again. And now we have ID number of 2, which means we are incrementing our ID, and all the values are still there. So that's great. We are now saving to our text file as well as to our SQL file. And with that, we have implemented this little section here. Welcome to lesson 13 in the C# from start to finish course. My name is Tim Corey, and today we're going to continue to work on our create team form. In our last video, we wired up the add new member section of our form. In this video, we're going to wire up our dropdown and our list box, as well as taking the add new member section, taking that object we created, that new person, and adding them to our list box as well. So that's the plan for this video. Now let's get started. Over here we have our form. Here's our dropdown, and here is our list box. Now, if you've seen my previous videos where I've wired up forms before, you know that behind this combo box and behind this list box, I'll have a list of, in this case, list of person. And for each of these, it's going to be a list of person. So let's go ahead and create those. This is my code behind. I hit F7. You can also come down here, right click on your create team form, and say view code. That works as well. Now, at the class level, not inside of my constructor or inside any of my methods, I'm going to create a private list of person and call this available team members. Equals new list of person, private list, it's actually person model, but person's fine. Selected team members equals new list of person model. So what's going to happen over here is we'll have all the people that are available that could be on this team in this dropdown. We're going to select one, hit add member, and they come over here into this list box. Now, if you decide I want to add a new team member directly, you can create the new person, that'll create them, and then take that object and put it directly into this list. The next time we open up this form, that newly created person will now be in this dropdown. One other thing to note is you might be thinking, well, I could limit this so that the second team I create doesn't have those team members available to it. So this combo box can get smaller and smaller. And you could probably, maybe, kind of. The problem with that is this create team form is not directly tied to a tournament. Now, in our system, a tournament kicks off this form, but let's think this thing through. We can have more than one tournament going on at a time. So if we had a basketball tournament and a ping pong tournament, wouldn't I be available to be on a team for both? Therefore, be on two different teams. So it would get really complex to try and figure out how to limit this combo box to only people who are available to be on a team. Let's think worst case scenario for a minute. What if you had a ping pong doubles tournament? And so you had 2 people per team. And in the office, you have 7 people. Well, ideal would be 8. So maybe one person does double duty and it's on 2 different teams. That's a possibility. So instead of trying to do all this crazy logic to limit this combo box, we're going to leave it alone. The only limiting we'll do is if we have added a person to this list, they won't be in this dropdown. That's the only limitation we'll do, which actually makes our job easier. Okay, so we have these 2 lists. The available will go over here, and the selected will go over here. So that's our 2 lists. Now let's create a method that wires these lists up. So I'm going to create a method called private void wire up lists. And what this will do is it will wire up our dropdown or combo box and our list box to our list. So we can say, let's get the name of the dropdown. The dropdown is, here's the properties. It's select team member dropdown. Select team member dropdown dot data source equals available team member. Now we didn't used to be able to do this. We used to have to create a binding source between our dropdown and our list because the dropdown didn't know how to deal with a list directly. We don't anymore, which is great. That makes life a little easier. The other thing we need to do is look at our display member. Now our display member is a string, but that string represents one property inside of your, in this case, person model. So let's look at the person model and see which property do you want to pull over that represents the person. And I don't see one. I mean, we have first name, that's great until you have two Tims. Then it's a problem. And last name is great except when you have two Smiths. We could do email address, but do we all know each other's email addresses? It doesn't make sense. So let's create a new property that's a read-only property that uses the values from more than one of these properties. Now you could do the prop full and then just delete the stuff you don't want. You can delete that, you can change that to a string, change this, delete this, and then modify this. You could do that. Or you can just type it out. It's up to you. I'm going to type it out just so you can see it. Public string. I call this full name. And it just needs a get. All right, this get needs to return $, double quotes, semicolon, inside semiquote, or the double quotes. We'll do first name, then a space, then more curly braces, last name. Now we could return last name comma first name if you wanted to. If so, I'd probably call this full name reversed or full name last first. You know, some way of indicating that it's the full name, but it's got the last name first. But I think we're fine with doing the full name as it is. So I'm going to copy this. Normally we don't copy and paste very much inside of code because that's where your bugs come in, when you copy and paste and forget to change all the different areas that need to change. But in this case, I really highly recommend it because we have to put this name inside of double quotes. And that means there's no IntelliSense. There's nothing saying that's not right or that is right. Even if I typed this wrong, it wouldn't tell me that until runtime. And in fact, runtime, it wouldn't really tell me that. It would just give me a weird value in my list box or comma box. So I copy and paste there. So that's our select team member dropdown. And then we have this team members list box. So team members list box dot data source equals selected team members, and then the team member list box dot display member is going to equal full name as well. And again, I'm going to paste that in there. So both will have full name. Now let's call this inside of our constructor. There we go. And before we go any further, I'm actually going to create one more method. Private void create sample data. And what I do with this is I create a sample couple of records that I then add to my different lists. That way I can make sure the lists are working the way they're supposed to. So let's say available team members dot add new person model, curly braces. I'll put my semicolon at the end first and come back and say first name equals Tim, last name equals Corey. Now I don't need to fill in the other fields because this is sample data and I'm only displaying just the first and last name. All right. And now I'll also do selected team members dot add, new person model. Same thing, put our curly braces, put the semicolon at the end, come back. I'll copy that and paste it again, and Jones. There we go. And I'll put this method before the wire up lists in my constructor. So I'm going to add 2 records to each of my lists and then wire up a list to the data sources of the dropdown and the list box. Why is that important? Well, if we start this, once it starts, you'll see that I have sample data in both lists. Here's the dropdown with Tim, Corey, and Sue Storm. And here is the list box with Jane Smith and Bill Jones. So both are working as they should. And now we can start working on putting actual data in here and then moving data around once we start wiring up these add member button, delete selected, and even tap into what this button is doing. So that works. So now I can actually get rid of the create sample data just by commenting it out. And the reason I do that is because I might want to come back later and put that in for testing purposes. And it really is a matter of uncomment, and that's it. The great thing about the compiler is if I were to send this code to production, this create sample data is never used, and it will not really do anything to my application to make it run slow or anything like that. It's just kind of there. So now let's wire up actual data collection here, or at least data display from our database or our text file. And how do we do that? Well, we need to come over here to our iData connector. And in here, I'm going to create a new rule or a new item in our contract. I'm going to say it's going to be a list of person model. I'm going to call this get person underscore all. That sounds a little bit weird, but what I'm saying is I want to get, not people, I'm going to say get person because that's the model, the person model over here. Get person all, just like create person. So my schema or my naming convention is going to be create for any kind of insert statement, get for any type of select statement where I'm getting records back. Now I don't need to pass anything in because we're getting all the people, and therefore that's all we need for our contract. Now let's come over to SQL and say, well, you're not currently implementing, so control dot implement the interface. We can scroll down here and see that we have this right here. So now we can say using IDB connection equals new system.data.sql client.sql connection global config.cnn string tournaments. I'll put one more at the end of that. We hit enter, and now inside here we can actually call our store procedure, which is over here. We have it already created. It's the people get all. So if I run this, oops, dbo dot sp people get all. And right now we have one person in our database. That's Tim Corey, and that's from our previous example where we were writing the SQL to test to make sure that the form worked. So that's all the people we have, and that's okay. We're going to call this stored procedure. Now before I call that, I'm actually going to create an output variable, a list of person model output. I'm not going to initialize it. Instead, I'll say output equals connection.query. This will be a person model. And then I will say, here is the store procedure. And that's really it. Dot to list. That converts it to a list from IEnumerable. And then at the very bottom here, we can return output. Now, you may be looking at that and saying, I can make this simpler. Take away this, and take away this, and just say here, return. Return this call. And yes, that is true, that is simpler, but here's the caveat to this. If I have any kind of issue where I want to debug, catching this before it returns the value can be tricky, especially if you have just a return statement here. Now, with this way, I could put my breakpoint right here, right after this is loaded, and then inspect this variable. It makes it a little easier for debugging. So I'm going to leave it that way so I have it in place for debugging. After I'm kind of comfortable with it, I might return it back to just a return, but I probably won't, because down the road, when I need to debug something, I don't want to have to rewrite code in order to debug. So I'll probably leave it that way. And that's something you're going to need to think through on your own. Is this way I'm going to do it or not? And that's really up to you. Okay, so we have this list of persons getting returned when we call the getPerson_all. And just so we don't have any problems here with compile time, I'm going to do my control dot and implement the interface, but notice it has that throw new not implemented exception, which is great because I don't want to implement it yet. One other thing to note is now that I've started to fill this in and I have more items in here, I'm starting to notice a repetition. This magic string tournaments. I'll want to fix that, and so let's actually just do that here. All right, so let's call it DB. And now I can replace all of these instances where it says tournaments with that string constant. And that way, if I ever need to change it, I change it here, and it changes for everything, not just one location. So if you're repeating yourself, figure out if you can do something different to make that a little easier or a little better. Okay, so we can come back over to our form here. And now instead of create sample data, I'm going to have a method that says private void load list data. And here, I'm going to start by calling the global config dot connection dot, and then right down here we have get person underscore all. And I will put this in the available team members. Now I could put this directly in here, and I might do that. It seems like it's a waste to create this method to do what's already been done, and it's also kind of a waste to have an initialization that then gets overwritten by this. So let's do that. Let's make it a little cleaner and do it just like that. So that's the available team members list. We can get rid of this. And notice nothing happens to the selected team members. And that's intentional because we don't need to change anything in that list. It should be empty to start with. We don't have anyone in the team to start with. Now if we run this form just as it is, let's make sure that we are in fact running from SQL. We're not. So let's change that to SQL. And now we can run it. And now if you notice, we have just Tim Corey as the selected team member, or all the team members in this list consist of just me. If we wanted to, we could add a new person, but it won't add anywhere yet. And instead of doing that now, let's do that once we've wired up where this goes. But first, I want to wire up what happens when we hit the Add Member button. I want to take the person from this list, remove them from this list, add them to this list, and then refresh both. So let's create our event for our button. I'll just double click this time. And there's our button event. And so the button event's job is going to be to take the person out of this list, put them into this list, and then refresh. So how do we know who's in that first list? Well, we're going to say person model P equals select team member dropdown dot selected item. Now that won't work until we cast it. We have to cast it to person model. And essentially what we're saying here is this normally is an object. If you notice, it says object right here for the type, but we said, no, it's not an object. We know that, well, everything's a base object, but this is more specifically a person model. Now, what'll happen is C# will say, okay, I'll trust you. And I will say, yes, this is a person model. And we'll take the selected item and try and shoehorn it into a person model variable. If it works, that's great. If it doesn't, it will blow up. But since we were the ones that filled in this dropdown with a list of person model, we know that's correct. So we're okay in this case. Now that we know who's been selected, we can say available team members dot remove. And that takes in a person model. It's going to find that person and remove them from the available team members list. That's P. Selected team members. It's not selected. Our list is, selected team members. So selected team members dot add P. So I've taken this person, I've found out who they are, what the actual person object is. I've removed them from the available team members list, and I've added them to the selected team members list. Now remember the way object instances work. We're not making copies here. We have taken the blueprint of the person model class and we've created a house. And we've said, okay, here is this house. It's at 123 Sesame Street. And so when I say find which one is selected, it's essentially saying the house at 123 Sesame Street has been selected. So when I say remove the object at 123 Sesame Street from this list, it says, okay, that does not destroy the house. It doesn't bulldoze the house. It just takes that address out of our address list. And conversely, we add that address to this address list. So we aren't making copies here. We're just moving who has that address around. In this case, we now have it removed from one and added to the other. I'm actually going to call the wire up lists method again. And now let's come through and do that same thing. It'll reset the data sources. That way they've been refreshed. And one of the benefits here is I can actually have a limited list, meaning a list is ordered by or has a where clause in it, something like that. Then I have my data source list. And so what I can do is I can actually do that limitation here. And every time any kind of data changes, like down here, it'll refresh that list. Now let's see this in action. We can only do it once, but that's okay. We have Tim Corey in the list. We hit add member. Nothing seems to happen. And so let's find out why. That's a great opportunity for us to debug when something we think should happen doesn't happen. What do we do? And so let's come down here and put our breakpoint in our event. I'm going to say add member. And it's going to say get the selected item. I'm going to step over that. Now the selected item is Tim Corey, so that's good. Now let's look at our list. Our list of available team members has nothing in it, so we can't remove it from them. And our selected team members has one person. So that seems like it should be displaying the right thing. So why is it that nothing here is displaying the way it should? Well, it would seem like the issue has to do with our wire up lists. It seems like this wire up lists isn't actually refreshing our data source since it's the same list. Now we can play around with something like select team member dropdown dot refresh and see if that works. And actually I'm going to take this, I cut it, I'm going to move it down here. Instead of wiring up the lists again, I'm going to do this instead. And this is a great time to debug. There we go. This is a great time to debug because we can learn a little bit more about how things are actually working and how to track down a problem. Because here's the deal. So far, my application has just kind of worked. And that really doesn't happen out of the gate that often, at least until you're well down the road of being a programmer. And even then, that's pretty much a rarity. I typically spend half my day debugging why my awesome logic didn't work. And so debugging skills are really important, and they also help you learn. Because as you track down problems, you may even find a bug in how C# works. Now, here's the deal with that. Don't assume that it's a bug in C# until you've eliminated everything else. I mean, everything else. Because 99% of the time, it's your bug. So, in this case, let's do a refresh instead of rebinding these lists and see what happens. So I have Tim Corey selected. I hit add member, and nope, that didn't do it. So I read about, and this is one of those Googling things, I read about a solution that seems a little wonky, but it was suggested as this is the way to do things. Take the drop down and say data source equals null. And then down here, data source equals null. So you set it to null first and then your list, and that should work every time because it changes that list and it forces a refresh. Let's just see what happens. Add member. Now he's over here and not over here. And that worked. So it worked the first time because it displayed Tim Corey over here, and it worked the second time when I hit add member and it moved him over. So that seems to work. So our solution, at least we found so far that works, is to set this to null first. Does that hurt anything? Probably not, but it would possibly trigger some event loops to happen, but we're going to have that anyways. For example, the selected item is going to change. Well, that's because that's going to be happening anyways, because Tim is going to move from here to over here. Therefore, the selected item over here will change. So that's going to happen anyways. Do we like this solution? It's not the best. Do I have a better solution for it? Not at this time. And so what I might do is I might put a to-do in here that just says, hey, when you get a chance, or a low priority to-do, when you get a chance, why don't you look into if it's a better way to do refreshing of the data binding? So, but otherwise, it works, and it's not terribly inefficient. Therefore, we'll leave it as complete. So now we have this wired up, we have this wired up, and we have this button wired up. We have a couple more to wire up. We have the delete selected, which is probably misnamed. That should probably be remove selected. In fact, let's go ahead and change that now. And also change the name up here. That way, everything is set before I create an event. So remove selected takes the person from this list and puts them back over here. So let's create that event. So it really is the same pattern, and I'll copy and paste here, but I have to remember to change things. The drop down is actually the team's member list box. So instead of being the select team member drop down, it's the team members list box. So whoever's selected in there, pull them over, and then we'll do the opposite of right here. We're going to say selected team members dot remove p and available team members dot add p, and then wire up the lists again. Let's test that out. So we have Tim over here, we add him, we select him, we remove him, and now he's back. If we fire this off, nothing happens because we don't have anything selected. But notice I just broke my code. What just happened? Well, we found a bug in our code in that if no one's selected, weird things happen. So let's start this again. Get a fresh set here, and we're going to pause it on removing the selected person. So add Tim, that's cool. Don't select him, hit remove. The selected item is null. If we step over it, we now have a null person model. Well, we're going to remove null from the selected team, I guess. We're going to add null to our available team. Yep, that's kind of ugly. So now we still have Tim in the selected, and the available we now have one that is null. We continue, select Tim and say remove selected. It knows we've selected one. We skip over that and it says that person is Tim. We remove Tim from the selected team members list. Now it has 0. We add him to the available team members list. It now has 2, the null and Tim. And wire up the list. And it looks like these are both blank, but if I drop this down, we have a weird error in this list. Why is there a weird error in this list? Well, probably because we have a null value in it. So I said we'd handle exception handling in another video, and that's true, but we do want to have at least some basic error checking or some way of validating our data when we do this. So let's create a validation here. Wrap this right here. I'm going to select these 3 lines, actually 4, right click and say surround with if and tab. If P does not equal null, we're going to do that. So the same thing up here, right click and say surround with if P does not equal null. All right, so there's our 2 checks, one for each of our buttons. Let's see if they work. We can't unselect Tim. He's already selected. But if we don't select anything here, we hit remove. We do Tim, he goes back over the list. So it looks like there's only 1 entry here, even if we hit the remove selected without selecting Tim. All right, so that's a bug fix already out of the gate. And that's one thing you want to do when you're creating this type of thing, where you're wiring up a form. You want to try the things that might break it. It always amazes me the things that users do just without thinking that are really awful. They do things that you're like, why would you ever do that? And so instead of reinventing the user, which we can't do even though we can fantasize about it, instead we have to reinvent our application to handle these users. Therefore, we have to try things that are just wacky, like not filling anything out and hitting create team or create member or remove selected, and what happens. So try those things out. As you come across them in your code, fix them, and if you can, have some really good testers test your application with the eye towards breaking it. Because you don't want testers who are all nice and follow all the rules, which some testers can be very conscientious to do. You actually want testers who are rebels, who say, nope, I'm going to break this thing and try every different way to break it. And that's really good for your testing experience, because you'll see what users will do when your application is in production. All right, so we've wired up our lists, both our drop-down and our list box. We've wired up the add member button. We've wired up the remove selected button. Now let's modify this button so it adds a person to this list. To do that, let's just double click on this button. There's already an event created, so it just takes me to that code, which is really convenient. So we already have this person model P, which gets created and updated. And in fact, we can actually say P equals globalconfig.connection.createPerson. That way we capture back the ID as well. And before we wipe out the values, or after, it doesn't really matter, but let's do before, we're essentially going to put them into, it's actually down here, we're going to put them into the selected team member and do the wire up. And copy this. It's the exact same code. We're going to add them to the selected team members list, and we're going to rewire the list up to refresh to show that new value. And that's it. If we run this, we have Tim Corey. Let's add a new person. We'll create Sue. She immediately goes in this list. I can remove her. She is now in this list. I can add her back. I can add Tim back. And then I can do no more. But I can remove Tim I can add Tim, I can remove Sue. We can do all the different iterations and test things out. But essentially, everything we've started out to do is now wired up. We can add a member, remove a member, create a member, and it all works correctly with all these different, the drop down the list. The last thing we're going to do is going to be for the next video, and that is to actually create our team. This is a little bit more complicated in the fact that we're going to have to save a couple different pieces of information into our database or text file. So we're going to do that next, but before we go, there's one thing we haven't done yet. I wouldn't find that out, unless we remember, until we did this. If we do this, we're going to get this error right here. Not implemented exception was unhandled. So what happened? Well, what happened is we didn't implement the getPerson_all method. So let's do that. Let's implement that method. And you're going to love this because it's going to kind of blow your mind, I think, how easy this is. Return people file dot full file path dot load file dot convert to person models. Guess what I just did? I just implemented that getPerson_all. How did I know what to type right here? Well, it's actually right here. I just read it. Because whenever we save a person or insert a person into our text file, we first read all the people out of that text file. So how do we get all the people out of that text file? That right there. Therefore, we just put that line down here. I did a direct return instead of creating the output variable. Like I said, for testing purposes, that might be a little more difficult to test, but that's okay. In this case, I'm just going to leave it as it is. If I need to test it later, I'll work on changing that. But now, if we hit start, no error, and we have Joe Smith and Sue Storm in our list. Don't get confused, Sue Storm is not from the database we just created. Instead, I created Sue Storm in my text file as well. And just to show, we can say Bob Smith, bob@smithy.com, and cell phone is 555-7756. There's Bob Smith. We can also remove Bob Smith. There we go. And now if we close this out, start it up again, we will see that Joe Smith and his brother Bob are both on the list because we added Bob the last time. So, implementing text files, not a big deal. So now our part 2 is complete. So we have these are all implemented right here. We just need to implement this button, create team, which takes in a team name and all the other data we created and creates a team out of it. Welcome to lesson 14 in the C# from start to finish course. My name is Tim Corey, and today we're going to finish working on the create team form. So far, we've wired everything on the create team up except for the button that actually creates the team. So in this video, we're going to change that. Now we have to figure out first what this button should do. We have a team name, we have the people on the team. Sometimes I find it helpful to go back to the database where we've designed things out and see where this is going to live so we can kind of help see what our ideas were when we built this thing out. So we have here teams. Let's design this. It has just really two things, an ID and a team name. And then you have team members. And that has the row ID, the team ID, and the person ID. And that's it. So we have two tables to fill in. First one is teams, and the second one is team members. And that order is important because in this one, when we create a record, we'll get this ID back. We'll use that ID right here when we also add each person. So it's going to be a two-step process. And the first thing you need to do is create or store procedures. We have the team get by tournament, but we don't have any inserts for the team or the team members. So let's create those. New store procedure. We'll delete out all of this. Again, I would leave this and actually fill it in if you're actually creating these store procedures. And the format is SP teams insert. Now, what do we need to know for creating a team? Well, we need the @team name. And if we look at the teams here, the columns, we can see team name is an nvarchar 100. So that's all that's coming in, but then I'm going to have this @id int equals 0 output. And that'll be the ID going the other direction. We'll leave the no count in, but take out the comments. And we're going to say insert into dbo.teams team name values at team name. And then select @id equals scope identity. And that's it. So we have our team name being passed in, and then we're pulling back that ID as an output, and that's we capture here, just like before. So we run this, and while we're here, let's also create the team members insert. So let's expand this out, and I'll create a new store procedure. The temptation here is to copy this and just modify it for what we need. But I'd recommend against that because, again, just like copying in code in C#, the likelihood that you miss one little spot and cause a problem is pretty high. So dbo.sp team members underscore insert. And here we have @team ID int, @person ID int, and @id int equals 0 output. Take out the comments. We're going to say insert into dbo.team members team ID person ID values @team ID @person ID. And then again, select @id equals scope identity, and we're good to go. So we'll run that, make sure it runs. We will refresh down here just to make sure those two do pop up on the list. So there is the team members insert, and there's the teams insert. So both of those are working, or at least they should. Let's come back over to here and double click on this button to create the event. So now we have the event, and what should we do here? And the decision here is, do we call two different methods, or do we call one method and have it do both jobs? So we have two different things going on. We have the team name being sent, and ID gets passed back. Then we send the list of IDs from here, and also the ID from the team, and then we have our team members list. So is that two actions or one? Now we have the idea of the single responsibility principle, from the SOLID acronym. And the idea there is that each method does one thing. But the question is this one thing or two? Now, I'm going to argue that this is one transaction. You can decide, nope, I want to do two different ones. But here's why I'd argue it's one transaction. Because you're creating the entire team. Both the name and the members are one set of data. They go to two different tables, and it'll be two different insert statements, but it's one set. Therefore, I like the idea of doing them together so we don't do half the job and then fail and not do the other half. So let's start at the iData connector, or connection. And we have here our create prize, create person, and now we need some type of create team. And if we look at our team model, we see we have a list of person model and a team name. So that's perfect. So we're going to say, let's put it up here. Doesn't matter where you put in the list. Team model, we'll return the whole model all over again. Create team. Team model. So we're going to pass in a team model, just like we do it with prize or with person. It's just a little more complex. And we're going to get back a team model because we're going to pass back in that ID. But if you noticed over here, there is no ID. So let's add that. And also this ordering is bugging me. I'm not sure why you ordered it that way. I'm going to switch those around so that team name's above the members. All right, so just like with prize model, we have the ID. With team member, we have the ID, which also makes me think, do we have ID in person model? And I believe we do, but let's just check. Yes, we do. So we have all the IDs we need to be passing back and forth. So now we have a create team part of the contract, our iData connection contract, our interface. And so now each of these two connectors, SQL connector and the text connector, they both need to implement that interface. So let's do that. Let's go into both and make sure that they both implement. Control dot and enter. And that just creates our public method with the throw new not implemented exception. That's fine. We'll come back to text in a minute. Let's start with SQL. So here we have our SQL where it says, okay, you want to create a team? Great, go for it. So let's start with a using. And in fact, we can copy and paste this using statement because it's really the same thing. Oops, let's not copy a query. Let's copy and execute instead because it has the way we're going to do executions. So let's copy this and paste it right here. So we're actually going to do two different inserts. The first one takes in the team name, and the only other thing it takes in is actually an output, and that's the ID. So team name, we're going to say model dot team name. Since we copy and pasted, we have to be very careful to check everything. So let's go through, make sure we have our database is correct. It is. Then we have our team name, our ID. It's an output. We come down here. This is not correct. And come back over here to our SQL. I'm going to copy that and paste in right there. So we have the correct value or the correct name for our store procedure. We do have a model.id, and that is the team ID, so that's perfect. But before we return the model, we have to do some more work. What we need to do is we need to insert every one of those people into our table. If we come back over here to our SQL, And look, we take in one person. So this team members table is going to have a number of rows per team, one for every team member. And doing that is fairly simple. We just need to do a loop. In this case, a for each. For each person model P in model.team members. So we'll loop through this. Oh, we already have a P. We'll say TM for team member. All right, so for each one of these, we have to do a new insert. Let's copy this. Paste it in there. All right, so instead of SP teams, it's team members insert. So we'll change that store procedure. And this is a tricky bit here. We already have a P, but it's a dynamic parameters, which we want to use. Therefore, we can just change it to not say var in front of it. And now we're just going to overwrite that P every time, which is great. It's what we want. Now let's grab our parameters. So you have team ID and person ID. So at team ID, and that's model.id. And then the same for each one of them. We're not actually going to need to grab the ID coming back out because we don't need it in any way. So we can ignore that and instead do the at person ID equals, and it's not model because it's per person model, so we want to say tm.id. And they should already be filled in because these people are already in our database, and so we have IDs for all of them. Even if we add a new person, we first get the ID back after saving them, and then put them in our list. So we always have IDs for all of our people that we're adding to a team. So that's all there should be for the create team portion for SQL. So we'll ignore text for now. And we'll come back over to our form and the code behind. All right, so in here, first we want to create our team member object. So team model T equals new team model. T.team name, oops, not members, name, equals, we had to grab whatever the name of this is. It's team name value. So team name value dot text, and then the T dot team members equals, and that's just our list up here of selected team members. And notice it's a list of person model, and this is a list of person model. So that works fine. And now we say global config dot connection dot create team, pass in T. We can say T equals, just to capture it back out. And now we're done. Now the team has been created, and really this form should close because we're not going to leave this open to create a new team. We're going to go back to our other form that called this, most likely. But just to be on the safe side, what we can do is we can reset up all of this information. So let's create a note to just remind ourselves, hey, if you're not going to close out this form, reset it. So let's do that over here. I'm going to say to do, if we aren't closing this form after creation, reset the form. So I'm not quite sure how we're going to use this form yet. We haven't really talked about how these forms all interact, but I think that we're going to drive everything off of the create tournament form. And so it'll create a team, it'll come back, it'll add that team, and then it'll say, oh, I want to create another team, and do the same thing over and over again. So in that case, we can just close out the form because that will wipe everything out. There's no reason to set everything back up new. So we'll leave it like that for now. And the only other thing we need to do for testing purposes is make sure we change this back to SQL. And now let's run this. Before we get too far though, I want to look at both the team table and the team members table. I'll run both of those, and they are both blank. So that's this place to start. Now let's run this and call it this first team. Let's call it team first place. I'm going to add Tim and Sue to this team, just so we have two. And then I'll say create team. Now remember, we didn't wipe anything out because we're going to assume that this form will close when we hit that create team. But let's go over our SQL and run this again. And we can see that I have the team first place down here. We can zoom in here. There's team first place, an ID of 1. And then we have two people, both on the team ID of 1. The first person is 1, the second person is 2. I would assume that that person 1 is Tim and person 2 is Sue. Now we could look that up if we wanted to. That's not hard. We could say select star from dbo.people where or ID, sorry. ID in 1, 2. And that just says, give me all the people that have an ID of 1 or 2. And that'd be Tim and Sue. So yep, that all seems to work just fine. So now let's wire up our text side. So let's first change this over to text, which right now will throw an error, which is great because then if we were to do this accidentally, we hadn't set it up yet. Notice different people because we're in text now. We create team, it's going to throw that new not implemented exception, which is great. So let's go ahead and implement this method right here. Now again, I'm not going to reinvent the wheel. So let's look at what I did in other areas. For example, here, I first load all of the prize model in, and then I find the max ID. I go up 1, I add the prize, I save that to the file, and then I return the model. So let's follow that same pattern, but now don't forget, we have two different ones we need to add. So first, let's look at the teams. And it's at this point you should have kind of a quandary you get yourself into. And you need to take a step back and think about what you're doing. Because the reality is, and here's where I'm going to land on this, the reality is we're not saving to two files. In the SQL table, we are. We're saving to two different tables. But there's not really a point to that. If you look at the team model, which is what we're passing in, if we look at that, we have an ID, great. We have a team name, great. And we have a list of person model. We don't have a separate model for these people. And by that I mean, if you go to the database and look at team members, there's the team ID, the person ID, and the ID of the row that they're entered in. We don't have that reflected in this model. And that's okay. We don't need to have that information. In fact, it's kind of worthless. Instead, we like to have the person model, which has their name and their email address and their cell phone number and all the rest. So we don't need to have two different text files. Instead, we need to have one text file that just handles the idea of having a list and how we're going to do that. Now, the list can be a little more complicated, and so we're going to figure out how to do that in a way that makes sense. But first, let's start with the basics. We need to have a file to save it to. So let's start there. Private const string, and this is the team file, equals team models.csv. All right, so there's our team file. And just like up here, we can say, let's get a list of team model, call it teams, equals, there's our file name, dot full file path, dot load file, dot convert to team model, plural, models. We don't have that yet. So we need to create that. So let's do that. Let's put it in the same spot as this convert to prize models. And it's okay that it's yelling at me right now. I kind of want that because I know I'm not done there yet. So we have these two converts, convert to prize model, convert to person model. So let's create another one. Public static list of team model, convert to team models. This list of string, we'll say lines. Okay. So what exactly does the text file look like? Remember, it's a comma separated list, so we probably have ID, comma, team name, comma, and that's where it gets kind of tricky. Because if we look at the team model, it's a list of person, which doesn't make sense to say the whole person. That's kind of duplicating information. So instead, what if we have a set of values that's separated? Now, normally it would be a comma separated list, but because this is a CSV file where it's already comma separated, let's do something else. So let's take the list of IDs separated by the pipe. That's going to look like, let's say 3 comma Tim's team comma 1 pipe 3 pipe 5. So that's what a row would look like. And so this represents the ID of a team, the name of the team, and then each ID of each person. Now we're not done there because we're going to have to rehydrate that. We're going to have to pull those people out and say, okay, we have these IDs. What's the full model for that person? So we have to do some other calls here to pull in our list of people. And so we'll do that at some point. But first, let's get this part of it done. So we're going to do a for each. Well, let's create a list first, sorry. List of team model output equals new list of team model. We're going to do a for each string line in lines. And we'll say string array calls equals line dot split, single quotes around a comma, Notice I'm just following the same pattern I have up here. And so now we have a team model. T equals new team model. T.id equals calls 0. T.team name, team name equals calls 1. And don't forget to wrap this one with a int.parse. And now we have to deal with that pesky last column, which is our list of IDs for people. So what are we going to do about that? Well, let's go back and look at our text connector real quick and look at the create person here. The first thing we do is we pull in the people file and convert it to a list of person or person model. That would get us every person that we have saved in our text file, which would give us something to look up then by ID. But this constant people file is in this file. Now we have two options here. One, we can load this down here and pass it in to the convert to team models. Or we can pass in just the string for the people file and then have it do all this work. I kind of like that second option better. So I'm going to copy this entire line, but then down here pass in people file. Now that breaks this, and that's okay. Come back over here and say comma string people file name. And now it's getting unbroken, at least as far as passing in information. Now, why is there only one parameter again? Again, this is because the first parameter is actually the output of this right here. And you can tell that because it says this in front of it. And that's the extension method, how it works. So the second parameter becomes the first visible one you see inside those parens. And that's the people file name. So up here, right after I do my output, I'm going to paste in that line. And then I'm going to change the file name to the passed in file name, people file name. And now I have a list of people. So now I can say string array. We're going to say person. Wow, there we go. IDs equals calls to dot split single quotes pipe character. So what does that do? It takes the third column, calls number 2, since 0, 1, 2, takes the third column, splits it by the pipe character, and puts that into an array called person IDs. Now comes the tricky part. How are we going to deal with looking up these people IDs? Not because looking up the IDs is hard, it's because what happens if we have an ID that isn't in our list of people? That could be a problem. Okay, so we have a couple options. One, we could gracefully skip over that person, or two, we can blow up. I think for right now, we're actually going to blow up because again, that application in an uncertain state or half-done state isn't what we wanted. So if the first record succeeds and the second record we can't find the person, that doesn't mean the team should have one less person on the team. It means we've got an error in our list somewhere. But in this case, we're going to blow up, and that way we know, nope, that didn't work. So for each string ID in person IDs, and we're going to say t.team members dot add. And here's where we do a lookup. We're going to say people dot where x arrow key x dot id double equals int dot parse id. And then we're going to say first, like so, and that should do it. Now there's a lot of curly braces, or I'm sorry, parentheses in there, and a lot of stuff going on. So let's break this down a little bit. So this right here, what it's doing is it's saying take the list of people, all the people in our text file, and says search for it and filter where the ID of the person in the list equals the ID from right here. So in theory, it should find only one person. We're doing a parse int on a string. Don't forget that. Otherwise, it's a string compared to an int, and that won't work. So the theory is each ID is unique, and therefore we should never have more than one. But C# doesn't know that, and so it says, I'm returning a list. And so we say, give us your first item. Now, if you did return 3 items in this list, it would still only give you the first one. But since we know it should be a one-to-one relationship, then the first one is the only one. Now, here's where it's going to blow up on this first. If there's 0 on the list, it's going to say, I can't do that, and it's going to explode. There is an option here, first or default. And what that will do is it will return null if it can't find a record instead of blowing up. But again, that wouldn't crash our application. Therefore, we could conceivably think that this is working when in fact it's not. So we're going to leave it like that. It's going to find the person object and add it to the team members list of object. So all that to say, for each line in our text file, add the ID and the team name, and then loop through and add the team members based upon splitting out calls to, which is this value right here, splitting this out by the pipe, and therefore we know which IDs, which we can then look up in our people list to find the full person object to add to our team members list. With all of that being done, we can return output. And now convert to team models is complete. We come back over here, no more yelling at us. In theory, we have a list of team model called teams. Now we need to follow the same pattern as up here, where we get the ID. And in fact, let's just copy this and paste it. Current ID and teams.count is greater than 0. Teams order by descending by the ID, which is the same name as we give it for every one of them. So that's fine. Find the first, find the ID, add 1. That's our new current ID. Put that current ID in the ID area for our team. And then we're going to say teams.add model. So we've taken the model passed in, we've given it the ID, now we've added it to our list of teams we found from our text file, if any. And now we need to do 2 things. First, we need to say teams.save to team file and pass in the team file name and return model. Return model works just fine because we already have that, it's done. But this save to team file, that's not created yet. So we come back over here, and we have save to prize file, save to people file, and now we will have public static void save to team file. This list of team models string file name. First, we're going to create that list of string. And that'll be what we save at the end. Then we're going to do our for each and say team model t in models. We're going to say we need to add a line for each one of them. But before we do, we have to address that list in there that we have to convert over to our pipe delimited set. So how are we going to do that? Well, we probably need to have another for each, but it seems like that's doing too much in this for each loop. So let's create another helper method. Let's create a private static, and we have return type of string. That's what we want. And let's call it convert people list to string. Let's pass in a list of person model and call it people. So this method's job is to take that list of person model and return a string instead. That way up here, we can just do the same kind of thing, only instead of passing in just the value for that last one, we will pass that value to this method and use the returning string in this place. So that's a little complicated to kind of visualize if you're not seeing it at first, but that's okay. We're going to do it here. You'll see it, and then I think the light bulb will click on. You'll go, oh, okay, I know what I'm doing. So let's start with what we need. We need a string output equals an empty string. And the last thing we'll do is return that output. Before we do, we're going to do a for each person model p in people. And we're going to say output plus equals p.id. And in fact, let's do this as our special string here with a $sign in front of it. That way we can do the pipe right in line. So for each person in the people list, we're going to say add to the output this. First the ID, which will get converted to a string, and then the pipe character. So everyone's going to have that. So after the first entry, say the first entry is 2, it's going to look like this. After the second entry, say it's 5, it'll look like this. Now, before you jump the gun and say, okay, we're done, at the very end, the last thing we need to do is take off this, the trailing pipe character. And the way to do this is fairly simple. We're just going to say output equals output, if I can spell, dot substring, start at position 0, and go to output dot length minus 1. And finally, return output. So what's going to happen is, after we loop through, we're going to have something that looks like this. The last thing we're going to do is we're going to do a substring of our output. And what substring does is it takes a piece of our string and returns that value. We're going to start at position 0. Each character is one number. Starting at 0, it's a 0-based array. And so I said start at 0 and count this many characters. Well, the length which would be all the characters, minus 1. And that starts at position 0, that's right here, then 1, then 2, and it says, well, I had a length of 3, so I stop at, 4, so I stop at position 3, right there, and therefore we're done. So 0-based arrays and with 1-based counts and all the rest can get very confusing. My encouragement to you is, if you're not absolutely certain, what I would do is create a little test project that just does one thing. It is a very simple version of this. In fact, I did that just to double check to make sure this is the way it's supposed to work, because I always seem to get it wrong, except when I don't, and then I question myself. So just test this out in a simple fashion in a test project, just to make sure that you have your counting correct, especially if you're doing things where you're counting only a certain number of characters, or you're going from the middle, or something weird like that, where you really need to make sure you get your numbers exactly right. But before we go out of this method, we have one bug to fix. And you may not have noticed it, but take a minute and try and figure out, maybe pause the video, and try and figure out what the bug is in this method. You figure it out? The bug here is, what happens if we have 0 people in our list? Should we? No, we shouldn't. But maybe we did. Maybe we have a team and no people in it. If so, the for each would work just fine. It would say for each person model P in people, people's empty, therefore I never run. But down here, substring of output, which starts off as an empty string, so count of 0. So it says 0 to output length, that's 0, minus 1. Substring of 0 to minus 1, that's going to crash. So there's a few ways to handle this, but probably the easiest way is to come right up near the top and say if count equals 0, return empty string. And so what that does is it kind of short circuits this process. If there's no people in the list, there's no reason for us to loop through a list or to do the substring and all the rest. Just say if it's the count 0, return empty string, because that's what it would be. So that solves this method right here. So now, just like in here, we can say lines.add. We can do our $sign and the 2 double quotes, semicolon at the end, and come back. We can start off with our t.id, and then our curly brace, comma, no space, curly brace, t.team name, curly brace, comma, another curly brace with no space. And then we're going to say convert people list to string and pass in t.team members. Then close that curly brace out. Now, this method, passing in a list of people, gets back a string of these pipe delimited items. That's going to put it in this spot right here. And so our end result is something that looks like this, which is exactly what we wanted. So the only thing left to do is to do our file.writeAllLines. And this is a baked into C# method, this file.writeAllLines. It takes in a file name, actually a file full path. So we'll give it the full path, and then an array of lines, or a list of lines. And that's our list of lines. So we've now saved to the team file. In theory, life should be good. Let's find out if it is or not. So we'll pull up our form, I'll also pull over my files here just so we can see that there is no team models file. So let's create a team of second is best. Let's add both Joe Smith and Sue Storm, but not Bob Smith. We will create that team. And now the team models.csv has been created. If we open that with Notepad, I'll pull it over here. We can see that we have the ID of one, second is best, and then that pipe delimited list of IDs for the people. So life is good. It seems to work. And with that, we have completed the create team form. At the beginning, it seemed a little intimidating with all this stuff going on, but we broke it down into sections. This section here, this section here, this section here, then this, and then finally the create team button. So by breaking it down into little chunks, sure, it took us a little bit, but we got the job done, and it wasn't that overwhelming. Once we started getting rolling in our system and the way we're going to do things, it really was just follow the pattern and do the same thing over again and make small little decisions, not big ones. Now that we've handled this form, in our next video, we're going to tackle something a little bigger. We're going to get to the create tournament form. This is the big one because once we have this done, then our system is pretty close to complete. The only thing we'll have left after that is to load which tournaments we have so we can view them and the actual viewer. And those are kind of small. So stick with it. We're getting close. Let's finish strong, get this application at least up and running. And then we're going to come back through and make some improvements and kind of upgrade this with a couple of different fun features that really make the application stand out and be more intuitive. So stick around for that. Welcome to Lesson 15 in the C# from Start to Finish course. My name is Tim Corey, and today we're going to start working on the Create Tournament form. This is the big one. Once we get this form completed, we'll have a mostly working application. The best news is that while this is the most complex of our forms, by now we've already done most of the parts we're going to need. That means we shouldn't encounter too many issues. At least we hope not. So let's jump right in. Whenever I start a form, I like to break down the different chunks that I'm going to do. And so I review what the form does and then figure out what the logical chunks are. And right away in my review, the first thing I notice is these two boxes right here are different, and yet their labels are the same. Now that just means we have a copy-paste error, so I'm going to go ahead and resolve that before we get any further along. I'm going to change this to say prizes. And that just fixes that little issue right there. The actual label is labeled prize label, and the box is prize list box. So we're all good there. It was just the actual text right here for this label. Now as far as the chunks that I'm going to break this up into, it's a little bit different because we're doing it on video versus you doing it yourself. Because here's the chunks if you're doing it yourself. I would populate this select team drop down first, and that'd be one chunk. Then I'd populate this list box right here, and that's another chunk. Then I'd wire up this add team, which takes whoever's in this drop down and puts them in this list box as the next chunk, because that way I can validate that this list is working. And finally I'd wire up this list box. Now, because we're doing this on video, I'm not going to do 6 different videos for this one form. We're going to try and do it in 3. And so therefore we're going to do all of these in one video. So we'll do a drop down, the add team, this list box, this prize box. All of these we're going to do in this first video. The next video, we'll wire up these delete buttons and the create new and the create prize buttons. We'll wire those up as well. make sure they're working. In the final video, we'll concentrate just on this create tournament button. So those are the chunks we're going to do. They're bigger chunks than I'd have you do if you're just doing it on your own, because on your own you can break it down into smaller parts and it makes a little more logical sense. So let's start with this select team dropdown. It's called select team dropdown. So we're going to go to the code for this, hit F7. And here's our code behind for our form. And the first thing I want to do is this is a list of teams. So I want a list of team model. I hit Control dot to add the using statement. Now I'll call this teams, or available team. Let's do available teams. Equals new list of teams. And what that's going to do is it's going to give us all the teams that are in the database, every one of them. And we'll put that in this list. Now, right now I have this as a equals new list of team model. We're going to go ahead and change that to either load the teams from the database or from the text file. So we'll leave it this way for now, just so we have something. And then let's work on getting that read for the team model. So we have the create team, but let's do the list of team model, get team underscore all. So it matches up, get team and create team. Get person all, get team all. So we're kind of matching the same patterns here. This is our new entry in our iData connection, which is our interface or our contract. And now let's implement that. So we'll do our control dot here. And then we'll also do our control dots in our text connector so that both are implemented. We'll come back over to the SQL connector. We'll go find this. So here's our get team all in a SQL connector. So let's first of all copy this code for get person, because it seems to function fairly consistently with what we're doing. I'll change output to be a team model instead of a person model, and we'll have to change the query to get the team model instead. Now, first of all, we need to figure out what store procedure this should be instead of SP people get all. So let's look for the SP team get all. We have an SP team get by tournament, and if we modify this to look at it, we can see that we get everything from a team and we join on the tournament entries so that we know, okay, it's this specific tournament. Well, we're not asking for a specific tournament yet. We're creating a tournament. So this isn't quite right. So we're not going to use that. Instead, we're going to create a stored procedure. We'll get rid of this stuff up top. And we'll say the name is going to be, we're going to follow the same convention. So DBO SP team underscore get all. We will have no parameters because we're getting all the teams. And for our select statement, be very simple. Select star from dbo.teams. All right, we'll put our semicolon at the end. And that's our store procedure. Very, very simple. Now, if we run this, just the select statement, we have right now one team, ID of one, and a team name of team first place. So we have one team in there. So let's create that store procedure. And we'll take that name. We're going to paste it here. And now we have a populated team model list, correct? Well, no, actually we don't. If we look at the team model, we see that we have ID, the team name, those are the things we got from the database, but then we have this list of person model called team members. We didn't get that from that SQL table. So how are we going to fill that? Well, remember that we have this other table in SQL. We have this table called team members. And if we look at this, let's select the top 1,000 rows. We see team ID of 1 for both of these. I'll zoom in here. And then the person ID is 1 and 2. So we have this linking tool that says, okay, here are the entries for this particular team. So we need to get team members get by team. So this looks like it's probably what we need. This SP team members get by team, we pass in the team ID and get back a list of people. And that sounds correct. So we need to call this store procedure. And we pass in @team ID. And how we do that over here? Well, we're going to have to loop through and call this for every team that we just downloaded. Because if we have 8 teams, each one of them needs to have that call by team ID to find out which people are a part of that team. So therefore, we're going to do a for each. For each team model, team in output. So the output right now is team model, but it doesn't have anything for that team members list. And so for each one, we're going to say team members equals connection.query, and this is a list of person model, dbo dot, there's our store procedure name, to list. And now what this does is for each team in our list of teams, we're going to query the team members list. Now, if you look at the store procedure, we're not actually returning just that, this right here. We're not returning this, just IDs, essentially. Instead, with the joins, we are returning the people. So, ID, first name, last name, email address, and cell phone number. They're people records. Therefore, we can do it right here. We can return a person model, which is ideal because we have a list of person model for the team members. So each team, we're going to run this query, and the results will get put in the team members list. Now, our output is not only our team name and ID, but also all the team members fully populated. So now get team underscore all should be correct. So now over here in the code behind for our create tournament form, instead of saying equals new list of team model, we can say global config, and we'll add the using statement there, dot connection dot get team all. Now we'll get all the teams and put them in this list of team model. Next, we need to hook up our dropdown to this list. So let's create a private void initialize lists. We're going to say in here that our lists, which we called select team dropdown dot data source equals available teams, and selected team dropdown dot display member equals, and we need to pick a display member to show. So let's look at the team model. And if you didn't notice what I did before, or didn't realize what I was doing, if you click on an object like team model and hit F12, it finds that definition. So it goes right to team model. It puts it over here as a not quite open tab. It's more of a preview tab. You can say keep it open, and then it'll make it a real tab. Otherwise, this will change based upon where you need to go. So I need to pick one property to identify this team model. In this case, it's pretty simple. Team name seems to indicate exactly who we're talking about. So I'm going to copy that. And then here inside my double quotes for display member, I'm going to paste it. That way my casing is perfect and I know that's not an issue. Now before we go any further, let's go ahead and check to make sure this part of it is working. So let's come down here to our program.cs, make sure we change this from text file back to SQL. And then we also need to change, instead of create team form, we're now on the create tournament form. If we run this, we're going to get this error. And you go, oh no, we messed something up. Well, yeah, kind of we did, but don't panic. Read the information. So additional information, which in the newer versions of Visual Studio, they fixed this so that this is much more clean and it puts the real information up top. But in this case, the real information is under additional information. And it says procedure or function sp team members underscore get by team expects the parameter at team ID, which was not supplied. Well, that kind of makes sense, doesn't it? We didn't pass in the team ID, therefore we don't know which team to look up. So let's stop that. And we need to create a dynamic parameter list. So let's grab, we're just going to copy it from up here so we have the same pattern. And then we're going to say down here, let's just put it right in here. And we're going to say, instead of model dot, this is at, let's check to make sure, it's called at team ID. So I'm going to copy that. This is at team ID, and it's not model. We're inside a loop, so it's team dot ID. So we pass that in by doing comma P. All right, and that should be all we need. Let's start again and see what happens. Nope. It says procedure or function expects a parameter at team ID, which was not supplied. Well, we passed in the P, so why is this not working? And this, again, is not the time to panic. It's time to just look at, well, what's going on here? In here, we said P, and then we gave the command type, which we didn't do down here. So let's just do that and pass it in, and this time it runs. Okay, so we needed that command type of store procedure to tell it that it's a store procedure. Now in the team list, we have nobody. That doesn't seem quite right, so let's debug this as well. This is one of those things where you get going, you're like, oh, I'm gonna nail this thing, and then this kind of thing, hits. This is natural. This is normal. The way we've been going so far, we've kind of had it too easy. And so now we're starting to see a couple of bugs and errors. And that's a good thing because it helps us debug what's going on. And those debugging skills are really important because you're going to need them every day. So in this case, I'm going to find out if I'm actually even getting teams. So I am putting my breakpoint right after I get all the teams. So I'm going to put it right there. I'm going to start. And now it's already at the breakpoint. Notice the yellow highlight to say we're at the start of the for each. So let's mouse over output. And if you can see, output says it has one record. It has an ID of 1 and a team name of team first place. And no team members, which is great. That's perfect because we load those down here. So let's step into this for each. And before we start going any further, let's look at the team to make sure it is the correct team. ID of 1, team first place for the name. So yes, that's correct. We're going to add our team ID, which is 1. We're going to call and ask for a person model back. We're going to call this method. And we get back the team ID of 1, team first place, now has 2 team members. The second person, is Sue Storm, and the first person is Tim Corey. So that's right. So let's keep stepping through. It's going to return output. That's good. And now I've stepped into an area that I didn't really need to. This is the other half of the class. Notice the create tournament form. This is the, we have a partial class in 2 different spots. And so this is the other half of that partial class. I'm going to step out up here, which brings me back to this creation. I can keep going. And it's actually taking me too far. I shouldn't have stepped out because it treats the partial class like it's a whole class and doesn't know one from the other. So I'm going to stop it again. And this time I'm going to go to my create tournament form and put my breakpoint at the end of the constructor. I'm going to take a breakpoint out of this for each loop and start again. And now I'm here at the end of my constructor. My available teams is 1, team first place, ID of 1, and it has 2 people in the list, Sue Storm and Tim Corey. So my team list is correct. So why is it that my dropdown is empty? Now hopefully this doesn't take you too long, but don't panic if it does. It's one of those things where when you stare at something too long, it actually makes the problem worse, not better. And so if you ever get stuck in a point like this, one of the things I encourage is that you step away for 5 minutes and do something totally different. I play a game on my iPhone. I just pull the iPhone out, play a game. It gets my mind off of what I'm doing, which actually helps me solve the problem. I'll come back and it'll be obvious. I'll go, oh, that's what I did. In this case, the obvious is I didn't actually call this method. If you don't call the list or initialize list method, then it never initializes the data source and wires everything up. Therefore, nothing in the list. Now, team first place is in that list. So, step 1 is done. It's a little rocky. We had a little bit of an issue, but we are back on track, and we got some valuable debugging steps in along the way, and we realized that we have to make sure that we follow through on every step we're doing. When I was done here, I said, oh, I'm done. And I didn't review how this fits in with the rest of the application. Now let's tackle the next chunk. I'm going to close out everything else. So close all but this, just to kind of clear my plate. I'll probably have to repopulate it with all those tabs, but I want to at least start fresh for now. Now, the next logical step you might think is to add the team. Because we've already started working on teams, let's complete that. But, and here's the issue, we don't have anything to add to yet. There's no place for it to go. So therefore, we need to come out over to here and populate this list box. Tournament players list box. So we'll hit F7 to go to our code. we're going to say list of team model selected teams equals new list of team model. The reason it's a new list of team model is because we don't have any teams selected by default. Now, if you're thinking, man, this feels familiar. It feels like we've done this before. We have. Create team form. Select a team member, that's a person, add them to the selected person list box. So it's the same pattern as over here. It's just now with teams here versus people in the previous form. So it should feel kind of familiar, and it should follow the same basic pattern. So in the same way, we have our tournament players. Let's change that name too while we're here. It's really not tournament players, it's tournament teams. We have over here a select team dropdown. So we should have tournament teams list. That's a little more consistent with what we're doing here. So we have tournament teams list box. So down here in the initialized lists, we can say tournament teams list box dot data source equals selected teams. Tournament team list box dot display member equals, and I copy from up here, team name, and paste it down here. Because these both hold a list of team model, and so their display member should be the same for both of them. And that's really it for wiring up this list box. There's nothing more to do because there is no list. So it's not like we can say, oh, yep, we're working, although we could put some dummy data in there just to be sure. But I think we're okay seeing how we only have to write 3 lines of code. I think we're okay for now. And because that was so easy, let's look at the prizes list box. That would seem like we'd have a list of prize model selected prizes equals new list of prize model. And then down here, prizes list box dot data source equals selected prizes, and then prizes list box dot display member equals that string. Let's go over to the prize model and look at the prize identifier. I would think probably place name is going to be good, although we might want to have some type of property that combines 2 or more. But for now, I think place name is good. So let's just copy this. Let's grab place name and then paste it into our quotes. And now, with that little bit of code, we've wired up these 2 list boxes. Now that they're wired up, we can come back over here and work on this button. This button's job is to take the value from here and move it over into here. So I'm going to double click to create the event. And then before I go any further, just because I know I've already done this once with the create team form, I want to see what I did to the add member button. Just to see the pattern so I know, yep, that's what I want to do. And in fact, I might even copy this code and paste it over into here and comment it out. That way I can kind of follow the same pattern for 2 reasons. One, it keeps my code consistent. That way you don't see things done 2 or 3 different ways depending on which form you're in. And 2, it helps make sure that since I have a system that works, that I use that same system, which reduces the amount of errors I have in my code. So the first thing I did was I converted my drop-down value, the selected item, to the type. So in this case, I'm going to say team model T equals team model in parens, select team dropdown dot selected item. So that takes the selected person, or I'm sorry, team in the dropdown, converts it back over to a team model. Since they all are team models, that's not a problem. If they weren't, it would blow up. So now I've done that, I can say if T does not equal null, we can say available teams dot remove that team. So it's not available anymore because selected teams dot add T. So it's not available anymore because it's now in the selected list. And the final thing we did was we call the wire up lists. We don't have that. Or do we? Well, we kind of do. We call it initialize lists. So let's go ahead and change that so it matches, so the pattern stays the same. But there's one more thing that we did here. In this wire up lists, we first assigned the data sources to be null. Remember that reset our list and allowed us to rebind. And so let's do that here. I'm actually going to copy and paste. And just make sure that you do copy each time, otherwise you'll copy the previous, or you'll paste the previous one. And that wouldn't work. Okay, so now we're going to call the wire up lists to make sure that our lists have been updated. I can get rid of this comment. And now let's run this again. We only have one team, but if we add team, it moves out of here and into here. Perfect. That's exactly what we wanted. And believe it or not, the first 4 chunks of this form are done. We wired up this selected team list so it populates with all the available teams. We wired up the teams and players selected box as well as the prizes selected box. And we wired this button up that takes a person from the available list and moves them to the selected list. So that's it. That's all we had to do in this first video. 4 small chunks. And those chunks were really fairly easy. We had a couple of glitches, but they're fairly easy. And we're really quite a ways towards getting this whole form done. In the next video, we're going to wire up this create prize button. Remember, we already have the form that creates the prize, but we somehow have to call that form, get the data back, and put it in this list. Because create prize works a little bit differently in that we don't have a drop down of available prizes. We decided back in our planning stage that we weren't going to do that because we figured that prizes were pretty much specific to the tournament and wouldn't be reused. So we'll create prizes specifically for this tournament. So we'll wire this up to that form and get the data back and put it over here. We'll also wire up this right here, this button. It'll be a similar mechanism as this create prize button in that it will call that other form we just did that creates a team. And then when it comes back with a filled out team, it's going to put that team in this list. And finally, we'll wire up these 2 buttons to remove people, or remove teams and remove prizes, respectively. So that's kind of a bigger chunk, it seems like, but in a lot of ways, most of it's already done. Welcome to Lesson 16 in the C# from Start to Finish course. My name is Tim Corey, and today we're going to continue working on the Create Tournament form. In the previous video, we started working the form by wiring up the lists in the dropdown. Now we get to connect our create forms to the create tournament form. Here we have our create prize button, and we have our create new, it looks like a link here, but that does the same thing only for a team instead of a prize. So these two are the first we're going to wire up, and this may seem a little intimidating because we're going to call a different form and have it talk back to us. And how you do that. And this is one of those areas where people often get it wrong, in my opinion. And that's by tying this form, the create tournament form, directly to the form we need to call. For example, the create prize form. The create prize form shouldn't know about this create tournament form. And that's where it gets a little tricky, a little bit, you have to think a little more about it before you just do something. Because there's ways to get it done, and then there's ways to get it done right. And so we're going to try and get it done right. So let's start with the create prize button. So in here, let's just list out the steps. We need to call the create prize form. All right. Next, we need to get back from the form a prize model. That's the tricky part. And then finally, we need to take that prize model and put it into our list of selected prizes. And that's the easy part. So let's start off with an easy part. Let's call the create prize form. And so these notes right here are great. They're one-liners. So I can then put code right underneath them. And then this line describes what this code down here does. So it starts off as notes of what I should do, and it ends up as notes of what I am doing for each of these sections. So to call a form, we do create prize form. Let's just call it FRM equals new prize form because it's a class, and so we have to instantiate it. So create prize form. And then it's just frm.show. And that's it. And now that form will pop up whenever we click our button. Let's just check that to make sure. If we click the button for create prize, up pops the create prize form. So that at least works. So now, how do we get it so that when that form does pop up, we fill the form in that it actually puts the prize into this list over here? So we need to pass back our prize model. And that's where the question is going to come in. So first, let's look at our prize form and just verify that when we create this prize button click, that we have a prize model that we've created, and we do. Now we haven't passed it back to itself, so let's do that. That way it has the ID back in it. So now we have the fully completed model with ID, but now what? Well, actually, before I get there, I want to point out one thing. This is actually not necessary to do. I often forget about that and just do it, but the reality is that this is, again, the address to our house. So it says, 123 Sesame Street. That's where this house lives. So in this create prize, if we look at that, I can't go directly to it because it's an iData connection. So let's go to the SQL connector and look at the create prize. If we look here, we see that the model we take in, we then add in the ID property this value. That means that without doing anything else, we've modified this model. Therefore, we don't need to take this return value and do anything with it because we've already got it. So it is one of those things that I often forget about it. I forget that we're passing around essentially reference types, or not quite reference types, but the address. We're passing the address around, not the actual house. So that's just something to keep in mind before we continue. But we have this model. It's now fully complete. So when we create the prize button, the next thing we want to do is send that prize model back to the caller and say, okay, here is the value, and we're done. So we're complete. So how are we going to do that? And the first way we could think about to do this is, since we have this constructor here, create prize form, we could pass in a prize model. So over here, we could pass in a prize model that we know about in this form, and then add that to our list of selected prizes. And as the user populates it and saves it, the form will just close because it's the same address again, remember, so that when the living room gets filled in the other form, the living room is filled over here because it's the same house. They're both using the same address. The problem with that is, what happens if I say, oops, I made a mistake, I don't want to create a prize? Well, then we have this weird prize with nothing in it in our list of selected prizes. And that's just not going to work. Now, the next idea is the one that people often do. And that's the idea that we can pass in the instance of this create tournaments form to our create prize form, pass this whole instance in, and then have a public method that's something like save prize or something like that. Well, what that means then is, in our create prize form, in the constructor, we have to say create tournament form. And so it has to be tied to the create tournament form, and no other form can then create a prize. And that doesn't seem like it's a great idea. I mean, maybe right now we don't have any other location that might want to do that, but we might in the future. And especially if you're in a organization where you have a large application, you definitely don't want to lock your forms down to being so tightly coupled to each other. It's called tight coupling. And so instead you want loose coupling, the idea that they don't really know about each other, but they can work with each other. And so that's what you want, is some kind of loose coupling. So what we're going to do is, in our Tracker UI project, we're actually going to create an interface. So right-click on Tracker UI and say Add, New Item, Interface, and let's call this the iPrize Requester. Okay, remember we call it I at the beginning for interface. Make the interface public. And this is going to have just one method in it. And it's going to be a void, meaning it returns nothing. Team complete. Oops, not team complete. Prize complete. And it's going to pass in the prize model. Add the using statement for that. Model. So what does this interface do? Well, it says whoever implements this contract will have one method called prize complete that returns nothing, but that takes in a prize model. How is this helpful? Well, check this out. If I take this interface, come over to the create prize form, and say you have to pass in, let's call it caller, iPrize Requester caller. So now it's saying someone's going to call you. We don't know who, but they will have this contract. So pass it in as caller, and then up here we're going to say iPrize Requester calling form, and then in our after initialize components, we can say calling form equals caller. So what that does is it creates a variable at the class level that stores whatever's passed in to our constructor. And why is this valuable? Well, we need to know this outside of this scope. So right now, caller is only available inside the constructor scope. But now you want to have it available in this create prize button underscore click event. Because what we're going to say is calling form dot, and notice here we have the for standard from Microsoft equals get hash code, get type, and toString. We also have this method called prize complete. And it takes in a prize model. We have a prize model called model. And with that, we have called our parent, whoever called us, we've called them and said, I'm done, and here's that model you asked for, the fully completed model. And this model will only be created if it's a valid form and they said, yes, I want to create that prize. Now we can actually get rid of these. I'll comment them out for now because we're actually going to then close our form. This dot close, which will close this current prize form because we're done. We have said, yep, we're complete, and here is the completed value you asked for. So now we can come over to our create tournament form, and we have an error. Create prize form FRM equals new create prize form. Nope, we need to pass in iPrize requester. Well, we don't have one of those. Or do we? Nope, we don't. But we can say iPrize requester. This class is going to be our iPrize requester. This class being our create tournament form. We just need a control dot here and implement that interface. And now we can pass in this. Now what is this? Well, the this keyword represents this specific instance. Meaning, inside of our fully built house, we can say, I know who we are. I know where we are. And so basically we look outside the front door, we read off of the mailbox our address and hand it to you and say, this is where we're at. So this represents this specific instance. This instance being a create tournament form class, but more importantly for the create prize form, we're also an iPrize requester contract fulfiller. We said, yes, we'll fulfill the iPrize requester contract. Therefore, we can pass that into this create prize form just fine. Now, does that mean we're locked into then only this form can call create prize? No. Anything. It doesn't even have to be a form. Anything can call this create prize form as long as they implement the iPrize requester. Now we're loosely coupled. The prize form doesn't really know who we are. It just knows that we implement the interface. Now the create tournament form knows about the prize form because it has to know that specific instance to call. And that's okay. So now we have to actually implement this interface. So what happens when the prize is complete? Well, that's actually these two right here. So let's cut them out of here. And now really, the create prize button just opens up the form. And here is where the magic happens. Actually, this step is already complete. The get back from the form a prize model, that's right here. So now we just need to take that model and add it to our list. Selected prizes.add model. And the final step is then to wire up the lists again, because our list has changed. and you want to see that. Now that should be everything we need to do. Let's find out if it actually works. We're going to run this. And we're going to say create prize. And that pops up our form. Let's call this prize. The place number is for 4th place, and the place name is almost bronze. The prize amount is $5. Create prize. It went away, and we have now a prize in the list called almost bronze. So that's it. We've actually accomplished our mission of wiring up this button. It really wasn't that hard. We just had to know the steps to do. And now that we know the steps to do, we can do this one much easier, much more quickly, because it's the same process. So this time, let's do it in a little different order. Since we know we need that interface, let's right-click on our our project, and say Add New Item, Interface, and we'll call this iTeam Requester. We'll make it public. We'll add that one method to it, void team complete, team model, control dot, add the using statement. And now our interface is complete. We'll copy that and save it. And now in our create tournament form, we need to add that interface as well. And we'll control dot to implement it. Now notice that this class inherits from form. And you can only inherit from one thing. But inheritance means it brings with it the methods and properties and other public items from that form class. But then it also implements not one, but 2 different interfaces. And you can implement as many interfaces as you want, because an interface doesn't actually bring in code. It just is a contract. And it says you will fulfill this contract. You can have extra stuff. And boy, do we. We have lots of extra stuff. And that's okay. We just need to at least have the items that we said we would when we said this contract is attached to this class. So we implemented iTeam Requester, but let's go down and actually wire it up. Okay, that's pretty easy. Selected teams.add model and wire up lists. And that's it. So now this is wired up. So we can come back over here to our design, double click on the create new, to the link clicked. Notice it's a link clicked versus the click, and that's because this is a link versus a button. A little bit different, but the default event is what we wanted, so that's good. So we need to do a create teams form, FRM equals new create teams form. We're going to pass in this. Now it doesn't take that yet, and that's okay. FRM.show. So the last thing we need to do is modify our create team form to take in our interface. Caller. And we will say private iTeam requester calling form. And then after initialize components, we will say calling form equals caller. So now the create team form at least knows who to call when we've completed a team. So now you can come down here to the button that actually creates the team. And if you're not sure which one it is, now it says create team button underscore click. You could open up the form, double click on the button, and it will take you to that event. As a to-do here, if we aren't closing this form after creation, reset the form. We can actually take that out because we are closing the form. And also we can take out this t equals. We don't need it. And instead we can say we need to call the calling form dot team complete t, and then this dot close. So we called the parent and said, yep, we're done. And then we also close this form. And now if we run this, we should be able to add a team as well as adding a prize. So we have one team here, team first place. Let's add them. And now we can create a new team. And it brings up this box right here. Let's call this place the Uncanny Losers. And we only have 2 people. Let's add a member. Oops, let's remove a member. Let's add a new person. Joe Smith, Joe and Smithy.com, 555-1111. And then his brother Billy Smith, Bill at Smithy.com, 555-2222. So now we have a new team called the Uncanny Losers with Joe Smith and Billy Smith. We create that team, and there they are, Uncanny Losers. So it looks like everything is wired up the way it should be. Now we just need to wire up these delete selected. And actually, I believe the other one said remove selected. Let's check that out. The create team says remove selected. Let's keep that same syntax. So, and let's get rid of all these pins that I don't need. Let's close all documents. And open up this one. All right, so let's change this. Go to properties. And instead of delete selected, we're going to say remove. And we'll come down here and also change this language to say remove. And do the same thing down here. Change both the name and the text to say remove. And then let's double click on this one right here. And now we need to remove one from the list. Again, we've done this before. So let's go to our create team form, open it up, double click on remove selected. And here we have the remove selected member button. I'm going to copy this. I'm going to close it out. And I'm going to close out this as well. Oops, not this one. This one. And over here, I'm going to paste this in and comment it out. Again, this just gives me a pattern, so I know that, yep, I'm doing this right. And so we first need to grab the selected player or team. So team model, T equals team model in parens, team members list box. Nope, that's not it. What's it called? It's called tournament teams list box. Tournament teams list box dot selected item. So we've taken a selected item, cast it to team model, it's a team, and then put that into our variable. And said if T is not equal to null, selected teams dot remove T, available teams dot add T, and then wire up lists. So it really is almost exactly the same as here. It's just a little bit different in how we do it. So in this case, we have tournament teams list box and selected teams and available teams. So that's how we do the remove a selected team or player from this box. Now for the prize, and I'll do both in the same shot since they're pretty similar. I'm going to say prize model P equals prize model prize list box, prize as list box dot selected item if P does not equal null, selected prizes dot remove P, and available, we don't have an available prizes. So we can take it out of the list, but here is the one rub, the one issue, and that is if we take it out of this list and we have nowhere to put it because we're not storing those. Remember, these are specific to the tournament and we're not going to worry about reusing them for different tournaments. So if we take it out of this list box, we're really saying we don't want it. Get rid of it. Now here's where a debate's going to come in. Because if we get rid of it here, we should probably delete it. As in remove it from the database, remove it from our text file, everything. But that raises the question, database is fine because the database keeps track of which IDs it has used and it makes sure that it doesn't reuse them. But what if, instead of this being the create tournament form, what if you're modifying a tournament? And we said, I don't want those prizes, remove them, and they get deleted. And then we say, oh, never mind, I'm not going to save this. Well, it's kind of too late. Those prizes have been deleted. Whereas if we didn't save it and we also didn't delete those prizes, then those prizes would still be there and nothing would have changed. So that could be an issue. It's definitely an issue with a text file because if we create a prize, that gets an ID of 1, we create 3 more, they get IDs of 2, 3, and 4, but then we delete those prizes. So we delete 2, 3, and 4. Now we're going to add a new prize. It's going to get an ID of 2, not 5, because it doesn't see that the max ID is actually supposed to be 5. There's nothing to tell it that. So that could be an issue if we remove something but then didn't really save the record or had some other kind of issue. And so in this case, I'm thinking that even though we may create prizes and then disconnect them from everything and they kind of sit there, I think we should leave them where they're at and just not delete them. And so that's something you're going to weigh. But if you want to say, no, you know what, I'm going to delete it, then all you do is put that in the code right below this line. But for us, this line does all we need to do. We're not going to save anything. We're not going to save a delete or perform a delete. So now let's test to make sure this form works the way it's supposed to. Let's add a team. Let's actually add 2 teams. Notice Uncanny Losers has been saved. Let's create a prize. Prize, the place number is, let's make it a 1 and say first winner, which makes no sense, but that's okay. $100. Create the prize. Now let's test removing. Let's remove Uncanny Losers. They go out of this list and back into this list. Let's remove the first winner. And nothing happens. And the reason why is because we didn't actually put that wire up lists after this item right here because we got distracted. And that's why it's always good to follow a pattern because it's very easy to see what you have and have not done. So let's just test this again. Always test it again, even though you're fairly certain it's going to work. We will create the prize. Create a prize for 10, 10th place, $1. Create that prize. 10th place is in the list. Remove selected. Now nothing is in the list. Perfect. That's exactly what we wanted. And that wraps up all the pieces that we needed to do today. We wired up the create new link and the create prize button. Both of those add to the respective list boxes. And we also wired up the remove selected for both the team and players box and also the prizes box. Now, before we wrap up for today, there's one thing that you may have noticed, and some of you may be going crazy thinking that we've already broken our application. And that's because in the last video, we wired up the selected team, the list box for the teams, and also the prizes. And we implemented everything in SQL. But we didn't implement anything in the text files. So that was an oversight, and that's one of those things where we use that not implement exception to our benefit in the fact we could compile for SQL, but we never actually tested it by switching over to type text file. And if we did that, we'd get that error throw new not implement exception. Now the good news is that no matter how far down the road we got, if we try to switch over a text, we'd get that error. So we'd know that yes, we've got a problem. So let's go ahead and actually, in this video, finish off this get team underscore all entry. And if we look up here to our create team, we see a list of team model called teams, teamfile.fullfilepath.loadfile.convert to team models. That is the code we need. We copy it, we paste it, we return it. Because this returns a list of team model, which is exactly what we need. Let's make sure that works. We'll run this, no crash, and now we have no teams. So let's create a new team. And we'll say the team name is, let's call it the best team. We'll add Joe Smith and Sue Storm. And we'll create that team. And we have the best team now in our list. We can also remove the selected. And it's now in our dropdown. Let's close this out. Start it up again. And notice that our dropdown is empty. So we have some kind of issue going on, but we're not quite sure what yet. So let's do a little bit of diagnostic work as to why this isn't getting us what we need. So let's put our breakpoint on this line and run again. And this time we break in this line, we're going to step into our code. So first we get the full file path. Then we load the file. Notice here's the file name. It reads all the lines. Then we convert to team model. And notice here's all the lines of our file. It says one line. It says ID of 1. It's called the best team with person number 1 and number 2 in the list. Great. So now we create our output model, which is empty. That's perfect. We load our people model. Let's step back out of that and step over that code. And that gives us our list of people. And we have Bob Smith, Sue Storm, and Joe Smith. Notice IDs 1 and 2 were Joe Smith and Sue Storm. So for each line in lines. We only have one line, so we'll do this once. We're going to split on the comma, and now we have 3 columns. And those columns are 1, the best team, and that one pipe 2. So now we parse that int for ID. The ID is 1. The team name is the best team. That's fine. We take calls 2, which is our 1 pipe 2. We split it based on the pipe. And now we have 2 person IDs, a 1 and a 2. And we say for each string ID in person IDs, and we're going to say ID parse, and we're going to say people, where x.id, that's the ID of each individual item, so 1, 2, and 3, equals the parsed value of ID, which is 1. Take the first one, add that to our team members. Let's skip over that and look at our team members. We have 1. And that first person is Joe Smith, ID of 1. That's great. And I'm going to step over this again. And what step over does is it kind of skips going into anything in this line, and instead just continues on to the next line in this file. So now team members is 2. That's great. I don't have any more people. I don't have more lines. So I return our output, which is 0. Well, that doesn't seem right. Why is output 0? Well, if we look, we created this team model T, we populated it, but we never said output.add T. There's our problem. So, that's what stepping through the code does, is it shows you where your problems are, because you start seeing unexpected results. And that's where you start looking even heavier at what's going on. Now if we run this, it should be that if we start this, that we can go ahead and take this breakpoint off and just hit continue. Now we have in the dropdown the best team. If we add that team, it goes out of this list. And if we remove it, it goes back into this list. So now we have a working text version as well as our SQL version. All right, so that's a little bit of back work, stuff we forgot and stuff that we needed to work on making right. And that's going to happen. You're not going to get everything perfect the first time. You're not going to remember everything. And especially when you're starting off, you're going to get a lot of bugs because you forgot where you were. And you've even noticed when I've been doing this, I've had a couple bugs where I just forgot to finish what I started. And so that's where I encourage you to write things down or make notes or add to-dos. And especially if you're thinking about things that aren't really on the line you're working on right now. Instead of thinking down those paths, stop, write it down, and get back on the main path. And what I mean by that is I remembered that I hadn't implemented that text side of things. I remember that a while ago. But instead of stopping what I was doing and interrupting that flow, I just made a note of it. And then I didn't have to remember to do that. And that remembering kind of eats up brain power. And so instead I put it on my legal pad and said, do this. And then I can come back to what I'm doing and give it my full concentration because I'm not worrying in the back of my head I'm going to forget something. So that's what I encourage you to do. Write things down, use patterns like I've done. So in the code behind for this, we have these patterns here that I actually copy and pasted from the other form just so I could see the same pattern and do the same pattern. Because doing the same pattern every time makes it easier to spot when you've forgotten something. Like even here, it's kind of obvious to see that this pattern doesn't quite match up to this, in that I have 2 items here and only 1 here. Now it's intentional because we don't have anything to add it to, but at the same time you're going, wait, that might be an issue. And that's great. It's triggered your brain to say, I recognize this pattern and it's a little different. And so I want to make sure that that different is okay. If you didn't have this pattern, you would never look at a line of code and just go, that doesn't look right. So those patterns really help you keep yourself in line. All right, so let's review one more time to make sure we've got everything. We have wired up our dropdown and this link, these 2 buttons, these 2 lists, these 2 buttons, and now we're just waiting to wire up this create tournament button, which takes in the tournament name, the fee, and then the values for these 2 entries and saves it in the database. Now, the cool thing is we're going to do more than just save in the database this next time, because yes, we're going to save this information, but then we actually have to take this information and scaffold out our tournament. Meaning, if we have 4 teams, we have to pick which 2 play each other in each of the 2 first games. And so we have to create that list so that we can start our actual tournament, which is, it's going to be great because we actually see something working. Welcome to Lesson 17 in the C# from Start to Finish course. My name is Tim Corey, and today we're going to mostly finish the Create Tournament form. At this point, we only have the Create Tournament button left to wire up. So why is it we're only going to mostly finish? Well, this part is really 2 different ideas. One is about saving the data to the database. The other is about setting up the matchups for our tournament. I want to break those 2 apart so we don't get confused on what we're going to do where. Now, I don't know about you, but I'm anxious to get this form working, so let's dive right in. Okay, we have our button here, Create Tournament. Let's jump right in and at least create the event by double-clicking. Okay, we have the event. Now, what goes in here? And this is where I do my comments again, just so we have the different steps, and then we can do that step one by one and make sure we've got them all done. Our first step is going to be to actually create the tournament itself, taking the name, the entry fee, and actually creating that record for it. In the database, we have the tournaments table. And if we look at this table, we're going to see we have the tournament name, the entry fee, and if it's active or not. Now, when we create a tournament, it's active. So that we already know that information. So come back over here. Let's say create tournament entry. Now, why is that first? Well, we also have to save the prizes. But if you come look at the table over here for tournament prizes, we'll see we have the tournament ID and the prize ID. Well, a tournament ID comes from creating this record in the tournaments table. Therefore, we need the tournament ID for this, for the prizes. Therefore, the prizes come after we create the tournament. And the same with the entries. The entries, we have tournament ID and team ID, which means that we're going to take everyone in this list, take their ID as well as the tournament ID, and create an entry. So therefore, we can say create all of the prizes entries, and then also create all of the team entries. So those are the 3 jobs we need to do first. And then once all of that is done down here, and this will be for the next video, we need to create our matchups. Now let's take a peek at our tournament model. Our tournament model has the tournament name, the entry fee, the teams entered, the prizes, and the rounds, which that will be once we actually create our matchups. We'll populate that with our rounds. So what it looks like is we can create this model here without the rounds filled in. We can leave that blank. But everything else filled in, and then we can say save that entry and have either the SQL connector or the text file connector save all the information we need in the various tables. So let's do that. Let's first create our tournament model. We can do that right now. That's pretty simple. Tournament model. Let's call this TM equals new tournament model. TM dot, let's start with a tournament name, equals tournament name value dot text. Now TM dot entry fee equals, what do we call this? We call it entry fee. We did entry fee value dot text. Now that's not going to go into entry fee because entry fee is a decimal. So there's a few different things we could do. One we could do is just the easiest is say decimal dot parse this text. Now the only issue there is if the user decided to put something besides a number in that box, it's going to explode. And so that's probably not the best solution. And this isn't an area where I would want the application to crash. Instead, I want the application to not go any further. And that has a key distinction between crashing and not going any further. In this case, what I'm going to do is instead of doing a parse, I'll do a try parse. I'm actually going to take this away from here. And let's for now just put a 0 there just to have a placeholder. I'm actually going to come up here before we even create our tournament model. I'm going to say validate data. I'm going to say decimal fee equals, let's start 0, and then say bool fee acceptable equals decimal.try parse entry fee value dot text comma out fee. Now what this does is it says I'm going to try to convert this value right here, the entry fee value dot text. I'm going to try to convert that to type decimal. If I do, it will send it out through this fee variable. And if I don't, it will send a 0 out to fee, and it will send a false as the result of this method into my Boolean. Now, this isn't the first time I've done this, so let's just move on. We're going to say if fee acceptable, let's actually say not fee acceptable. Again, if you'd rather say fee acceptable double equals false, that's fine too. We can do a, for now, message box.show saying you need to enter a valid entry fee. And then we can also do, we can give it a caption. It says invalid fee. And then we can go on and give it buttons that you want and all the rest. Let's give it a button, message box buttons dot OK. And then after that, the icon will be a error. That's a little more complicated message box than normal. But essentially all we're doing is filling in more values that are normally defaulted. And so the message box buttons.ok is the default value, but that allows me to specify it and make sure that everyone knows. But then I have a caption up at the top of the message box as well as the actual value of the message box. And then this message box icon.error just gives it a different icon. It's that red icon that make sure you know, oops, I did something wrong. So that lets the user know there's a problem, but we still need to do the return. And what this does is it stops this processing at this point, no further. So we know that if you get to this line right here, this is a valid fee. Otherwise, if it was not acceptable, we'd be kicked out. Now we can say tm.entryFee equals fee. Now let's move on to the prizes. Now the prizes are stored in the selected prizes. So we can loop through those and say for each prize model prize in prizes, selected prizes. So for each prize in the selected prizes list, we're going to say tm dot, not get type, prizes dot add prize. We could do that, and that's going to loop through each selected prize and add it to our prizes list. And that would work if we need to modify something in each item, or if you're only selecting certain ones from this list. But since this entire list is the selected prizes, we can make our lives even easier and not even do a for each. tm.prizes equals selected prizes. Because this is a list of prizes, or prize model, and this is a list of prize model. And they could also say tm.entered teams equals selected teams. And now we've populated our tournament model. Now we can actually save it. So, just like before, the first thing we do when we want to save something is we go to iDataConnection. And we're going to say, let's do up here, tournament model, create tournament, and pass in a tournament model. So it follows the same pattern as all the other creates. We're going to pass in one model and get one model back. Now that model coming back will have the ID, which we don't have yet. So let's create that. And in fact, just to make our lives easier, we can copy it from another model, simply enough, because the ID is basically the same thing. It's just a unique identifier for the tournament. All right, so now we have an ID to pass back if we need that ID. Let's save this. And now SQL connector is going to yell at us. We implement the interface by doing Control dot and hitting enter. And now right here we need to create that tournament. Before we do, let's go to text connector and do the same thing and implement that. Let's save that. And now over here in our SQL connector, we can actually put the logic in to save our tournament. Now I can copy the code from up here just so I have the structure of what I'm going to do. Again, we're using the same structure. That way it's similar in how we do things so we can expect certain things and so that certain things pop out when they're wrong. So before we go any further in this though, I'm actually going to comment out everything in here and uncomment it if I need it. Now before we go any further though, we need to actually have some kind of insert statement for each of the three of our tables. So let's create one for tournaments first. So right click on Store Procedures, New, Stored Procedure. We're going to call this, based off the same naming convention before, dbo.sp tournament underscore insert. Now what parameters does it need? Well, let's find out by doing our insert statement first. Insert into dbo.tournaments. And our values are, let's expand out the tournaments and the columns. So we need a tournament name, an entry fee, and we can leave the active out. Actually, we'll have it added, but we won't actually create a parameter for it. Instead, what we'll do is just assume that every time you create a tournament, it's immediately active. So we'll say at tournament name, and that's a nvarchar 200, and at entry fee, and that's of type money. Notice I knew those two by looking at the columns. That's nvarchar 200, that's money. Now we can say values at tournament name, at entry fee, and active is 1. 1 would be true. So there's our procedure for inserting tournaments. I copy that. And here I will actually paste it in. And I have my at tournament name and at entry fee. So at tournament name, and I will copy this and paste it and say entry fee. And the last thing I noticed, because I'm following the same pattern, is that I have that at ID, which is an output, but if you look over here at my procedure, I don't have that. So I need to add at ID int equals 0 output. Now, I can't run create procedure again because I've already created this procedure. So I have to change it to alter. And I run this, and that works. Now, right now it's yelling at me because it says, I don't know what that name is. But that's because my editor window is not caught up to the latest values. IntelliSense has not been refreshed since I ran that create statement. So if I hit Control-Shift-R, that'll refresh after a minute, and now it says, oh, yep, I know what that is. And now if I were to try and change this to create, it would say, you can't do that. There's already one in the system called that. So that allows us to know if we're on the right track or not, but you have to refresh that IntelliSense. Otherwise, it has stale information. So now we have our ID passing out, and that's good. So now I can uncomment this. And it should be mostly good except for this whole model thing. All the information is wrong here. Instead, we have to get the correct value. So I'll Control J on each one of these and pass in the correct values. And now I'm going to do the SP tournaments _ insert. That's right. Grab back the ID. Perfect. But then this for each here, we want to change. So instead of model.team members, we want model.prizes. We'll do prizes first. And we'll say for each prize model PZ. And that will change how we do this insert here. Before we do, let's actually create that insert. So we're going to minimize that. We will create a new procedure. Wipe out all of this. Say again, following conventions, dbo.sp prizes. It's actually tournament prizes. SP tournament prizes _ insert. Again, we can get rid of some of this stuff, a little housekeeping. And then we'll also expand out the tournament prizes column so we know what we're dealing with. And we will say we have the at tournament ID int, at prize ID int, and at ID int equals 0 output. And now we can say insert into dbo.tournament prizes, and the values are tournament ID and prize ID, values at tournament ID at prize ID, and then we need to do a select at ID equals scope identity. And if you remember, we didn't do that over here. Again, patterns. I really should have pulled up a store procedure that I've done before. But again, another alter. I'll run this, and that's good to go. This one, I'll make sure I'm not highlighting this, otherwise it would run just that. And I'll execute that, and that's now created. So tournament ID and prize ID are the two things we're passing in. So we'll paste that here. We have tournament ID and we have prize ID. And we'll actually copy and paste the ID. Now, we already have the ID captured here for the tournament. So therefore, model.id does work for tournament. But then we need the pz.id. That's the prize ID. So each prize in the list will have its ID. We marry that with the tournament ID. Now we know this prize goes to this tournament. We have the output of ID, but we're not actually going to capture that or keep that, I guess you could say. So we'll leave that alone. We'll just not use it. And then we'll do the same pattern for the entry of our teams. So for each team model, tm in model.entered teams. And again, follow the same pattern. I'll copy the whole thing and paste it. Be very careful to change all these parameters. So now let's go over to our SQL and create that insert. So a new store procedure. And we will say the name is dbo.sp tournament entries underscore insert. And we're going to insert at tournament ID, sound familiar? And at team ID int, and at ID int equals 0 output. And now we'll say insert into dbo.tournament entries, tournament ID, team ID, values, at tournament ID, at team ID, and then we'll capture that select at ID equals scope identity. Okay, again, we're going to insert into our table our tournament entries each team linked with the tournament. So that's pretty much the same thing as the prizes. So we'll change this to be tournament entries. We're going to say it's tournament and team ID. And that tm.id is the team ID, so that's good. So now we're going to loop through each entered team and insert a record for them. Now, while at this point we are done as far as saving what we have right now in this model, we're not really done. And here's why. A couple things I want to address first. The first one is the idea of how complicated a method gets before you break it up. Now remember I said that a method does one thing. But how you define that one thing can be a little bit vague. For example, this method does one thing. It creates a tournament, meaning it stores all the information about a tournament into the database. But really that's broken up into multiple subtasks. So for example, we can create a method that replaces all of this and call it save prizes. And we could call this one save entered teams. So there's ways you could break this up into smaller methods, and that would actually make this method a little more readable, which I kind of like. So there is something to be said for making this actually a quarterback method, where all it does is it calls private methods that do one task. Save the tournament, save the tournament prizes, save the entered teams. So that kind of makes sense, and I'm kind of leaning that direction, especially since, really, this create tournament isn't done yet. And why isn't it done? Well, let's look at this model. We have the ID, got it, the name, and entry fee, yep. Entered teams, yep, save those. Prizes, yep, save those. Rounds, haven't touched them. In fact, we're not going to touch them in this video. So the question is, does the save happen now or once we have this rounds list of lists of matchup model, once that's populated? Well, it would seem like it'd make more sense to wait until that's populated before calling this, meaning we're going to have yet more to add to this model down here. So I do think that that would make sense. And so let's actually break this up into smaller private methods. So I'm going to call the first private method, let's call it save tournament. I'm going to take this code right here and replace it with save tournament, passing in the model. I'll actually create that right here so I can see it. Private void save tournament. I'll pass in a tournament model called model, and now I'll paste that code in there. Now the other thing I need to pass in, notice it says I don't know what connection you're using. So we can pass that in as well. We can just actually grab this definition and pass it in. And then we can pass it in here. And now the save tournament does just the actual tournament save. Now passing this connection in is safe because we're still inside this using statement. That's okay. And we don't have a return type here, even though we are updating the model with a new ID. And that's okay, because that new ID gets saved into this model, which again is just an address to a location. And so therefore, since this object also knows about that same instance, that same location on the street, then we don't have to pass data back because we know what that value is. Now you may say to yourself, wait a minute, we do pass back that same model type in other methods, so why don't we do it here? Well, I told you I don't do it here, so why are we doing it over there? Well, because I forget that instances don't have to be passed back and forth. Once they have them in two different locations, you can modify them in either location and they both are updated. I forget that once in a while. And so, yeah, we have code in here that really isn't necessary. Now, it's not hurting anything, but it could be better. And I've got a whole video in this series on refactoring. Now, refactoring does not happen during the process, mostly. Now, we are refactoring here right now because we're doing this method and said, you know what, there's a better way, let's do it right the first time. That's a good thing. But sometimes you look at sections and say, you know, that could be better, but now's not the time. Refactoring is best done when the application is mostly complete. And the reason for that is because sometimes you'll refactor something too early and then refactor it again, and before you know it, you have this complex application that doesn't need to be. I've had people try and debate with me whether to use a string builder versus, string concatenation. And that's one of those things where, yeah, there's times and places where that's valuable, and there's times and places where it's not. I don't worry about it at this phase. I worry about it once my application is running and I see how it's actually used. Because sometimes you can over-optimize something too early and actually make a slower application. So we're not going to over-optimize. We're not going to refactor continually. We'll do a lot of that stuff at the end in order to make our application a little better. Right now, we're concentrating on getting it done and getting it working. Okay, so we have this save tournament method. I'm actually going to copy the signature here. I'm going to paste it and create a new one, and this one is going to be save tournament prizes. And instead of tournament model, we're going to pass in, actually we'll pass in the tournament model again, because we need both the ID of the tournament as well as each prize ID. So let's grab this for each section and paste it into its method. And again, grab a signature of one of these, paste it, and now instead of save tournament, it's going to save tournament entries. And we will cut this and paste it in down below. Now notice that in each of these, except for the first one, we have this P is not existing in the current context. That's because the first time we do it, we said var P. And since we now have separate contexts for each of these, we have to do var P for each of them. So now we have three methods. We can say save tournament prizes, and save tournament entries. And now our create tournament method is a lot simpler to read through. We can see that it saves the tournament, then it saves the prizes, then it saves the entries. And then each method just does one thing. This one just saves the tournament, whereas the next one just saves the prizes, and the next one, the entries. So now we've kind of refactored this a little bit as we're doing it to make this a little more readable and a little bit more streamlined in how it works. So we're going to save all of that and now come back to our code behind and see that really we are done. We've created the tournament entry, we've created all the prize entries, and we've created all of our team entries. And that was all done by calling just this one method, global config dot connection dot create tournament TM. Done. Now we do have a bit of an ordering issue in the fact that we do need to do our matchups before we actually save this tournament, since it doesn't really make sense to call the create tournament twice. So we're going to have to actually move this up in the process and work on doing this somewhere up here. And that's where we'll actually wire up our matchups. We're going to lay out who plays who when. So we'll do that first and then actually save this tournament entry. Now I could have done this in the opposite order and first create our matchups and then worked on the save, But I kind of want to go over the save first, since we're confident in how that works and we know how to wire that up. Because this wire up matchups, or actually set up how the matchups work, is going to get into some kind of new territory. And so I wanted to take a separate video to kind of walk through that and make sure we're comfortable with how that's going to work. So that's all we're going to do for the SQL side of things today. We're not actually even going to test it, which makes me twitch a little bit, but I think it's important that we have our matchups in there before we test something, so we can test the entire process start to finish. Now we're not quite done yet. We can't forget about the text connector. And the text connector has the create tournament. We need to actually create our tournament. But this is a bit interesting because with every other create, like the create team, we actually saved to the team file. So every model has its own file. So therefore, when we come up here, we should say private const, if I spell private right, private const string tournament file equals tournament model models.csv. Try to get all of my singular and plurals correct. So tournament models.csv. So that's our file, the tournament file. But if we follow a pattern, the first thing we do is load the file and convert to our model. So it's a list of tournament model tournaments equals, let me say tournament file dot full file path. That still works. We have that. Load file, that works as well because that loads to a list of string. And this is the one we need to create. Convert to tournament models. So we need to convert this list to our tournament models. So let's create this. We'll copy this. Go to our text connector processor. And under convert to team models, we're going to create the same thing. Public static list of tournament model this time. Convert to tournament models. This list of string lines. Now this one passes in a string people file name because it has to load the people in order to process the teams. Well, we'll need to do that too at some point, but first we need to figure out what our layout is going to look like. Now this is going to be a bit more complicated. So here's what we're going to do. I'm actually going to open up the tournament model by hitting F12. I'm going to say that I want that to be a new horizontal tab group. So now I have down here my tournament model. I'm going to actually collapse down to definition. So outlining, collapse to definition. That gets rid of the multi-line comments and kind of crunches them down a bit. So I want to see as much as possible down here. But up here in my convert to tournament models method, I'm going to do the same thing I did up here, where I kind of map out how the file looks. So let's start off with the ID, comma, tournament name, comma, entry fee, comma. Now here's our first snag. We have a list of team model. So what are we going to do with this? Well, let's make this, it's going to look like a series of IDs. Gonna put this inside of parens just so it makes it a little simpler. The parens aren't actually in our file. But ID, pipe ID, pipe ID, and this would be our entered teams. So We have our ID, our tournament ID, our entry fee, and then we have a series of piped IDs separated by pipes, that represents our entered teams. Then we have a comma. Then we'll do the same thing for prize model. So ID, pipe ID, which is prizes. And then the really fun one. What does rounds look like? Well, I'll actually start and reverse this and say rounds and dash just so we can see it first and then kind of take in how this is going to work. Rounds is a list of matchup model. That means that for every entry in this list, the entry is a list of matchup model. So it could be 1, it could be 5, it could be 10 matchups as one entry in this list. The next entry is another list of matchup model, and so on and so forth. So we have a 2-layer deep array or set of data. So we can't just do this because that's only 1 layer deep. We need to go deeper. Therefore, we're going to say that we're going to have ID, and instead of pipe, we'll have to have a different character to separate. Which character? It really doesn't matter too much as long as you know what that character is and it won't be used in some way. I'm going to use the caret. So ID, caret, ID, caret, ID. That is one list of matchup model. Then I'm going to have a pipe, and then I'm going to have another set, and then a pipe, and then another set. That's what the data is going to look like. This represents one list of matchup model. This represents one list of matchup model. And this represents one list of matchup model. And then combined with pipe separated, these represent the list of matchup model. Hopefully I didn't lose you there. It's a little bit deeper than normal. We're doing a list of a list. But remember that each round we're going to have matchups, and then the next round is all the winners from the previous round get matched up again, and this time they are battling against each other, and then the next round is the winners from the previous round. So we'll have, say 8 in here in this first set, and then we'll have 4 in the next set, and then we'll have 2 in the next set, and so on. So that being said, we need to create this and actually break it apart from our text file. This is what the text file is going to look like. And now we need to break that apart and rehydrate a tournament model for every line. So we're going to follow, we can close out this now so we have back our full screen. So you follow the same pattern where we create, first of all, our list of tournament model called output equals new list of tournament model. And that's what we're going to return. And now what we need to do is do our for each. So I'll say for each string line in lines. Again, this will just follow the same pattern. We'll first split by comma, because comma is the main separator for our file. We'll call that calls for columns. Then we're going to say we need to create a new model, a new tournament model. So tournament model T equals new tournament model. Let's actually call it TM to be consistent with what we've done before. TM. Then we say tm.id equals int.parse calls 0. And then tm.tournament name equals calls 1. This is the simple stuff. We'll get this out of the way first. Next is the entry fee. tm.entry fee equals, and this is a type decimal, if we mouse over it. So decimal.parse calls to. So those are the easy ones. Now we need to get into the entered teams. Now, how do we do that? Well, we're going to need to split this line apart by the pipe, just like we did here. I'm actually going to copy this and paste it down below, but instead of person IDs, it's team IDs. And I didn't copy the essence string. So now you've split column 3 on the team IDs. And if you get confused as to which column is which, I recommend that you create a cheat sheet. ID equals 0. Tournament name equals 1. Entry fee equals 2. Entered teams equals 3. Prizes equals 4. And rounds equals 5. That way we know at a glance, okay, ID comes from 0, entry fee comes from 2, and entered teams comes from 3. Just so we're assured of what's going on. Now, just like above, we're going to do a for each on this team ID. For each string ID in team IDs. So for each string in team IDs, we're going to do what? Well, this is where we did a lookup based upon up here we had on people. So let's do the same thing, only with teams. We have to load our list of teams and then find the team based upon the ID. So we'll need to pass in the team file. And we'll have to capture that here, just like up here. So we will say, right below output, we're going to say a list of team model teams equals team file name dot full file path dot, let's just make sure we copy the pattern from up here, dot load file dot convert to team models. And that takes in the people file name, which we don't have. That's this right here. We don't have that yet, so we need to pass in the people file name. This will get a little bit long. So what I'm going to do is actually this. Before every dot, I'll hit enter so we know what each step of the process is. So we'll pass in the people file. And over here, we will actually grab this entire portion and paste it at the end of our signature to say we want that people file name as well. And we'll pass that into our team, convert to team models. And now we've got a list of our team models. So now we can do the same thing we did here with our people, only we'll do it with teams. So this is a little bit, we got a little bit of a space problem. So what I'll do is I'll copy this. And I'll put it in comments down here just so I see it. So we can say tm dot, this is going through the, right now the teams. Okay, so entered teams. So therefore we can say tm.enteredTeams.add And here we say teams.where x equals x dot id double equals int dot parse. This is the ID. And outside here, we need to say first. And so what that does is it looks through our list of teams, says find me the team with the ID that matches this ID. If you find it, give me the first one. Let's put that into our entered teams, just like the pattern up here. The really convenient thing here is, since we did this load teams right here, the work is already done for all the parsing of not only the team, but then every person on the team being added to that model. All that work's already done because we did it up here. We're just taking that to the next level by using this list to hydrate our tournament model. So really, this line of IDs doesn't just represent one object each. They represent an object that also has a list of objects inside them. You would think we had to do some kind of multi-level to get to all those, but we don't. We just need to call actually this line right here to convert to team model. That does the multi-level. This is where code reuse is so helpful, because we're not reinventing the wheel of converting stuff over to models. We do it at the base level, the simple level, and just keep adding on to it until we're at this more complex level. So now I look and see I have to have prizes. Well, I'm going to pass in prizes information. Let's start with the file name. Prizes file. So let's pass in the prizes file. And over here in our declaration, which is getting long, which we can do on multiple lines if you want to. Makes more sense now that it's kind of huge. We're going to say string prize file name. And we'll take this. Do the same thing. We'll say list of prize model. Prizes equals the file name dot full file path dot load file dot convert to prize model. That takes nothing in, therefore that's all set. Now we can come down here. Our next for each, we're going to say string array prize IDs equals calls for, not for F, just for, dot split on, again, the pipe char. It's a char, not a string, because it's surrounded by single quotes, not double quotes. And again, just double checking, yes, prize is in the fourth, or the call for, which is actually the fifth one. Now we do our for each. I'll scroll down a little bit. For each string ID in prizes or prize IDs. Notice I'm using the same variable name as up here, and that's okay because this string ID, the scope of it is one loop through the for each, and then it gets overwritten by the next item. Once the last loop is done, we get down to here, all of these IDs are no longer in scope, the scope being this right here, these curly braces. Therefore, there is no variable ID by the time you get to here. Therefore, I can use the same ID name over and over again and keep consistent with how I do things and not mess things up by stepping on toes. So I can say tm.prizes.add prizes.where x equals x.id equals int.parse id dot first semicolon. How do I know to do that? I just follow the same pattern as up here, which is the same pattern as up here. We're not duplicating code because this pattern right here is the same pattern, but with different items, prizes versus teams, and we're adding them different locations. So it's not really duplicating code. You could probably create some sort of helper method that might get you a little closer, but this right now is as close as we need to get it. So now I've done all the columns except for the big one, rounds. And I'm actually going to save this one for our next video. So I'm actually going to come down here and say to do capture rounds information. And the reason why I'm going to not do that now is for the same exact reason why these up here are so easy to do. I am reusing code from a previous call. I already needed teams before, therefore I've created this method. Well, down here, we haven't created any of the methods that I'm going to need because we have, let's look at our database here so we can see kind of an example. We have the matchups and we have matchup entries. Matchup entries, if you notice, have matchups and they have parent matchups. So all of this is going to get pulled in and linked and all the rest. We haven't created the matchups yet. We haven't written that table. We haven't written to this table. So we also haven't created the methods to read from either of these tables and to rehydrate this information. Therefore, if we're going to do this now, capture the round information, we'll need to create all those methods, and that could get kind of confusing. So instead, I'm going to wait to do this until after our next video when we actually create the matchups and the matchup entries. So I'm going to save this as it is right now and pretend like this actually worked, where we pulled this in, populated the tournaments model, because it did to an extent. It did to the same level as SQL did. And that's really all we need, because now we need to add a new entry. So do the same thing here as up above. So if we're going to copy this and paste the pattern. So we're going to say if the tournaments list of tournament model, if that count is greater than 0, then order by descending by the ID, take the first, get the ID, add 1, that's the new current ID, just like up here. Now we can say the passed in model, model.id equals current ID, and then we can say tournaments.add model. So I took the passed in model, I gave it a valid ID, I added it to my list of tournaments, just like up here, and now we're going to save to team file, or down here, teams.save to tournament file, and we need to pass in a bunch of information. We're going to pass in probably a team file name, and we're going to pass in the person file, the people file name, and a whole bunch of other stuff. And we won't call it teams dot, we'll call it tournaments dot. Tournaments dot save to tournament file. And this is an extension method that we're going to put into our text connector. Oops, into our text connector processor. And before you go on, note that this has to return a list. We haven't done that yet, so return, not here. We're going to say output.add down here, output.add tm, and then down below that, we're going to say return output. So I kind of interrupted our flow from it, but I saw that error. I wanted to fix it right away. We have a list of tournament getting returned, and we weren't returning anything, so we have to return output, which is our list of tournament model, but we also have to add to output each time we create that tournament model entry. So I took care of that. So now we have this save to team file. Well, we're going to create this save to tournament file. Public static void save to tournament file. This list of tournament model, and we'll call this models, and we'll pass in nothing for now until we need it. So again, following the pattern, we're going to say list of string lines equals new list of string for each tournament model TM in models lines.add. We'll do our $, double quotes, put a semicolon at the end, and come back. We'll start off easy. tm.id, comma, no space, tm dot tournament name, comma, no space, tm dot entry fee, comma, no space. And then here's where it gets interesting. I'll just put empty string for now. We'll come back to that. But we have, let's grab this right here. So we have this list. I'm going to paste this right here. So 0 is ID. 1 is tournament name. 2 is entry fee. 3 is entered teams. Well, we don't have the entered teams converter yet. We create this people converter, and it just converts everything based upon, in this case, pipe, which is perfect. So we're going to create the same kind of thing, where we'll say private static string convert, and this is not going to be a people list, it's going to be a entered team, so team list to string, a list of team model called teams. Again, follow the same pattern. In fact, I'll copy and paste this entire thing. And if you can do that, or get close to doing that, you know that you have a refactor opportunity, and we do. But we're not going to do it now. We'll do it in our refactoring video, because right now we're going to follow the same pattern, and it's going to work. And so I'd rather follow the same pattern and have it working than try and figure out some kind of complex thing to make it do things a little bit better. So we're going to say if teams.count equals 0, return empty string. Otherwise, for every team model, we're going to call this T just to make it a little more understandable. We're going to take the ID and add the pipe at the end. And now we just do our substring to remove the last pipe, return that output. So again, this and this are practically the same thing. They're different in they use different models. And they pass in different list of models. So they're really close, using the same property. So in that case, what we're going to do is we're going to wait until the end and refactor that later, because it is a little more complicated. We'll get into doing generics, and that's always a little bit fun. And we'll work on how we're going to do that while getting this ID. That's can be a little more complicated, but we're going to do it because it makes sense. But for now, if it's either too complicated for you or if you're unsure how to do it, just do this. I mean, this works. So why knock it? Sure, you can make your code a little tighter, a little neater, and made a little more robust by creating one generic method. But to do that at the expense of not getting your application done is foolish. So get this working, get it right, and then come back and make it better. All right, so follow the pattern, convert people list to string, pass in the correct list. I'm going to do the same thing here and say pass in tm dodge entered teams. And now we can continue on with our string. Now it's this point that you realize that this string right here is going to keep going. That's getting a little bit too big for our screen. And so I want to make sure that I put some line returns in here just to make things a little more readable. The problem is if I do that, things turn red. And so the way to fix that is to actually add our string literal character, which is the @ symbol, after the $sign. So